the main thing for today. Yeah, we'll just wait a couple of seconds for confirmation. Okay, awesome. Yeah, so all right, so here's Bobby for you.
Let's do that again. Good morning. All right, well, hello everyone here in Bengaluru, everyone online. It's an absolute honor to be here with you in this beautiful city, amazing culture. It's just been a wonderful few days here already with Music Hack Day, so I'm very excited for today. I wanted to say maybe a few words about the Audio Developer Conference. I would imagine that, show of hands, do you know about the Audio Developer Conference, the yearly conference? How many have been to the conference? Show of hands. Yeah, great, fantastic. And then how many have joined online in the past? Many more. Great. Well, I invite everyone to join us in our 10th annual coming up. We'll be in Bristol, UK this year. The dates are already out on social, so you'll see some of the save the dates. If you subscribe to the newsletter, you'll get more information as well. That will be an online and in-person hybrid again, so we do look to expand the online presence, so I think that'll be just an amazing conference. So why are we here and doing these ADCx events? We launched them last year in San Francisco, and the idea is we want to start doing more regional events and kind of spreading the goodness of ADC and what we've seen. When the community comes together, you make new friends, you network, you make new companies. I've spoken to so many of you that will come to one ADC, have an idea, and by the time you come next year, you already have a company. And usually by that second or third time, you're presenting and you're growing your company and you're growing your ideas, you're growing your network. And this idea came about, we should start doing more events and do more regional events and partnering with events that are happening in regions as well, like Music Hack Day India. We were thinking that what an amazing opportunity to bring a hackathon together with the one-day pop-up. So we look forward to doing more and expanding into more cities. And with that, I want to say thank you to Prashant. Thank you to Manaswi as well. Without them, there would be no ADCx India. There would, in fact, without the community members stepping up and wanting to do these regional events and helping, this is the way we'll continue. And I hope that this will become the first of many. And I hope that you'll all spread the word and we continue coming together to do these events. I want to thank our sponsors. We do have some wonderful sponsors that made this happen. So we've got Juice, Pace, Dubverse, and Embody. And Embody is also here to present as well. So very exciting to have not only the support of the ADC team, but also sponsors stepping up regionally as well, because they make this happen too. So I look forward to meeting all of you during the breaks. Let's network, let's become friends, let's do amazing things, and let's have a great time. A round of applause for Tom. I promised Tom I would not ask him to come up on stage, but I will point out Tom, and Tom is going to wave back there. So Tom heads up Juice. Now that you see where Tom is, I expect you to inundate Tom with tons of Juice questions, which he's already smiling about. Lovely. Have a great day.
Awesome. Thank you so much, Bobby. So we had an amazing hackathon on the last 2 days, on 5th and 6th of Jan. And we thought, okay, before we begin the event today, let's give you a glimpse of what has happened. So I'm going to share a quick video. So that, just a second. So you can have like, yeah, actually there's a music in this. So we'll try making that happen as well. So just a second. Sorry about that. Okay. All right, so that was basically the Music Hack Day India, and the idea for us was to bring everyone together and let them come up with some things on day one, and then try building something together. And we actually also have some of them who will be presenting today towards the end of the event, and you'll actually get to know some products that are already ready. So it was an amazing set of events, and we really appreciate everybody who took the time to participate. So a quick round of applause for all the Music Hack Day participants. Awesome. So I think we can start on the set of talks. But before we do that, it's a request for everyone to just keep their mobile phones in silent so that the speakers do not get disturbed. And the talks are going to be very quick, around 18 minutes-ish, something like that. So if you have any questions, please keep them ready. After the talk is done, we'll hand over the mics and you can ask your questions right away. So yeah, all that is in place. So with that, I think we can begin with the first talk for the day. It's by Gregory Pat, and he's going to give you some visibility into GeoShred and all the other things that he and his team are working on. So I'll just stop sharing my screen. So the audio didn't come from the video. So this has to be. Awesome. So now this is the system. This is the template. Yeah. Okay, you can do it. You can hide the screen.
So it looks like it won't let me share my screen while the other screen is being shared.
So all the speakers who are here, you can please come closer so that you are prepared for your next talks. So whoever has the talks next, I think you have the schedule, so you can be in the front rows as well. Yeah. So I think acts and experiment with sound effects.
Okay, hello. Can you hear me? Okay, so my name is Gregory Scandalis, and I'm the CTO and the CEO of a company called Monforte that makes a product called GeoShred, and I'm not really going to talk much about GeoShred today. I'm going to mostly talk about modeling South Asian and Chinese instruments in GeoShred. So just a quick outline of the topics. We're going to go right to the demonstrations at the very beginning because it's good to see the demonstrations of what the instruments are capable of. Okay, so I'm just going to go back to the beginning. Actually, I'm going to go right here. So this is a quick outline of topics. So let's start with the demonstrations. I was going to have the demonstrations at the end, but it's really good just to hear the musical demonstrations at the beginning. I'm going to go through a brief history of physical modeling synthesis, which is this technology that's used to create all these wonderful South Asian and Chinese musical instruments. And then I'm going to talk about this technology called MPE for MIDI and how that relates to modeling. It's really a very synergistic relationship between MPE MIDI and modeled instruments. And then I'm going to talk about some special considerations for modeling South Asian and Chinese instruments, and then we can have some quick questions. Okay, so some housekeeping. This presentation has a lot of material into it. I may not be able to present all the demonstrations, so if you want to get a copy of the presentation, you can go to my website, moforte.com, and just go to news. And the first news topic is going to be the deck for this presentation as a PDF, and all the links for the sound demonstrations are in the deck. Okay, Brief attribution, physical modeling collaborators. So the physical modeling technology, Julius really is the father of all this technology, Dr. Julius Smith, who's the second position here in the image. He's a professor at Stanford. And about 10 years ago, we started working with rock star Jordan Rudess. We call it the rock star and the professor. And then Nick and myself have been working with Julius for over 30 years. There are some additional collaborators. We've been working with a company called Audio Modeling. Lele and Stefano have done a tremendous job of taking Julius's work and translating it into realizations. And then last year we met Sutu, who has been doing a lot of the instruments that you will hear in the demonstrations today. Very briefly about me, I'll skip over most of this, but I have been doing modeling of the physics of instruments for a long time. I did it as a part of my physics degree 40 years ago. You can see a movie here that I made back in 1982, and we'll go forward. We'll see a little bit of a pluck string. Hey, that's nice. And we'll see some vibrating membranes. And so it's very nice that this technology continues to exist. Okay, let's go right to the audio demonstrations, about 2 minutes. Okay, so those are the audio demonstrations of these wonderful South Asian and Chinese instruments. As I said, I won't talk much about GeoShred, but it is a framework for modeled instruments. We've dedicated ourselves to only doing modeled instruments, no sample-based instruments. There's also modeled effects. Currently there's 22, and there are currently 33 physically modeled instruments. Expect this number of instruments to grow over time. Okay, so let's dive into a brief history of physical modeling synthesis, which is the technology that these instruments were created with. What is physical modeling synthesis? So any method for generating sound in which a mathematical equation, a model of the physical source of sound is used, is physical modeling synthesis. And typically we're trying to solve the partial differential equations for the acoustic situation. And when you have a physical model, any gestures that are used to interact with the real physical system can be mapped into parameters. And so this can be used for expression, and you wind up with a completely different performance experience, very emotionally driven, than you would have if you were only using samples. One thing people ask about is physical modeling a single little algorithm that I can put on my DSP? No, it's not. It's actually a collection of different techniques. Each technique is specific to the sound generation process. So what we see here is a taxonomy of various modeling areas. This is called the Horn-Bostel-Sachs classification, and there's many different kinds of instruments. And each of these instruments actually has a different modeling technique. So let's go back into the history. Let's go back to 1937, 1939. Homer Dudley was attempting to model the human voice, but he was using analog circuits, really radio circuits. And he developed this system called the voder, and it had a keyboard on it, and the operator could speak using this keyboard. And I'm just going to play a little brief video.
The machine uses only two sounds produced electrically. Let's see how you put expression into a sentence. Say, she saw me, with no expression. She saw me. Now say it in answer to these questions. Who saw you? She saw me.
Okay, so that's 1939. So in 1961, a team, Kelly Lockbaum, came back to the same idea of trying to model the vocal tract. The reason they wanted to do this is they were looking at voice compression on telephones, and they came up with a digital model. In fact, this is the first digital model. And they modeled the vocal tract as a series of cylinders. Each cylinder could be a different size and length. And so that was a set of filters that were cascaded. And by appropriately controlling those filters, you could create the sounds of the human voice. And here we go, 1961, Max Matthews, who is a professor at Stanford Karma when I was a researcher there. Max figured out how to control this model, and he did a version of the song Daisy Bell, and I'll just play that for you.
Daisy, Daisy, give me your answer too. I'm crazy, all for the love of you.
So that's 1961. It's really the first digital realization of a physical model. Max happened to be friends with the science fiction author Arthur C. Clarke, and in the movie 2001, this recording that Max made was referenced by the computer HAL as he was being shut down.
I'm sorry, Dave. I'm afraid I can't do that.
Daisy, Daisy, give me your answer too.
Very nice tribute from Arthur C. Clarke. So now we get to the 80s and the late 70s and the 80s. And there were a pair of students at Stanford, Karplus and Strong, who discovered what they called the self-modifying wavetable synthesis. And this actually is a physical model. They didn't realize it at the time. They licensed it to Mattel for toys making sound. And David Jaffe, who's a student there, wound up doing a composition using this model. A computer music composition. So David and Dr. Julius Smith wound up partnering, and Julius looked at this and he said, oh, this is actually physics. This is a solution. This is D'Alembert's solution to the wave equation. And between David and Julius, they came up with all of the mathematics that is used today with this type of physical model, and they identified all the different ways that it could be set up to perform like a real instrument. And when the next machine was launched in 1988, this model was the introduction to the next machine. It was running on the DSP on the next machine, and I'll play a little brief bit from 1988. Oops. It's a little bit of Bach, all physically modeled. So you move forward to 1985, and Julius continued to work on physical modeling, and he came up with this algorithm that he called digital waveguide synthesis. and it was identically D'Alembert's solution to the partial differential equation for a string. And it was licensed to Yamaha, and Yamaha did tremendous things with it. There was an instrument called the VL1 in 1994, and the VL1 had a shakuhachi that is still a desired instrument, and a tenor saxophone that's still a desired instrument. All modeled. So, other physical modeling that was going on at Stanford is Perry Cook created the first singing physical model in 1990. And Scott Van Dyne worked on a thing called coupled mode synthesis, which I love this algorithm. It models percussion sounds, and you can easily take a recording, get into MATLAB and grab some data and calibrate some filters, and you can come up with something as powerful as a percussion ensemble. That's a Tibetan bell. And one of the other students at Stanford realized that that modeling the filters and the synthesis process on an analog synthesizer was also a form of physical modeling. In fact, at the time, 1996, there were no digital models of analog synthesizers. We take it for granted today because there's so many digital modular synthesizers. But Tim Stilson came up with how to model the Minimoog filter.
What we have here is Synth Builder and Synth Core from around 2000 running on my legacy Windows 98 machine. I've got a patch up and running on it. It's one of Tim Stilson's Moog VCF patches. I did this as an example. It's got some detuned oscillators in it. I'm going to play it just so you can hear it.
Okay, so at the very end of this research cycle that happened at Stanford, an engine was created that had 8 DSPs in it. It was called the Frankenstein. And all kinds of physically modeled ensembles were being created and performed and recorded at the time. And the thought was that physical modeling was going to replace what then was the pervasive synthesis technology, which was FM. Again, it's an ensemble, all done with physical modeling in real time. 1997. Okay. So a brief note about guitar models. They are typically based on extended car plus strong. In our own product, we have extended car plus strong. I do want to show this little image here because this is really nice. This shows how you can take actual recordings of, in this case, a guitar. So we typically grab a recording of every note on every fret on every string. And you get in there and you look at here, this is the spectrum. This is frequency increasing in this direction. And these are the partials, and the partials, the different partials are decaying in time at different rates. And so that's what calibration of a physical model actually means, is that what you're trying to do is design the filters that are in the model, a separate filter for each note, such that the partials decay at the same rate as the original recording. And it's a very successful way to model these types of things, and it's actually a kind of a form of compression. Okay, current state of physical modeling, and then we'll move on to MPE. So currently, starting in 1994, physical modeling started to become a niche. And what happened is there was a sudden drop in the cost of memory chips, and at that point, sampling was the main technology that was used for everything. And sampling is really good stuff, and it still exists today. But this technology called MPE, that we'll talk about in a moment, made physical modeling more viable. And that's because you could now have controllers that had multidimensional ways of controlling these models. And it's really been a tremendous win for physical modeling. At this point, also, there are many different physical modeling products that are on the market. So I want to talk briefly about MPE, and then we'll wrap it up. So MPE, it's a set of conventions built on MIDI 1.0. There are about 250 products that support it. And the spec was released in January of 2018 with a revision April 2022. And the MIDI 2 version of MPE spec will be published at NAMM in about 3 weeks. So MPE in a nutshell, basically every note goes through its own channel. That way every note can have its own expression. And there are 3 X, Y, and Z controllers that are defined for MPE, which means that every note can have 3 dimensions of expression, this is tremendously powerful when you have a model-based synthesis algorithm. So I want to talk briefly about one of those controls, which is typically in the X direction, pitch fluidity. And Mahesh Raghavan has made a nice little example for us to hear what pitch fluidity sounds like, but it's super essential, especially in South Asian music. Western music handles pitch fluidity in a different way, but listen to what Mahesh has done here. So, though it's not a part of the MPE spec, most MPE controllers have something called pitch rounding. And what that means is when you stop moving on your performance surface, the note drifts into being perfectly in tune in the temperament that you're currently playing in. So for example, a lot of the South Asian players are using Carnatic intonation, and so the pitch rounding is rounding their notes into the Carnatic tempered notes. Okay, so let's see, I'm going to skip over this one. MPE plus model synthesis, it's a big deal. And basically MPE is what is enabling modeling to move forward today. So together with MPE and modeling, the whole is greater than the sum of the parts. Okay, last slide and then we'll go to questions. So some special modeling considerations for the South Asian and Chinese instruments. So you heard the instruments at the very beginning. So the instruments, the sitar, the vinas, the sarod, the sarangi, which is bowed, they're all string models. They support strumming so that you can strum those strings. There are a separate set of strings which are sympathetic resonators, just like the real instruments. And they all have models of a parabolic bridge so that the string bounces into that bridge the way it would on a sitar or a vina. And they all support, I put strumming in here twice, the bansuri, the shanai, the naswaram, the dizi, the suana. They're all blown instruments, and they all support being overblown so that you're getting this vast range of harmonics as you're playing at different velocities. And you can actually overblow them up to the next octave as well. The pipa is a very interesting model. It embraces a type of performance technique called tremolo lunshi. And this is the technique that you heard in the pipa where it goes delelan, delelan. It's a kind of a bouncing tremolo. And then finally the arhu, the zonghu, the gahu, they're all bowed instruments, and they are calibrated using the calibration mechanisms that I talked about earlier so that they sound just like the original instruments. Okay, that's it. It was fast. Are there any questions?
Hi, Pat.
Hi.
Pat. Oh,
Hello.
Check.
Yeah, thank you for typing it in. I'm not hearing the questions, but I'll repeat it for the online audience and then I can go ahead and answer it. Okay, the question is there a way to incorporate extended techniques into the physical modeling, like extending the range or electroacoustic performances like flute plucking, etc.? That's a very interesting question. Um, the latest release of, at least in you can do this in a model in general, and I'm trying to not talk too much about GeoShred, but in the latest release of GeoShred, there is a mechanism for strumming. And you can strum the flute, and you can strum the Shania, and you can pluck the Shania. And so, yes, it's possible to perform the physical models in ways that are beyond the realistic instruments. The question is, hi, my name is Harish. We have come a long way since the last century, but there still seems to be a gap between the model and the real instrument. Yeah, I'll agree with you on that. Could you highlight the current gaps that need to be filled in order to achieve realism in modeling? Yeah. So many folks know about this thing called the uncanny valley, where it's mostly talked about in terms of computer graphics, where if the computer graphics don't match reality, then it feels kind of odd and creepy. The same thing happens with these models. That where if the realism is not there, then you start to perceive it as being a little bit creepy. That being said, I think the work that the audio modeling guys have done, I think they're really close to sounding like reality. Their latest release is about creating ensembles like, 3 violins, 3 cellos, 3 violas, 3 upright bass. And they're working on movie soundtracks. A lot of their customers are working on movie soundtracks where the realism is really required. So I think the techniques that most of us are working on now are ensemble-based techniques, where it's not just a single instrument, but rather we're now starting to simulate orchestras. And what's really interesting to me about this is what we were doing in 1997 at Stanford with our engine. It's just now becoming possible with powerful computers and big ensembles of lots of VST or plug-in instances. In the peculiarities of South Asian music, you talked about pitch rounding. Could you talk about other such unique peculiarities? Okay, so the pitch rounding is actually independent of musical paradigm or culture. But if you look at some of Mahesh Raghavan's videos, you'll see that he performs these gamakas that are just really, really beautiful and very expressive. And he's actually writing the pitch rounding. He's moving his hand in a very discrete way, and then he's stopping and letting the pitch rounding take the note back to the carnatically tempered pitch. And he's exploiting the pitch rounding actually in order to perform his gamakas. And so that's probably the best example of a unique peculiarity that we don't see in Western music, but it's very pervasive throughout South Asian music. Okay, thank you. Bye.
For the next figure, and he's going to
Hello. Is my voice reaching? Yeah, perfect. Yeah. Presentation. Ah,
Hello, can everyone hear me? Yeah, nice to see everyone. Been a cool couple of days. Hope everyone's doing fine. So, I will be doing a talk on the Indian roots of generative music. And when I mean generative music, I mean all sorts of things like live coding, algorithmic compositions, little bit, but a little bit about me first. So, my name is George. I'm in the final year of my design degree at Shrishti, and that's where huh? So, is it true? I think it's moving. No, I think it's stuck. Oh, yeah. So sorry about that. Small hassle. So my name is George. I'm still a student at Shrishti, Bangalore, where I'm doing my final year in industrial design. At Shrishti, I had the opportunity to really deeply explore the world of new media, creative tech, computational design. Lovely 4 years, honestly. In my third year, I spent a year with Yashash Shetty at the Indian Sonic Research Organization, where I worked with sound artists from you have the Zurich University of Arts, a couple of them from NYU. And during my residency there, I was working with neurotechnology. and specifically brain-computer interfaces. Now, like after that, I kind of like work with a couple of different things. I like to make new media art. I try to look into like generative geometry now, computational geometry. Part-time, I work as a haptic design technologist for Compostable Umwelten, where we try to make things like haptic compositions. Trivik's doing really cool stuff at the company. So if anyone's interested in neurohaptics or neurotechnology, please check them out. But let's move on. It's an open-ended question I'd like everyone to ponder over, because that's a question I've really come across over the past 2 years of both academic and independent research. That is there really like a validity to taking an Indian approach as opposed to like a Western one? Because we're all familiar with 12-tone systems, you're all familiar with bar sheets, 4x4 signature time. But does that work? Or could we try something else? Because it's Music Tech India, it's not ADC Korea or France. So why not try, if you're sitting on a bedrock of knowledge, why not try an alternative approach? So that's what I want to do with this presentation today. It's to hopefully build a somewhat valid argument, but I'll let you guys answer that question hopefully after the entire presentation. Couple of disclaimers. This became a much bigger topic than I anticipated. So these are like tiny rabbit holes I'll be presenting here, but the actual topic could be potentially way more vast than I expected. So feel free to check out my work later. I will update quite a bit. So let's go. The first thing I want to talk about as the bedrock of music is time. So when you look at like Western and Eastern cultures, our topic of time, like our understanding of time is actually very different. So usually, I think many of us are familiar with the one on the West, like on the left, which is like a standard time signature on a musical sheet. And the thing with a lot of Western time signatures or how the West thinks about time is very linear. Like you move from point A to point B. And that makes sense with how they conceptualize music. But when we look at like Eastern concepts like in raga or in Chinese timing examples as well, it works as a principle of generative cycles where the musician kind of bounces across the entire framework. And that allows for some very interesting possibilities when you think about it in terms of computer music or like sequencing. So a couple of you have used VCV rack, I assume, or some of us use maybe Super Collider or Sonic Pi. And like the Tala system, you keep returning back to the same initial note like a cycle. So that allows a lot of like generative possibilities. And it's interesting why we don't think about it in this term, in this sense, because we already have people do this in things like tidal cycles, where you still have the same cyclic rhythm that people kind of return to, and it reincarnates like a wave. If you've seen the Domyun performances in Tokyo, you see like artists like maybe Atsushi Tadokoro, he also uses tidal cycles and he implements actual tablas and konakols in that. And he really makes use of that cyclic rhythm. When you see Indian artists like Koparzi talk about like tidal, it really changes the way they think about music. But that's already inherent to the Tala system or how traditional musicians always talked about Indian music. So that is one way to think about computer music and Indian music as well. One sec, I'll just get it. But yeah, even including improvisation, you see people do things with jazz on things like Bespoke, where they computationally improvise and you have other instruments react to it. So I think like improvisation and cyclicity is a very important part of computer music and Indian music. And that's one interesting thread. Let's move on to the next. Now, this is my favorite because I know I talk about neurotechnology, but long term, I'd like to work with spatial audio and immersion. But the origins of the universe in a lot of like Indian philosophy would mostly be something called the Shabda, which is this initial primordial sound that architecturally or like morphogenetically creates the universe spatially. So they don't think of it in terms of like stereo, they think of it in terms of 3D space. And that has a lot to do with like the metaphysics or cosmology of ancient India, where they think like it's like a base ground where things emerge from. You see that happen in instruments such as the tanpura, or you have an ambient drone string in the sitar, which creates this background spatial noise, and then the melody emerges from that. And what's interesting with where some of us like work with things like music for healthcare and music for mental health, is that this idea that drawing people into a phonosphere or a soundscape, especially a 3D soundscape, can actually create the sense of the sublime. Now, the sublime is kind of different from the sense of beauty. When you think of beauty, it's something like, oh, it's something pretty. But sublime is something like if you see a huge valley, you see that sense of like space. Or maybe if you look at the night sky, that sense of immense boundaries kind of makes you look at it with a sense of awe. And that kind of tends to dissolve your ego. And that's what the ancient Indian musicians try to do with their instruments. Now, Maslow, before he died, like a couple of years before his death, he actually postulated that self-transcendence itself was a need to be fulfilled. And that is something that Indian musicians also thought about. If you look at like ancient aestheticians like Bharata, who wrote like the Natya Shastra, the first Indian book on music and aesthetics and stuff, that was what he wanted to do. So you take people into the simulation and then you try to dissolve their ego. Let's look at something like, I'm sure everyone's familiar with the Las Vegas sphere, and that huge sphere, you have a lot of displays and stuff. And one interesting thing when you look at social media reactions to this is that a lot of the visitors said this was something like a very spiritual experience. Not just with the Las Vegas sphere, you see that happen with a lot of immersive media. This kind of like, oh, where am I? And what is this? So yeah, I think this has a lot of potential when you look at the Metasounds engine or like spatial audio in like Unreal Engine. You can create these very powerful ambient soundscapes combined with a visual feedback. I think there is something very powerful to be evoked here. So that's interesting. Let's go to the next one. Discovery. So discovery is also a very interesting thing. So I'm going to take you through something called byte beats. So byte beats are kind of like the lowest level of live coding, where people actually write these wave equations and describe like a calculation, and that actually creates a sound. But byte beats are not created. The people who make them say they discovered them in the space of the computer, and no one really knew it was possible to like write tiny C programs and then make entire sounds out of a one-line program. And it was actually created, or like discovered, I would say, by this guy named Wisnut in the early days of the demo scene. And this is how he described coming across byte beats. And no one really expected it. It kind of sent shockwaves throughout the entire demo scene community that such a thing could happen. Very interestingly, ragas are also said to be described the same way. So people do not, like Indian artists, they don't create ragas or they don't write or calculate ragas, they discover them. And you could have an infinite amount of ragas possible, and you actually have musicians build or discover their own ragas. Why is this the case? I am not completely sure, but it has something to do with the way they conceive the universe as this like combinatorial space of possibilities, like kind of like hyperspace or a higher dimension of things where you can draw inspiration from. I think when you think about things like latent space in AI music or the new stuff with stability audio, something interesting to think of there. So yeah, sorry. This is one of the most favorite things I've come across. So Irv Wilson was this guy who studied something called Zen harmonics, which is like, how do you think of tuning systems outside of standard 12-tone systems? Like, so you have C, D, E, F, G, C. That's the standard 12-tone system of most Western music. He tried to create alternate tuning systems, which means alternate music systems. So Indian music uses one tuning system, Chinese music uses one tuning system. So this guy tried to create stuff that actually generates tuning systems. And he actually did this a lot later in his life. But in his early life, he used to read like entire papers on Carnatic music. If you look at his website, you see all these papers written on South Indian ragas and South Indian Carnatic music. So this diagram you see here is actually the actual calculation format, where he takes a base frequency and then he kind of generates the entire tuning system from one single frequency. So like 400 hertz, he then builds the entire tuning system. And this is actually a 2D representation of a 3D sculpture of a 4D scale. So I find it very interesting how he really took the soul of discovery from Indian music and then built this entire corpus. If you're interested in what he did with tuning systems, there's a documentary called Surfing the Sonic Sky. I think it's also a website. Really cool stuff out there. So bonus stuff. This is just like not really like principles you can take off, but something interesting maybe you could dig into it deeper. So Pingala, who is kind of like rumored to be the brother of the grammarian Panini, I think a couple of you are familiar with him. So he actually created this like binary syllable-based generative rhythm system for poetry. And he actually used like Fibonacci sequences when he created these rhythms. So I think there's something interesting there as well. It's very interesting to see how a lot of theorists took very computational or computational analogous approaches when they thought about music and rhythms and stuff. This I found kind of funny. So you on the leftmost, you can see one of those very dubious Facebook posts where you see like ancient India, like high profile science and stuff. I later saw a touch designer video that like actually lets you create this kind of like architectural music or architectural like waveform patterns. So if you're thinking of things like in VR, maybe you can actually create sonic temples or real archi music. And I think that's something you can actually do with a degree of serious intent. The third one's an actual example of archi music. So in certain places like the Vitala temple in Hampi or in the Velayappa temple in Tamil Nadu, you actually have these pillars, they're called Ranga Mandapas, but these pillars actually are said to be musical. And when you tap them, you can actually hear a musical note. So we don't know how they did it, but it seems that when you talk about ancient India, they really took the principle of architecture and archi music very seriously. So finally, the stuff I'm doing right now, I think with more obscure languages like Uterpi, you kind of can do things like self-similar melodies, which is like fractals. Fractals are something you see pop up in a lot of Indian art and Indian music. Kind of because like the ancient Indians kind of thought of holonomics or holography, where everything is a self-similar replication of God at some level. So you can also do this in Super Collider. Super Collider also has some like L system-based fractal music generators. So you see a lot of potential there. I think that's it for now. Hope this has been somewhat convincing, because I think there's a lot more to do out there. I think like there's some stuff in tantric art as well, where you have like geometricals. That's something I'm doing on my own, but you can look into audio visual and stuff. There's a lot of work to be done in like audio visual when you talk about Indian music. So yeah, questions? Anyone?
Hey, this was super interesting. I had a question. You mentioned Tidal and like tools, tools like that. So there are tons of generative music tools out there. So in your research, what have you seen is like are missing components in these to be able to create Indian-oriented like generative music?
So a lot of so very interestingly, you can see like kind of like Easter eggs of Indian music in a lot of generative systems. So if you use Sonic Pi, you will see a tuning scale of Purvi or Bhairavi. If you use VCV, I'm sure a lot of you use, there's one sequencer. There's a macro oscillator, or I don't know which one is it, the random sampler that everyone uses. I think that's also called Tidal in VCV. but you can actually create Bhairavi generatively in VCV there. I think in Unreal Engine's meta sounds, you can kind of use Bhaskara's sine tone formula to create music there. But the problem is it's all very dispersed. So you have like one idea here, one idea there. It's not in one system, right? And people can't make up their minds. So you have a lot of like Western researchers take one idea here and they think of it very interestingly. But I think if you're trying to think of something like completely indigenous, it requires a lot of intent. So maybe if we kind of integrate all these concepts into one platform or one system, that would be, in my opinion, truly indigenous. If you ask me if there's anything out there that really replicates indigenous systems, I don't think it exists. Yeah. Yeah. Yeah, even there's this app called Wilsonic where you can build your own tuning systems, but it's not really the actual, like, not to the degree that Wilson himself did it. So
yeah, I mean, you can also take the Scala archive,
yeah,
pull out things from there, stick it in.
There's a lot you can do with all these concepts. I mean, I hope this is just what I found over like 1 year. I'm pretty sure there's a whole lot more out there which we don't even know exists. So.
Yeah, so I mean, like these little pockets of information exist. You just have to put them together. It's not, integrated into one thing already. Yeah.
Yeah, exactly.
But the tools are out there. It's all I can tell you.
Hi. Really informative presentation. So I just want to know one thing. Like when you were talking about Indian rhythm, tal, I can sort of imagine a generative possibility in that making music because it's a cycle, it doesn't change, it goes on forever. Whereas when it comes to rag, whatever I've seen while making music, it's generally like just like how he said, make your own scale. But rag is not exactly a scale. It's got specific characteristics like Vadi, Samvadi, certain weight on certain notes, or even the way you move. It's not, you don't play the whole scale. You move in specific style of the rag, which could have same notes in another rag, but that is again different the way they approach it. That's the reason why classical musicians spend decades understanding the whole quality of the rag. So did you find anything moving in that direction in your research or?
I think like if you try to directly, so the one big problem with Indian art and Indian music is it's kind of fused with the religious nature of worship. So that is kind of a very spicy topic as someone who's not from that community. How do you manage or navigate that? But the thing is, Indian music is a very, what you said about rag is exactly correct. People try to think of rag as a scale. Even when you try to learn Indian music in Bangalore, they try to conceptualize it as a sarigama patanisa on a, like that same Western notation, but there is no analog to rag, or like rag is not an analog scale. It's its very own thing. That is something I would like to actually fully explore because I think there is, again, I believe there's validity to that. One interesting thing about rag is how rag actually means to color. So it actually means color. So the entire intent of a rag is to color your mind or to create a sensation of color. So they didn't think of it as just sound. It was a very multimodal way of thinking about music. So I think that, again, it's a huge topic. It's not something you can uncover in a year or two. Probably decades worth of real intentional research has to be put in.
So that is somewhat, it gives you a language to speak in. In Tidal, you can set up these Markov chains where you are only giving certain symbols and then it completes phrases based on those symbols, sort of a thing, which is kind of what the idea is, that, okay, move in this direction and then move in this direction after that, because that's what makes sense. That's the aesthetic of it, or that's the language of it is.
I also think it's important to not take it like stick to the syllabus. I think we've all been taught as kids to stick to the syllabus a little too much, and to be creative, or if you want to think of something cool, you kind of have to step out of the line a bit. So it's not, you can't just follow it by the book and expect to create. Because then we'll be stuck in the loop of creating religious music and it won't be something that moves beyond. A lot of people, when I ask them, why do you not listen to Indian music? It's beautiful. It's beautiful music, but it's frozen in time. And I think it's time we unfreeze it and move forward with something more interesting. Yeah, it's not my opinion. I think it's something that's eternal. But I'm talking about like 20-year-olds or 21-year-olds. They're not. Yeah, true. I completely agree. But it's, again, you can't argue with the public, right? Yeah, exactly. I would argue for it. I 100% am willing to die on that hill. But then you have to also think. I'm just saying we have to think of it. We can't just be sticking to tradition too much, a bit. That's what I think. That's just my opinion.
Hey, thanks for the interesting presentation. Here.
Oh, yeah, sorry.
Yeah, so I just had one question. So you briefly mentioned about music for healthcare, right? So
Yeah.
I right now work in the healthcare industry as a project manager. I do have an interest in these kind of areas where, music, audio, tech. So I just wanted to know from you, from your experience, what are the different possibilities out there? What are the researches that are happening in that space, audio?
I may not be the best person to talk about music for healthcare, but I think Nimans is doing a lot of cool stuff in their music cognition lab. So right now in the head office at Bangalore, there is a research group that looks at the perceptive or cognitive aspects of music. I don't think it's necessarily Indian music, but then 2 weeks ago, they wanted tabla players to test out stuff for their experiments. So I think they're doing really cool stuff. So you should probably reach out to the music cognition lab. When you talk about music in healthcare, again, it's not something a lot of us are familiar with, but it's an idea taken very seriously as in research abroad. Like how you look at the cybernetics of, especially with things like EEG and stuff with brain-computer interfaces. So you can kind of auto-regulate your own mood-based systems based on visual feedback or audio feedback. So I think when you look at EEG or biosignals and music, something to explore there. I'm not the best person to ask on this. I'll ask about this.
Thanks.
Hello.
I think there's one more. Yeah.
Hi, I really liked your talk. So I'm Madhumita and I also learn Carnatic music and I do give concerts. And I have some experience in AI. I didn't know about Markov models and how you could use that to kind of generate like scales and stick to the scale, but I do agree that a raga is more than a scale. So what is your opinion about generative Indian music? And like you said, I think the music that we have right now in Carnatic is very close to religion. It is tied up to religion. So maybe having generative Indian compositions on different themes, in the style of Carnatic music is probably something that would like draw in the youth. But what are some challenges that you feel exist in creating?
I think challenges, again, so you probably have way more experience with Carnatic music than I do since you are trained. I think the major challenge is just thinking. So I don't know why these things, like these facts, are so explicitly put out there. It's easy for everyone to access, and yet did no one think that there was something there? Why did it take time? Or why don't people have faith? I think it's a question of thinking more than, because challenges can be overcome. We have brilliant people in this country. So I don't buy it that whatever technical challenge that is there, I think that can be bypassed. But if you keep looking at the West, or if you keep looking at what's happening outside India, I think that perception that we have nothing to do with what the knowledge we have is something that has to be overcome. Ragas itself, again, I think ragas are way more flexible than a lot of other systems, especially like with the gamakas, you can kind of like not fiddle around with it. Again, I don't want to like touch it too much as a non-expert. So
you think that we can have generative music,
yes,
but with some kind of constraints?
Absolutely, I think there's potential for generative music, and I think people are already doing that. There are artists who work with generative ragas that I've seen in the country, and people who do live coding and in NYC and stuff, they take this stuff very seriously. So there is potential. It's just about taking initiative or maybe a leap of faith, I think.
Thank you.
There was a performance yesterday by Jagannath. He calls himself Jackbot at Shunya yesterday. And he basically demonstrated how you can have all the gamakas, all the right motions and all of that. Of course, you need to know what the aesthetic is. You need to know what the language is. And of course, your tool. So look up this guy, look up this tool also called Din is Noise. Pretty cool things in there.
That's wonderful. It's wonderful to hear that people are doing stuff like that. So yeah. So thank you so much.
So thank you so much, George. I think it has already sparked a lot of conversations, which can continue during the networking breaks as well. And we also have some more talks today, which will touch upon similar topics. So I think we'll have a lot more to discuss about as well. The next speaker that we have with us is Dharanapati Ratnakumar, and his topic for the talk is leveraging pruning and quantization for efficient real-time audio applications. So big round of applause for Dharanapati.
Will I have like speaker? Can you do it as a presentation? Just can you go? No, just yeah. Oh, sorry, no. Just one second. What do you want as a presenter? No. Great. So, good morning, everyone. Glad to be here today and glad to see a lot of like-minded people. My name is Dharanipati Ratnakumar, and I'm doing a PhD in Maynooth in Ireland. And my research topic is neural audio effects. So today's topic is going to be a bit ML focused. So I hope everybody has a decent understanding about it. Again, it's not going to be very complex. It's going to be a simple introduction kind of a thing. So let's get into it. So the topic for the day is leveraging pruning and quantization for efficient real-time audio applications. So so the first thing is neural network model compression. So it's kind of a huge field where, so anytime you train a neural network, the main focus is on improving the accuracy. People don't really give a lot of importance about the model size. The main agenda is to have a higher accuracy. And another thing is anytime you train a model, you train that in a GPU or in a GPU cluster. But then most of the times for inference, it's not going to be happening in a device that has access to computational devices like GPUs. So it might be in a CPU-based system or edge devices like phones and stuff. So so this is where model compression comes in. And model compression involves techniques to reduce the size of the network without losing accuracy. And there are a couple of techniques. So weight sharing, pruning, knowledge distillation, and quantization. Today we're going to focus mainly on pruning and a bit of quantization. So I'm going to kind of focus the talk around audio plugins since I'm kind of working on neural audio plugins. So the current audio plugins are predominantly CPU dependent. So there are companies that's working on, like, for example, like GPU audio and stuff. They are trying to bring in ways where you could
your plugins can use GPU for inference. And then the traditional DAWs are still the industry standard. So what I mean by that is that even though there are improvements in machine learning in audio plugin domains, but still the current DAWs doesn't really take advantage of that. So if you're building something, you need to kind of consider the existing ecosystem. And plugins within DAW typically require real-time processing. In a sense, if you load a plugin in a track, it kind of works in real time. In a sense, the DAW sends a series of buffers and it expects a series of buffers out, and it kind of has to happen in real time. And neural network based plugins needs to be highly efficient in order to kind of work real time. And there are few models currently available that are used in real time neural audio effects, such as DDSP models and Rave. But then these are the models where the architecture itself kind of inherently gives you it has an advantage of running in real time. So, but if you want to use, for example, an LSTM or even a TCN that has a much larger size, it's kind of really hard to kind of do it. So this is where model compression techniques kind of comes into play. If you can train a model with a larger size, but if you can kind of shrink it so that it can run in real time, that can be really helpful. So we'll look at the first technique that's called model pruning. Basically, it's a very simple technique. So all you're doing is you're pruning the model. In a sense, you're kind of shrinking the model size, but based on few criteria. So it involves identifying and removing less important neurons or connections and then retraining it most of the time to kind of improve or get back the accuracy that's been lost when you kind of shrink the model. And pruning involves applying a binary criteria to zero weights. So what it means is that you take, for example, like let's say, we'll again cover what weight pruning or neuron pruning in a minute. But then if you want to prune a particular weight or something, you have a binary criteria in a sense. Like let's say you have a threshold. If it's above that, then it's 1. If it's below that, it's a 0. So basically you either on or you off. So also, like for example, in implementation in PyTorch, you have a mask for the model. So it'll have zeros and ones. So, and it'll kind of, and then you finally apply the mask on the model so that you know which weights to keep and which weights to discard. And then pruning larger networks than training, pruning larger networks after training is more effective than kind of, starting with a smaller model and then kind of training. So that's kind of the idea. And then you have two types of pruning. The main two types, one would be structured pruning and one is unstructured pruning. So in structured pruning, you try to kind of prune either a filter or a neuron so that you could kind of shrink the model. So basically like let's say, or a layer. So like, let's say you have a network with 3 layers, 4 layers, and if you want to prune a whole entire layer, you can kind of remove that and then have the rest of the layers combined again so that you have a smaller network. But then when you have, when you do unstructured pruning, you're basically kind of reducing the, so you're increasing the sparsity of the model. So you're not really changing the structure of the model, but you're simply making the weights more sparse. But then you could still have a bit of improvement in performance if you use sparse matrix algorithms. So where you do get a bit of advantage there. And then again, so unstructured pruning is also called like weight pruning because instead of pruning kernels, you're pruning weights. We'll again see what weights and kernels are in a minute. And then in structured pruning, you're pruning kernels or neurons. So if anybody has done a bit of machine learning and stuff, would have seen a simple architecture of a CNN. So the main idea to see, so the main points here are that you have a kernel. So that's going to be the one that's going to, extract some feature from your input. And then you create a feature map from that. So in essence, you'll have a feature, you'll have a filter that has multiple kernels based on the input number of input channels. And then based on your number of filters, you're going to have your number of output channels. So when you kind of do, when we work with audio, mostly we end up using 1D convolutional networks. So this is a 2D convolutional network, but then a 1D one is going to be very similar, but then instead of having a 2D kernel, you're going to have a 1D kernel, and it's going to convolve in the in the time axis. So in this case, since the first layer, so the input has just one channel, we are using the filter has just one kernel. So that's kind of the idea. So you could have multiple filters, and each filter will have multiple kernels. Okay. So and based on the number of kernels you have, you will end up having number of filters you have, you'll end up having number of features. So in this case, you technically have 3 filters, so you end up having 3 feature maps, and can kind of go on. So as I said, in unstructured pruning, you simply see which weights are less significant, and then you just prune those things. And in structured pruning, you kind of see which kernels or filters are less significant, and then you prune that based on that. And one key thing to note is that anytime you prune a filter, you need to also make sure that, so if you prune a filter, you're going to end up having less features. And if you have less features, in the next coming layer, you need to have one kernel less for each filter. Okay, so it's a bit hard to kind of visualize here, but just know that there's a dependency there. So when you remove one, you also remove. So when you remove one filter, you remove multiple kernels in the next layer's filters, so that your model kind of, the structure stays the same. So the example I'm going to kind of show today is going to be a temporal convolutional network. It's a popular network which we use in audio applications. So it's kind of an advanced form of 1D convolution. So the idea is that Tcns are causal. So in a sense, if you work with real-time audio, your model has to be causal. It can't kind of look into the future. So it needs to create, or it needs to compute each and every sample based on the current sample and the previous samples. And then to have better performance, Tcns have something called dilated convolutions. So in a sense, that helps you increase the receptive field. And also Tcns are good at parallel processing. That's one advantage it has over other sequential models like LSTM-RNs and stuff. So yeah, and then this is kind of an image that kind of explains what causal and dilated convolutions are. So in this case, you could see that each kernel is of type size 2. So to generate one sample, it looks at 2 samples, but then for different layers, it has a different dilation factor. So in the first layer, you could see that it takes the kernel the kernel size is 2, but then you don't have any gaps between it. So it's like it has a dilation of 1, but then as you go, you exponentially increase the dilation so that you could achieve much larger receptive field. So for example, in this case, to compute that the rightmost sample, it can actually look at all the current and the past samples. So that's kind of the idea, and also it's causal, as I said, it's not looking into anything in the future. So this is a simple example. So in this case, I just trained a simple Tcn model, and the task is to just simply emulate an low-pass filter. And if you kind of do it with an absolute mean error loss, it's going to be really easy for the model to model a low-pass filter. It can easily do it with like 1 or 2 layers with 1 or 2 channels. So so I used an STFT loss so that it's a bit hard for the model to recreate it. So in this case, this is going to be the okay, can't load audio right now. Just 1 second. Should be fine. I think I'll just go with it. Didn't use the system. I think it's fine. I'll just go with the. Anyway, I'll just explain that with the spectrogram. Still, it's pretty clear there. So that's going to be our input dry signal. And then since we wanted to kind of emulate a low pass filter with a cutoff frequency of 100 Hertz. So if you use a much smaller network that has just 8 channels, so this is a model with 3 layers, and each layer is with has 8 channels. So you don't get a very good result, as you can kind of see that from the spectrogram. It does a decent job, but still you have artifacts and it's not proper reproduction. But then when you have a 32 channel model, a larger model, but then you prune that once, and you could prune that with sparsity ratio. So in this case, I think it's 80%. So we force the model, sorry, we prune the model to kind of remove 80% of the weights. So you end up, so 80% of the filters in the 80% of the filters in each layer. So we end up having 7 channels in each of the 3 layers. So, and then we retrain it once. So we end up having a much better result. In fact, that result is kind of very similar to the 32 channel model. So as you could see that a 7 channel model performs way better than an 8 channel model, since it was pruned from a much complex model. So that's kind of the idea about pruning, and then we're going to quickly have a look at quantization. So again, quantization is another technique that's been extensively used in large language models and stuff. So where the idea is to kind of reduce the precision of the parameters. It can be for the weights or biases. And then, so you basically convert, so generally when you train a model, it's going to be in 32 float. So you convert that into 8-bit. Yeah, so you train a model with 32-bit float, and then during quantization, you convert that into 8-bit int. So as you could kind of see, the main benefits are memory usage and then power consumption and latency. And with power consumption, as you could kind of see that an 8-bit addition is like 30 times less, consumes less energy than a 32-bit float. So, and then quantization is kind of, it's extensively used when you want to kind of deploy models to, edge devices that runs on batteries and stuff. And then you have 2 types of quantization. One is post-training quantization, and one is quantization-aware training. Post-training quantization is very simple. You still have like dynamic and static and stuff. I'm not going to go into details of it, but in essence, it means is that you train a model and then you finally quantize it. You change the weights to a much lower precision, and also if it's dynamic quantization, then as your inputs comes in, you kind of dynamically quantize it based on the range. And then with quantization-aware training, so what you do is you kind of induce a fake quantization while training. In a sense, for example, an 8-bit can store 256 values. So when you train a model, you kind of, like let's say if it's a weight and if it's in 32-bit float, you kind of round it to the nearest value so that your entire range is going to have 256 values. So that's kind of the idea. But the operation still happens in floating point, but then what you do is you kind of fake quantize so that it ends up being in a rounded value. So this kind of forces the model to, increase accuracy also in this constrained environment, so that you will end up having, so after training, when you actually quantize it, it's going to have much better results because it kind of has seen an environment where, the values are kind of rounded to that. So again, with quantization, you might not get much improvements in terms of like audio FX plugins and stuff, but then that's something you consider it. So there are a few model compression libraries which you could use. For example, even if you use PyTorch, problem with PyTorch is when you do structured pruning, so it'll end up giving you a mask, but you don't have, currently there's no feature in PyTorch where you could actually shrink the model just by running a couple of lines of code. But there are a few other libraries that does that. For example, neural network NNI from Microsoft. That's the one I used for the example which I showed. So where you do you prune a model, and then once you prune, and then when you want to actually shrink it, the way it works internally is that you kind of trace the model. In a sense, you pass an input, and then you trace how the model goes, how the model. You're basically tracing it like how you draw with tracing with a pencil, and then you kind of get the graph, and then you remove the weights or the layers, or the layers from the mask, and then you kind of stitch it again. You also have another library called torch pruning, and then you have Razor. So there are a few interesting neural network based audio plugin tools. I hope everyone have heard about Newton. It's really an awesome tool where if you're working on some neural network model, and if you want to kind of quickly deploy it in a DAW or something, you'd kind of use that. So that's a tool that really bridges the gap between experimenting with PyTorch and then actually using that in a DAW. And then you also have Arch Neural, where if you have something in PyTorch, you can kind of convert that into a C++ model and then use it for inference. And yeah, that's it for the day. Thanks. Any questions?
Hi, fantastic presentation. There's so much great information there. Thank you so much. I have two questions. The first one is about structured pruning. How do you select what features to tune, or what are some metrics we can use to evaluate our pruning?
So most of the time, it's going to be, in a sense, even though it's structure pruning, you're still kind of focusing on the weights, and generally they use L1 norm. So one thing I kind of mentioned to say is that pruning and regularization kind of goes hand in hand. So if you use, for example, like L1 or L2 regularization, what you do is you force the model during training to have a sparse model, so that there's going to be few weights. It's going to have value either, like if you use L1, it's going to be 0, or if you use L2, it's going to be close to 0. So that then you have a simple criteria like an L1 norm, where you say that if a value is below a certain threshold, you just prune that. So if it's a structured pruning, then you're going to kind of have some weightage between. So either you could prune globally, or you could prune layer wise. So you, like, let's say if it's layer wise, you take layer, and then like let's say you have 32 channels, and then based on the sparsity, a sparse value you give, you take the best, so the ones that has less significant weights, and then you would remove those filters.
Okay, so if you set, like, let's say sparsity to 50%,
yeah,
would that be something similar to dropout?
Dropout is more like it kind of randomly drops out different weights
but
during
here
training.
You
basically just like zero out.
Okay.
So basically, like you're kind of completely removing those.
Okay.
If it's structured, you're removing the filters, or if it's unstructured, you're removing the weights.
Okay.
Not removing in a sense, zeroing it out. Yeah.
Got it. Thank you so much. The second question is, do you see a trend where DAWs are moving towards using GPU that sort of does away with the processing power threshold and the need for pruning and quantization? Do you see that happening in the future?
I think it might be, because again, this is just my intuition. I feel that the future DAWs are going to be more web-based. So since there's going to be a lot of generative, for example, like Firefly from Adobe, so you're going to have a DAW. There's going to be everything is going to happen in their servers, so that you don't really have to worry about the like processing and stuff. But still, it's going to be helpful for them if they are going to run a lot of inference and stuff. Probably like something like quantization might be helpful, because it's less energy, it consumes less energy and things like that. But then even if you are, I think this is more beneficial for people who are working with models, and then they want to, which are going to be helpful for audio production and stuff. And then, as I said, like, for example, if they want to just simply deploy that in a DAW using something like Newton, like say you're working on LSTM, but you really want a small, there are studies that has pruned LSTMs where, you do get 3 or 4x smaller size, also 3 or 4x faster inference. So this paves way for experiments in those architectures which you don't really normally find in real-time applications. Yeah.
Got it.
I hope that answered your question. Yeah.
It really does. Thank you so much.
Thank you. Yeah.
I would like to see a comparison of the results. I'm sure you've presented, like you have it on some paper or something.
I'm yet to publish one, so probably probably in a couple of months. So it's going to be a journal paper.
Okay.
So that's going to compare not just audio plugins kind of thing. It's going to be a benchmark paper where you take existing models where you do have, so the one problem with iterative training is that, iterative pruning is that you need to kind of have the same model with the same data sets and stuff so that, once you prune something, you could train it again. So there's going to be a benchmark of models that has data set and then models that doesn't have a data set where you just prune it, one-shot pruning without iterative training, and then you compare the results of, how much reduction you do get with existing models. Yeah.
Right. Like for the ballpark, like what is like the difference in accuracy?
For example, you kind of
with and without, like.
So the idea is that when you normally do pruning, you try to shrink it as much as possible where you could retain the accuracy. That's kind of the idea.
I see.
So when you prune, like let's say you have a model that has 100% model size and you get 100% accuracy. The idea is to keep 100% accuracy or probably go to 95 and then shrink the model as much as possible. So there are cases where you could shrink it like 90%. In a sense, the model could go to like, just 10% of the size and still keep the 95% accuracy. Yeah.
I can definitely see this being of a lot of importance.
Yeah.
Because there are certain projects that want to not be in the cloud and just like for example, like there's this speech recognition project which wants to like take it to the common man, like where they can like talk in like vernacular languages, and in instances like that, a model like this would be very helpful. Like perhaps we could run something on board, like on their device also, know, or something that's like a small portable device.
Right.
So I see a lot of value in what you're doing.
Right. And then there's the thing called lottery ticket hypothesis. In a sense, it basically means that anytime you have a network, the assumption is that there's going to be a much smaller network that can actually produce the same accuracy. So even with pruning, it doesn't even have to be. So the whole idea is that if you're developing some model, you could just simply try pruning once so that you could see that, hey, can I have the same accuracy at the same time reducing the model? You're not losing anything. Like you could just simply shrink it, just by doing one or two iterative pruning. So I think whether you have a constraint or not, it's probably, I would say that it should be a standard practice where anytime you train something, you try and prune it so that if you can get a smaller network, it's beneficial. Otherwise, it's fine. Kind of.
Agreed.
Yeah. Right.
Hi, this is a very nice presentation. Thanks for it. I've learned a lot.
Thank you.
So with respect, when you talk about reducing the size of LLMs so that we can run, especially in the smaller devices when you was talking about.
Right.
So there are some startups which are hardware focused, like H.AI, who are building the hardware that is customized to run these LLMs very efficiently.
Right.
So they're trying to move away from the whole GPU space and they're trying to build these models. So I assume that is going to become a mainstream, at least I hope that.
Right.
So do you think even this pruning, all the things that you're trying to do to reduce the LLMs will still be valuable? Or I just wanted to understand your perspective with hardware evolution.
I think I'm not an expert in that, but still I feel that even pruning or even quantization, like mainly I think however your architecture is going to be in the hardware level, I still feel that your energy consumption is still going to be kind of the same for doing an integer calculation or a floating point calculation. So in that sense, it's not going to go away because you're still going to get that benefit. Also with models, like it's just that, as I said, you're not really losing anything. You're going to keep the accuracy at the same time, just shrinking it. So anything you get is kind of a free lunch. They do call it free lunch. So yeah.
Right. So, but the only thing is now, if you talk about say 100% size to 10%, it sounds amazing. Right. Now there'll be a lot of interest. But the moment the hardware is going to take that maybe we might not be able to see that big a difference is what I was feeling, but maybe I was wrong. So we have more.
Yeah, exactly. Yeah,
Yeah.
if your infrastructure is, if you have a limited infrastructure, as you said, like you could have more models
Agreed.
running. Yeah,
Agreed.
it's always going to be some efficiency there. So yeah, but again, I'm not sure about there's going to be any special hardware that's going to come up for audio specific thing, as you said.
Yeah.
Since there's a lot of investment in LLMs, is because that's where the money is. But hopefully,
But it'll work because it's fundamentally it's an it's a neural network, right? So you have the
yeah, I'm
same
not
nodes
sure.
and weights.
Like, let's say they make some hardware that's very specific for transformers. Something
Could
that
be.
does something
Right.
that improves something where there's attention or something like that.
Hmm.
Then I'm not sure how that's going to be beneficial. Again,
Sure.
I'm not an expert in that, but I just feel that way. Yeah.
Sure. Yeah. Thanks.
Hello. One quick question. So at least to me, when I'm looking at quantization, it looks like, at least on paper and with the example that you gave, that it would be a very, very big impact on accuracy there. Like going from F32 to Int8.
Right.
It sounds like the impact on accuracy would be substantial. So how do you, I don't know.
So that's where, so when you do just quantization after, post-training quantization, you're not going to get that benefit much. But then when you do quantization aware training, where you do consider that, so you do get benefits there. In a sense, it can actually perform better. Like studies kind of show that. So they do. There is the term called quantization noise. Of course, there's going to be some loss in accuracy, but the trade-off is you're like reducing it way too much, but at the same time, your accuracy is not going to drop like similarly. So your loss in accuracy is going to be much minimal compared to the amount of reduction you have in the precision. That's kind of the idea. Yeah, there are research where 1-bit, 2-bit, 3-bit LLM models and stuff. It might sound like how can you do that in 1-bit, but still that's a very cutting edge research that's happening. And it's there, it does work. So yeah.
And I'm assuming, you can probably combine both pruning and quantization.
Yes, exactly. Yeah,
especially
anytime you do. Yeah, of course. But as I said, when you're like doing something like an audio effect, a neural audio effect, probably quantization might be kind of an overkill with the latency and stuff. At least my research currently is more focused on pruning. But again, quantization can also be, also this thing called knowledge distillation, where you have a teacher-student network, so you train a larger network and then that's going to be a teacher network that's going to train a smaller network, a student network. So there are other techniques which they use for model compression, and these two are one major things, yeah. Yeah. Thank you, everyone.
Yes, so how is everyone doing so far? So this is actually an audio developer conference, so we need to hear some feedback. How is the audience doing? So I need to turn up the volume a little bit more. How is the audience doing? Okay, still not loud enough. It's not reaching that level. The limiter is still like, you can't reach the threshold. How is the audience doing? Yeah, we're still not there, but it's okay for now. Okay, maybe after lunch, I'll try it again. Yeah. Okay, so speaking of lunch and breaks, actually, no. Let me ask a question. How many of you do mixing, like music mixing or sound design mixing? Okay. How many of you know what mixing is? Okay, yeah. So I actually have a joke about mixing, but I listen to it again tomorrow and see if it's still good. Yeah. So I mean, the reason I brought that up is because we have an extremely diverse audience. There are people who are developers, there are people who are musicians, artists, mix engineers, sound engineers, and there's a lot of possibility for collaboration. There are a lot of things that can come out, right? And like Bobby mentioned in the start, ADC has been a place where startups get like formed, right? So yeah, I think that's where we are heading to. I think we already have like some interesting topics to talk about. There was talk about audio modeling, MP, then there was Indian roots of generative music, and then pruning and quantization, which Dharni just wrapped up. So I think there's a lot of things to talk about. I think Dharni also briefly mentioned about DAW in the web. That could be a future. Yep, I am up for talking about that as well. Yeah, so I think we'll take a break now, like a half an hour break approximately. We will also have like our sponsors here. So you will notice that right on the foyer, ground floor foyer, there is a table set up by Embody, Team Embody, and they have like some demos that you can actually listen and experience. There are also, there's Tom from Juice, there's Bobby from Bass, and there you will also find Sharat from Dubverse, so you can also like go and interact with them and yeah, have some fun. And please be back sharp before 11:30 because we have to start. We have like so many talks to cover, so we will not delay the starting of the talk. But yeah, please make sure you're here for that. And there's going to be coffee and some snacks on the foyer and also on the terrace, so you can choose to decide where you want to interact with folks and have some coffee and stuff. And if you don't see the coffee set up yet, just enjoy having some discussions. And once it's ready, you can just start having that. All right, so see you all in a bit. Okay.
Okay, but if I have to share any, okay,
So you
share
share
screen,
Yes.
share sound.
Yes, you share sound. So the
Got
sound
it,
goes through
got it,
this.
got it.
But on Zoom, you just disable everything.
Got it, got it. So
No, don't do
that's fine.
Yeah.
Just share.
Yes. And on here, you just leave computer audio or just leave your computer audio.
Oh, hey, bro, where?
Oh, yeah, this is a little.
I'll
and I'm going to give a talk on procedural sound design from embedded to games. So who I am a creative technologist, a musician, and a visual artist, sort of. I studied at Berkeley College of Music in the electronic production and design department. And after that, I quickly deviated from being a musician and being more into installations and doing interactive media. And the main thing that I use is Max MSP. That's the thing that I was trained on, and where it's the medium that I use to express myself. So what is procedural sound design? Procedural sound design is a technique or a method that involves using algorithms to create dynamic audio experiences with certain parameters that use real-time generation of sounds. So what does this mean is that when you're designing experience of some sort, be it for an electronic vehicle, be it for like an installation, for games, for an app, you are not recording samples that will then stay in your memory and get played at certain targeted events. You are writing a synth engine which is continuously generating sound, and based on certain parameters that you assign to that sound, to that synth engine, you can adapt the sound. Like you can change the pitch of it, the tone, the timbre, the filtration, the effects, and all sorts of things. Now, the question that I get asked is like, why? Like, why should we do procedural sound design? The main thing that I talk about is that it just saves a lot of space. Because whenever, like, let's say you have a AAA game and you're shipping it, if any of y'all have been on Steam, a AAA game is nearly like 60 to 80 GB. And I remember the times when I used to wait like 2 days to like download a game and just play it. But procedural sound design does decrease that size because you're not loading, so you're not shipping with a lot of assets that are just sound-based. So what are some of the tools and technologies that you can use? There's Max MSP that is created by Cycling 74. It's a graphical programming language that lets you real-time generate sound and visuals. I'm pretty sure since we're in the audio dev community, there are a lot of people who use Max. Max is paid. You can export code from it, but then as soon as you cross a certain threshold of income, there's some licensing that gets involved. There's Pure Data, which is kind of like Max, but a boiled down version. Pure Data is completely free. It's open source. If you're looking at commercial stuff, there's AudioWeaver Designer that's based out of Boston. They have set of tools that you can also use to like compile code and run it, and it does real-time audio problem processing. And if you're working in games, there's Wise that lets you use procedural sound design. So I'm going to get into a few things. So Max MSP, how do you like make this patch in Max and then you take it out? There are two things. For the longest time, there was Gentilda. Now what Gentilda is it's a subset of Max that has not all, like every time you pull up a small thing in Max, it's called an op object. In Gentilda, you have operators, which is a boiled down version of what you get in the whole world of Max. So you don't have all the filters that you get. You have a very smaller subsection of operators that you can use. This does limit you in creating a very immersive experience, but what you can do with that is that you can build your own filters, you can build your own synthesizers, how you pass in MIDI data, and all of this is written in the Gen language. So it's a subset inside Max, and you still are using a patching kind of environment, but you can export that code into C++. You can have certain parameters that you expose. You can then recompile that into like a VST, into an app. You couldn't do it for the web audio assembly. That is why last year Rainbow was released. Since Rainbow took Gen, which would let you use like 60% of the code that you wrote in Max outside of Max, it takes you to like 95% now. It lets you do a C++ export with like full documentation as to how to incorporate that into, let's say, another VST. So you can like build a Juice a Juice VST straight from Rainbow. You can export it to web audio, which is great. So if you have a patch, you like the synth sound, or you like this like generative ambience that you want to host on your website, you can just do a JavaScript export. If you are doing an interactive installation where, let's say you have like 16 sensors and you need to like, when someone triggers sensor number 1, a certain sound needs to play, you can export that to like a Raspberry Pi as well. And then there's full set of documentation as to how you get sensors then attached to these parameters and trigger sound events. Next is Pure Data. Pure Data, again, as I said, is like Max, just a lot less objects to use. And weirdly, when I started to work with Pure Data for a project, I found that it was really limiting, because simple stuff like having a scale object, which you use a lot in Max, where you just want to take an incoming number that's going from, let's say, 0 to 1, and you want to scale that to 300 to 556, it's not there. You just have to like build it from scratch, which is great, because if you're used and spoiled by Max, you learn to then remake certain objects that you're really used to inside Pure Data. So you teach yourself how to make certain things and how certain logics work. Now, Pure Data doesn't natively support exporting all the code that you make in it, but there are people like who develop the heavy compiler, where you can download this tool chain onto your terminal, and you just need to put your Pure Data patch into that, and it generates a C++ code output with certain parameters that you can expose. So the only downside of that is that you need to build everything in PD vanilla. So there are a few flavors of Pure Data. There's Pure Data vanilla, there's Pure Data extended, which gives you some of the features that are then maxed into Pure Data. And then I think so there's PD cat, which is like, it just looks a little better, and it's a little cute. I really like using it at times when I want to feel happy. But there's Pure Data, which you can use to export. So that's like any synthesis technique that you want to build, you can do it. So let's say you want to build a subtractive synth, you can do it in Pure Data, you can do it in Max, and then you can export it and host it in another land. Granular, you can do FM. A lot of times you can do like even convolution based stuff, but that is a little bit tricky, where you need to like involve other C++ code to like get it in. You can do a lot of time-based processing. So my main experience in using procedural sound design is in automotive applications. Last year I was subcontracted by a contractor for an EV startup in Bangalore, where they wanted to have a fake exhaust note sound for their bikes. If y'all have been around, y'all might have seen it. It's pretty popular. I can't take names because I have an NDA. But how I got in touch with them is that, I didn't mention this. I also work for Animal Factory amplifications. I am one of the 3. I help in everything from circuit design to product design, graphics, marketing, PR. Very small company. So yeah. So the guy who got in touch with me was one of our customers, and he was like, hey, I got this project from this company. We need someone who's like really good at Max. And since I had like tons of experience in Max and a little bit of procedural sound design and a little bit of procedural sound design experience, I got on board with them. And since they were more of a traditional sound designer, where they worked in DAWs like Logic, how they were implementing their fake exhaust note was designing it in MassiveX and then exporting samples, having samples pitched up by certain parameters, and then you interpolate between the samples with like given external parameters like the throttle or the RPM. And when I was got on board, like every Bangalore startup, they were in fire mode. They're like, it needs to ship next month. And I was like, y'all, that's not gonna happen. That you cannot ship a project next month. They're like, no, we have the software, it's auto viewer designer. We've got all these samples, and then I played it. And it first of all, audio viewer designer is not interpreted. It's compiled. So every time you make a new design, you have to like hit compile, and you wait for 5 minutes, and then as soon as it plays, you're like, shit, that's wrong. Oh, sorry, I can't swear. Damn, it's wrong. So you're playing hit stop, then go change your patch, and then see, okay, are my pitch tunings right? What's happening at like 20 kilometers per hour? Okay, it's not sounding right. I'm getting a lot of aliasing. So then I came in and I was like, hey guys, there's this thing called procedural sound design where you can like make a synth engine, you can assign it parameters, and it's like fully real time. It takes barely any cycles on your CPU, so your UI doesn't hang, because every time that they had to load in samples, their UI would hang because it's taking it from their storage to the RAM, and then there would be a little glitch. So it was a labor of love to get them convinced, where we had to write white papers, and I'm not a developer, so I didn't know what a white paper was. So I had to write a white paper as to why we should use procedural sound design. Then there was the whole licensing talk. We got in touch with Cycling and said that, hey, we want to use this. They're like, oh yeah, there's this thing called Rainbow, and we got a beta testing version of it. Turns out that if you're more than $200,000 in revenue, you need to strike a licensing deal where each time the product is shipped, Cycling gets a cut. So the higher ups went with Pure Data. That was also a whole thing of how we set up the tool chain, where we had to first make demos of certain parameters of certain synth engines, because they had different synth engines that they wanted to run depending on how the UI changes. So that was how it went through. We used Pure Data to recreate the sounds in real time. Then how we would test these sounds and validate these sounds on our laptop was that we had to design an app that ran on their software that would record CAN data. If you're not familiar with CAN, it's controller area network. It's the protocol on which all automotive signals are sent through. So you could, like, what's your RPM, what's your throttle, what's your brake temperature, is your oil low? All of that is sent through the CAN network. So we had to build an app that would record CAN data into a CSV file. So we would record CAN data, go on a ride, and then you take all the CSV data, you convert it into a WAV file. That WAV file would then be played through Ableton Live, piped into Pure Data, which would then change parameters. So depending on how fast the person is going, how high how quickly they turn their throttle, all the data would then be fed into Pure Data, and then Pure Data would make the sounds. Now, once Pure Data makes the sounds, you're like, okay, this is great. Whichever parameters you want to expose to the CAN and to tune it afterwards, you need to expose that, run it through the heavy compiler. You get a C++ output. We would send that to the DSP team. The DSP team would then recompile it into Java, and that would run as a service. Now, after all of this is done, you still need to what you make on your laptop versus how you interact with it on a vehicle is extremely different. Because you might think that, okay, this sounds good when it goes from 10 kilometers per hour to 20 kilometers per hour. But what happens when you brake? Like the vehicle can't say things. The vehicle is slowing down gradually, but for the user, they have gone to a sudden stop. So how do you bring that in? So then, okay, wait, we also need to take in brake data. And as soon as there's a brake, as soon as we see that, okay, there's a brake been applied, what do you do to the pitch? What do you do to the volume? if someone presses the front brake versus someone presses the back brake, because the back brake is a more slowed down, gentle stop, but like the front brake is a like immediate stop. So how do we bring that in? So all of this, if you had to do this via samples, I mean, you can't do it. Like there's no way. So that is what we had done for that team. It went well. They shipped it. I don't know how many people use the feature that we worked on, but it's there. And so that is what you can do for vehicles, and that is more as a thing called AVAS, Acoustic Vehicle Alerting System. Alerting system for EVs, where they are so quiet between the 0 to 20 kilometers per hour that it's a kind of a hazard for people with limited vision. So yeah. So what you can do is that there are other companies like Porsche and BMW that are like having this plate inside their cars because they want their users to feel, because they have this pedigree of having all these V8 engines and V12 engines, and they want to recreate that experience in their cars. So they have that inside their cars to have their users feel like, oh yeah, this sounds great. There's Mercedes who makes like really nice sound for their EQS engine. It sounds somewhere between Tron and yeah, it's great. And then they also like brought in regen. So each time the car goes into regen mode, there's a different sound that plays. So it also like affirms to the user that, okay, you know what, all of these things are actually happening in the car, and it's a more rounded experience. This is a project that I worked on while I was working at a architectural studio in Boston, doing a lot of installations. My boss was kind of a crazy guy. He was from the Media Lab in his 60s. He found a Porsche Targa that was on the verge of breaking down, so he converted it into an electronic vehicle. This was the first time back in 2019 when I first got exposed to procedural sound design. And over here, there's the whole UI of the car was built in Max, which I don't know why he did that, but everything that we did was done in Max. So we had like 30 installations that ran 24/7 throughout Europe and the US. And for some reason, he always stuck to Max. And it's not the best thing. Like, it's great to prototype in Max. You don't really ship a product in Max, but working over there, I learned how you can actually ship a product in Max. And this is one of the engines that didn't get assigned, like it didn't go through, like the high ups didn't like it, but I loved it. So this is a quick demo. And this is made with just FM, but instead of using like it's a two operator, 2-channel FM, but instead of using sine waves, you just like use a triangle or a saw and a phaser, you put some offsets, and weirdly it sounds like a very good engine. Video games, I think so I quickly spoke on this. You use it, you can use it for footsteps, you can use it for waterfall sounds, like all your environmental sounds. Procedural sound design is great for that because you don't need to like ship like a 20-second waterfall sound that has to continuously loop. You just have a few cycles, and you can just have it running in the back. You have adaptive scores. This is something that Mick Gordon used for Doom. If you haven't checked that GTDC talk, it's a great one as to how when a guy comes in front, how's the music change. He has not used procedural sound design, but it's also a great way to like use those techniques into procedural sound design. This is a quick thing that I had made in RNVO to create environmental sound for Unity. So I just built a plugin that gives me like a nighttime ambience. And you have full like here I've only exposed the parameters for the volumes, but you can expose any parameter that you build into the synth as well. Challenges: balancing computer power versus audio quality. Procedural sound design doesn't always sound great. Like without context, some of the footsteps sound terrible. But then it's only when you put that footstep into the video and you see the person's step is where your brain makes a connection. You're like, oh wait, yeah, no, that is a footstep. So always you need to balance that as to how much audio, how much stuff do you like, how much reliance do you give to audio quality versus computing power. You can make engaging soundscapes. compatibility, you can have this hosted on the web, or you can have it on an STM32 board, you can have it on FPGA if you want, you can have it as an Android app, anywhere. As long as it's in C, C++, it can be compiled and output wherever you want. And there are some regulatory aspects. This is mainly for electronic vehicles as to how loud they are, how quiet they are. All of this, because it's such a tunable system based on wherever you ship this item. Like Europe has a very different legal system as to how loud the car needs to be versus the US. And there are also different things like you can have a fart sound for your backing up thing, because which Tesla does, that doesn't fly in Europe. So you can always, balance all these things out. Future trends, AI-driven or AI-driven audio integration. There's a company in Germany that's doing this, where they have procedural sound design models that are tuned to how the person is driving. So it like takes in all the data of how hard they accelerate, how slow they accelerate, and they take all that data and they change their models in real time with that. There's real-time environmental simulation. It's great for VR and all that stuff. I'm not really into that as of right now, but I'm sure it's going to be our future. And the best practice is always test in context. Never have it on your headphones and test it on your laptop and be like, this sounds great. You need to put it on the vehicle. You need to put it in the game. You need to put it wherever it needs to be, and always test in context, because your models really change depending on wherever they are shipped. So always test in context. That's my best practice thing. Yeah. Thank you. Oh, shit.
Check. Hi.
Hi.
This is more of a hardware question. Where are the speakers placed in the vehicle? Is it where the engine typically was at? Because that's where the sound comes from, but it's more of a curiosity.
Like where in the vehicle that I worked on?
Let's say you're working on a motorcycle. Let's assume you're working on a motorcycle. In that case,
it depends. So ideally, you would want them to be at your level, but you always want to design from how a traditional motorcycle works, if that's what you want to recreate.
Correct.
So you'd want it in the body. You'd want it because you'd want it where a traditional engine would be.
Correct. Then again, the bulk of the sound comes from the silencer, not necessarily the engine.
Yeah.
And so that's kind of in the behind. So
yeah, so you would want it. There's Revolt, who's done a great job. They are more of like a performance scooter, and where they are speakers places that it's placed right underneath the battery, where so if you have a traditional fuel tank, it's placed underneath that, and it's a huge subwoofer that also like shakes the bike a little bit. Okay. So that is where they have placed it, and honestly, that was the best implementation that I've seen in India for an AVAS system.
that also gives you like a sense of like a vibration, like the engine.
It does, yeah, and it like reaffirms that you are riding. I mean, a lot of people don't use it, but for the ones who are like ice nerds, they really like that. So for them, they like keep it there. Also, the size of your speaker depends on how good it'll sound. So you can create the best sound that sounds great, but then if you are developing a sound that's going to be on like a 1-inch speaker, you need to take those challenges and considerations into account when you're delivering a product like this.
And are the speakers mature enough to be like, or are they cased well enough to be like road proof? Like water, dust,
I mean,
damage.
I don't really deal in that.
Okay.
Yeah, but I hope they are, because they should be.
They should be.
Yeah.
From your testing perspective.
Oh, from my testing, I can't comment on that. Yeah. Yeah. I mean, I would like to, but I might get into legal troubles. I can't do that.
I see. Okay.
Yeah.
I just wanted to ask in terms of the safety considerations. I'm guessing in this case you were talking about the safety of the rider and being able to know when they're braking and intuitively feel that.
No, that is the safety of everyone around the driver
as well. Yeah, which is what I wanted to ask. Especially, I guess in the Indian context, where a lot of places we don't have footpaths, we have pedestrians on the street. I mean, a lot of times I felt the wind of the electric bus passed by me before I knew there was a bus.
Yeah.
So, what kind of things did you take into? I mean, what kind of factors did you
take into consideration?
And what do you know about them?
So, there is no regulatory body set up in India that is checking this. That's why most of our electric vehicles, and the companies in India, they don't really have it. Either their engine is loud enough so you know that it's there. But there are a lot of buses that don't know. And so we usually try and stick with the European standard, where between 0 and 20 kilometers per hour, which is the speed at which it is quiet enough and there's not enough wind noise to know that there is something near you. It needs to, I think so, hit 80, not 85, that's way low. I think so 75 or something in a certain radius. Yeah, that was we were following that because India doesn't have any regulatory body.
Did you also take into consideration maybe a higher noise floor in India?
Yes, we did take that into consideration, but by the end of the project, it turned more into shipping the product than keeping these things into mind. So I'm guessing if there's someone who's taking a more slow approach to building this feature into it, they will keep all of these things into consideration. The Porsche Targa that I worked on, my boss wanted that to be road legal in Lexington County, and for that we had certain things that we need to meet. So there we paid attention to it. That is only because he wanted to drive it in his city. Yeah, but so we had a Bose sound system and the huge subwoofer that would just make. I tried to emulate a Porsche sound. It wasn't great because that was my first time doing it. But yeah, it worked, and he just needed to drive in his city, so that's why we had it. Yeah. Thanks.
All right. So in the interest of time, I think we'll have to wrap up with questions. But feel free to meet Aaron outside and then have a discussion there. All right, so this was fun. Actually, so I think there was a little bit of mention about Max MSP, and on the ADC's YouTube channel, you'll also find some keynote talks by David Ziccarelli, who's the creator of Max MSP, and one of his interesting talks is actually titled "Incompleteness is a feature, not a bug." So yeah, definitely worth a watch. And yeah, I think this was a really interesting talk because in the gaming world, CPU versus RAM is an interesting problem to solve. Just throwing out some keywords that you can discuss about in the next networking break. And now we have Aman Jagwani, who is going to give a talk about modular audio synthesis on FPGAs with high-level synthesis development flow. So a round of applause for Aman.
Okay. Hello, everyone. I'm very glad to be here. Thank you to everyone for the amazing talks. I'm really enjoying them. My name is Aman Jagwani. I'm a PhD student at Maynooth University. I'm working with Professor Victor Lazzarini over there, and my focus is on FPGAs and creating a self-accompanying cross-adaptive synthesis system a standalone synthesis system. So we're trying to do that on FPGAs. So today I'm going to talk about modular sound synthesis on FPGAs with the high-level synthesis development flow. Just a quick note is that synthesis and high-level synthesis, or HLS, is not sound synthesis. It's more about actually creating hardware from code. So if I refer to HLS, that is different from the actual sound synthesis. A little bit background about me. I'm an audio programmer, sound designer. I also have a background in electronic music and jazz drum set as well. And then right now I'm a researcher in the field, in more the embedded system kind of field. So before we start, I'm just going to give an overview or like an introduction of FPGAs. FPGAs, or field programmable gate arrays, are integrated circuits. They're like chips. They're like the microcontrollers or CPUs or chips that are on our phones and all our devices. The difference is that they are reprogrammable and customizable. You are actually able to change the electronic circuits, the logic units that are within the chip. It's mostly done with specialized hardware description languages like VHDL and Verilog. What I'm focusing on today is another technology called HLS, which enables us to program FPGAs from C or C++ code, basically. It's very specific, and it's still not, it's called high level, but it's not actually that high level. It's still quite low level. But there is if you have a good approach and a systematic approach to it, it is possible, and it is accessible, I feel, to the audio developer community. So one of the goals of my talk is also, and the project that I'm working on is also about bringing more access and uses of FPGA in the research and industry as well. Another factor about FPGA is that it has a high degree of parallelism. We are able to customize the actual processor that we make, or like the code that we make. So we are able to do a lot of functions and a lot of things in parallel on the FPGAs. That is very useful for music and audio. For example, in spatial audio, we can have many parallel processing channels happening together. Then there's also ultra low latency. In FPGAs, you don't need to work with buffers. You can do a lot of very heavy processing sample by sample. So that results in ultra low latency in the order of magnitude of microseconds, which is really powerful for real-time audio processing. Another thing is, on FPGAs, we can work with extremely high sample rates, like high in the megahertz, like about 25 megahertz, around 100 megahertz as well. So we can actually do our audio processing at those sample rates. So that means that we can achieve very close to virtual analog. We can achieve alias-free, higher order FM synthesis, for example. Another thing that we can do on FPGAs is there's a large number of GPIOs, or general purpose inputs and outputs. So that means you can have a lot of channels again. So like doing spatial audio, huge arrays of speakers, they can all be processed parallelly without any problem on a single small chip. Some examples of FPGAs in the audio industry and in research are, the first is a synthesizer example is Novation Summit. The oscillators are like virtual analog oscillators, run at extremely high sample rates to achieve the sound. If you hear it, you'll know like it sounds really good. Even the UDO Super 6, similar thing, the oscillators are run on FPGAs. So they leverage the super high sampling rates. Then another example is Antelope Audio interfaces. They have analog emulation of different kinds of effects on their interfaces, which are run on the FPGA. So that leverages the extremely high throughput and processing capabilities of FPGAs as well. And then a very prominent research project is the Cifala project by the Emeraude team in France. So they have created this toolchain called Cifala that enables the programming of FPGAs with the Faust language. Faust is a domain-specific language. It's for DSP programming mostly. If you haven't checked it out, you can create very, very powerful DSP applications, synths, effects with Faust, and it's quite accessible. And with Cifala, they translate Faust straight to flashing an FPGA. So definitely check them out on the GitHub. It's a great way to be introduced to FPGAs as well, and you can make a program pretty quick running on an FPGA with Cifala. And they also use HLS, which I'm going to talk about soon. So they convert the Faust to HLS, and then HLS, which is C or C++ HLS, gets converted to hardware code, and then that gets flashed onto the FPGA. So, so I'm quickly going to talk about the hardware that I'm using for my examples. There are two very prominent manufacturers of FPGAs. One is AMD Xilinx, and the other is Intel Altera. So I've worked in the Xilinx side of things. So I use this board, which you can see on the screen. It's the Digilent Zybo Z720 FPGA board. So it's a complete board with the FPGA in the middle, which is the Zinc 7000. It is actually a system on chip, which means that it's not just the FPGA on the chip. There's also some memory, BRAM memory, and there's also a dual core ARM Cortex processor. So just a CPU. So on that single chip, there's a processing system and the programmable logic, which is the FPGA part. And one of the challenges with working with these chips is balancing what you put on the CPU, what you put on the FPGA, and how they are interconnected and how they're interfaced as well. So generally in the CPU, we do more things like control systems, like sending control signals, updating parameters for our synthesizers like frequency, modulation index, things like that. The CPU also initializes all the hardware, so the hardware peripherals and as well as the hardware that we are coded onto the FPGA. The CPU has all the drivers for all of that and enables you to configure and initialize them. And it helps with the peripheral communication as well. So peripherals are things like the audio codec. So from the chip, we have to send our digital audio to the audio codec that has the converters that it basically has the DAC. So the communication with that and the configuration with that is done on the CPU as well. And it also communicates with other peripherals like sensors, ADCs. There's UART communication, which enables you to do MIDI control as well. So all of this happens on the CPU. And then on the FPGA side, that's where we do things that need low latency, things that need high processing power, and basically our main audio synthesis like computing audio, processing audio, all of that is done on the FPGA, and that audio is sent to the audio codec. The CPU configures the audio codec, the FPGA sends audio to the audio codec. And then there's also DDR memory on the, now out of the SoC, there's also DDR memory on the board, which both the CPU and the FPGA have access to. So to recap, we have like the development board, which is the Zybo Z720. And then inside that, we have the Zinc 7000 SoC. And inside that, we have the FPGA and the CPU. So yeah, so now getting into the HLS part. So like I said, traditionally, FPGAs were programmed with very specific, and are still programmed with very specific hardware description languages, which require specialized hardware knowledge that is beyond my scope as well. And it's something that is not generally in the scope of the audio developer or community. So HLS provides some mitigation of that issue to some extent. HLS basically, you have a C or C++ program that gets converted into the hardware code. So these are automated tools that are provided by the vendors. Xilinx has, Intel has as well. So within Xilinx, there are three tools. There's Vitis HLS, Vivado, and Vitis IDE, like I've shown over here. So Vitis HLS is where we do the HLS programming. That's where we do our C++ code. So that's where we design the standalone sound synthesis IP core. So IP core is a terminology, it's intellectual property. It's a terminology where each module or hardware unit you create is called an IP in the hardware world. So within Vitis HLS, we take a C or C++ program, and that gets converted into this IP core. Then we do the testing of the C program as well as the testing of the hardware generated within Vitis HLS. So after that, we move to the next software, which is Vivado. That's where we have like a block diagram. I'll show some examples soon. And where different hardware modules are connected. So we can think of like in HLS, we create different parts of a modular system, like oscillators, filters, etc. So we integrate all of those things in Vivado in like a block diagram. And then over there it gets basically converted into a bit stream, which is flashed onto the FPGA eventually. In Vivado, we can also do debugging with things called integrated logic analyzers, where you can digitally probe your generated electronic circuit on the hardware. And then we move to Vitis IDE, where we program our CPU, which was there on the SoC as well. So that's where we make the drivers, we initialize all the hardware that we generated as well, and make sure all the configuration and initialization is done. And after that, on the CPU, you can also design your control system for assigning parameters, launching gates for envelopes, things like that. Yeah. So just quickly, this is the programming structure for HLS. It's centered around a top level function, which is what gets converted into a module or IP core that I was talking about. The top level function, in that we put all our DSP, we put HLS or put optimization directives, and we use very specific data types. I'm not going to get too much into the details of HLS programming. This is more about the structure and the approach and the design considerations. So that our top level function is basically analogous to what our module will be eventually on the FPGA. So for example, if it's an oscillator, all my oscillator processing will be inside the function. Then we have input arguments and output arguments, and they all have to be, again, specific data types, and interfaces have to be defined according to the ADCx standard, which is the standard used in hardware and all of our integrated circuits and embedded systems and all. Again, not going to get too much into details, but basically that's how we decide how we communicate into and out of the module. And then then we test the function within Vitis HLS with a test bench. You test the C function, but you also test the generated register transfer layer, which is basically the generated hardware within Vitis HLS. With the same test bench, you can do that. And then you basically generate the hardware and export it into Vivado. So the main aspect of what this project is, we are trying to translate a modular synthesizer on FPGAs. So modular synthesizers are basically constituted of different modules that are interconnected, and you create different sonic possibilities with them. Similarly, FPGAs are reprogrammable as well. So leveraging that aspect of it, if we have a collection of modules like as IP cores, what I spoke about, we can interconnect them and change them and create different kind of sound synthesis possibilities with just one set and one system of things. So that is the paradigm that we are working with here. The interconnectability and reprogrammability is the main aspect. So what the system consists of right now is basically an expanding collection of sound synthesis HLS IP cores. They're already generated, they're ready. So they consist of like oscillators, envelope generators, filters, mixers, everything you have in your modular synth. We are making IP cores for that. And then there's a base audio system. So in the FPGAs, it's not easy to just get audio out of it. Nothing is made, there's no libraries, there's no drivers ready. You have to do everything from scratch. So our system also takes care of that: audio input, output, drivers for the audio codec, drivers for different peripheral IP cores, and as well as inter-module communication. Everything is basically, the goal is just drop the HLS IP cores and make your synthesizer. And then we also have a control system on the CPU. So that's what I was talking about, changing the parameters and stuff like that. So that there are options for that. We can have we can make a generative piece on the CPU in C or C++ that uses the IP cores to play as its instruments. That's also possible. We can have GUIs. MIDI is also, we've implemented MIDI as well, and you can use different kinds of sensors as well. So that's all done on the CPU with the control system. So I have a couple examples to show you. The first one is subtractive and additive synthesis, like a combination of both, because we have an oscillator bank with 4 outputs, goes through a virtual analog Moog emulation filter. And these are basically the IP blocks that we have that we are using with them. And we also, this design also shows the Zing processing system, which is basically the CPU that has all the control signals. that is controlling all of the different IP cores. And then that's sent to the I2 transmitter, which just basically does data conversion for the audio codec to understand. So here's a quick demo of that. Sorry. I think it's not sharing the sound. Sound is playing from the computer. Sorry about that. Yeah, so that's just an example of subtractive and additive synthesis happening together. Then we also have dual operator FM synthesis. Quickly gonna go over this in the interest of time. Yeah, so that's basically the same system, two completely different synthesizers. You can switch quite easily between them. Some applications of the system would be quickly prototyping different complete hardware synthesis implementation all on one chip. Yeah, and just deploying them quickly, easily, like for companies, for commercial applications, you can quickly make different kinds of synthesis. It's very powerful. It's everything on one chip. It's not just like a filter on one chip. It's a whole system on one chip. Yeah, and then eventually we are working on making this even higher level, and an application would be to make like a Mac style graphical interface for generating hardware designs of modular synthesis. Works in progress right now are additional IP cores like reverbs, delays, spectral processing, more control surfaces as well. And we're also working on C-Sound acceleration. So C-Sound is a sound and music computing system like Pure Data Super Collider. We have C-Sound running on the board already. We made a bare metal build for C-Sound and it's working on the board. Now we are working on interfacing them with the existing IP cores and making new IP cores for the unit generators and opcodes of C-Sound. So yeah, that's it. Thank you. Hope you enjoyed. Questions?
Yeah, so in within the FPGA itself, you have the actual FPGA with the gates, and you also have the CPU and peripherals. So wouldn't there be a bottleneck, like because the audio is eventually going through the peripherals and the DAC and so on? So that will have the constraints, like digital constraints. So won't that be a bottleneck in speed and performance, even if you're using the FPGA?
Yes, definitely. That's a great question. So yeah, right now I'm just using whatever's on the Zybo board. So we are limited by the audio codec on that board. So even though I can run everything at extremely high sample rates, I'm still doing normal 48K. But there's an ongoing project with the Sifala team as well and with our university as well for higher order FM synthesis, particularly, which uses ultra high sample rates, for example. And for that, we are developing like very fixed, like specific hardware to go over the bottlenecks. Like the French team has already developed a DAC for that, so that it works with higher sampling rates. We are also looking at HLS implementations of DAC for high sampling rates. Yeah, but that's a great observation.
Can you elaborate on some applications that can be accomplished using an FPGA but cannot be accomplished with a bare metal high-end processors like RISC-V or Raspberry Pi?
Yeah, definitely. So, firstly, the very high sampling rates, that's not always possible on something like a Raspberry Pi. Then the parallel aspect of it, outputting large arrays of speakers and doing spatial audio in real time also. On FPGAs with the amount of GPIOs, you can do a lot, and also with the parallelization, you can do a lot. Then another thing is the ultra low latency. The FPGA latencies, like once we get over the latency induced by things like the audio codec, the possibilities of latency on FPGA is extremely low. So things like active control of acoustics, that's again something being worked by the Cifala team. And also just signal processing at extremely low latency is also something.
Aman, can you build a codec in FPGA that like instead of depending on the I2S bus to decode it, because it's field programmable logic gates, can you just convert that to send it out? Is that possible?
Yeah, it is. So that's also something work in progress. Just bypassing the whole audio codec and communicating out of the FPGA for the audio. You can definitely build it. There has been progress. There are people have built it with VHDL and like normal FPGA programming. We are also trying to do it with HLS itself, and then you just output audio directly from the FPGA pins. So that will be a major. That will be very helpful in realizing the actual benefits of the especially low latency.
Hi here. Can you also tell me how we can, in HLS maybe, how can we build maybe IP cores that allow us to use like AI models, like for the same sort of reverb, these kind of audio effects?
Yeah, I mean, you can definitely try, but there will be constraints on this as well, like the amount of logic units available. But it's basically HLS programming is very specific C++ programming, so it's not as simple as like just taking an existing model. It will have to be a lot of redesign or even just doing it from scratch. But for example, the thing we did with the filter, that's a existing Moog 4-pole filter emulation. So it is possible to first learn the HLS programming and then take something that exists and redesign it. So that can also be done by these the AI-based reverbs and things like that as well.
Okay.
But GPUs are still probably a better option for AI-based stuff than FPGA.
And if I want to get started with FPGAs, if I just, let's say, get an FPGA, can I just download the HLS file and run it on the FPGA? Is that how easy it is?
No, it's definitely not. Unfortunately, it's even just installing all the tools is it's a long process as well. I would say look at the Cifala GitHub because they really have put the documentation well, and doing it from Faust is a good way to get into it, I feel.
Okay. Thank you so much.
Yeah, thank you.
So can I ask, this is basically like for the musicians here, this is like building like a very fancy VCV rack that runs on a very fancy Arduino.
Yeah, you can. I mean, that's a big extension, but you can say that something like that. Yeah, the structure is basically what you said. Yeah, got it.
Thanks.
So, how does this compare to DSPs? Like, what are like the biggest advantages that you think that FPGAs have? Because DSPs are very audio specific.
Yeah.
And we are doing audio specific stuff here. So what is your take on that?
Yeah, so I mean, the main thing is you can change it. DSPs are fixed, application specific. FPGAs, you can change it. That's mainly in the end, you're trying to make your custom DSP with FPGA. So that's the most prominent thing I would say.
Like, would you, so the customizability is the appealing factor here.
With respect to DSPs, I would say so. Yeah.
I see. Okay.
Hi. So once I've prototyped some modular synth on the FPGA, can I transfer it to some custom chip? And for example, if because making it on an FPGA is more like a prototyping act, is there a process to go from the FPGA to like a custom ASIC or something?
Yeah, I mean, definitely you can prototype and then you can convert it to a ASIC for sure. And that's also a goal of this because it's easier prototyping and you can test many different options as well. So I'm not completely sure about how to go there, but the goal is to like that. This is the workflow that is like what you're saying, to prototype and then fix it. If you're thinking about like large scale production and stuff, that would be the way to go for sure.
Thank you.
Thank you.
Yeah, speaking of audio codecs, how interesting does a format have to be when its encoder is literally called lame? If you get it, you get it. All right, so the next speaker that we have is Nanditi Khilnani, and she's going to speak about symphonies in syntax, the confluence of code and classical music. So round of applause for Nanditi.
Hey guys, it's gonna take a bit to set up the Zoom, so.
Please click on this, and you can, yeah. Yeah, but you're sharing sound, right? You're sharing sound, you can hide this panel.
Okay, I think, yeah, I'm good. Okay. Okay, thank you guys for waiting for a couple of minutes. I'm Nanditi, and I'm glad to welcome you to Symphonies in Syntax, the confluence of code and classical music. I'm very excited to share this creative exploration of mine with you guys today, which looks at code as an inherently suitable medium for music making and music learning. It also unlocks some valuable compositional techniques that sit at this intersection, which have proved in my experience as a catalyst and enabler for music learners, as well as it unlocks some new ways of creation for practicing musicians, which is very playful and is full of surprises. I think the live coders here will already understand where I'm going with this. So yeah, at the outset, I must say that this is not a new topic of exploration, as many of you might know. The idea of the early explorations of algorithmically trying to compose music date all the way back to 500 BC, when Pythagoras started drawing comparisons between music and mathematics. even though the term algorithm didn't exist at that time. And then later on in the 1700s or so, there was this musical dice game. It's a well-cited example of algorithmic music from that time, which is believed to be devised by Mozart, and where you basically had two six-sided dice, and then you had this predefined rule set which you can use to make combinations of smaller musical excerpts. So it was very procedural and algorithmic in a way. And we are talking about a time where there were no computers yet. Then there is also from the Baroque era, which is even earlier, Bach was considered to be, his music was considered to be very algorithmic. The compositions were very procedural. There were things like puzzle canons and fugues that are big examples of contrapuntal compositions, which we will come to eventually. But he has this way of putting symbols in the notations for the performer to check real time and then compute internally the patterns that they're supposed to play by looking at the notations. So if you notice there at the end, there is a symbol which is also in the beginning in this graphic, and which basically means that once you've played this, you have to now play it again in reverse. And you have to play it all together. So that's how like contrapuntal composition would happen in this case. We will come to like a practical demo of this as well, but just to give a brief introduction of where we are getting at. And then I think we had this conversation when George was presenting also. In the recent times as well, there have been a lot of research papers and projects that look at composing algorithmic classical music and just generating like loads of it automatically. And in fact, the explorations of algorithmic music have been going on since 1950s, like actually with computers, it's been going on since 1950s. But recently, the challenges that were faced earlier where, human intervention was required to figure out the styles and get the music in a certain style of classical music, let's say, those are now being addressed because of machine learning and classification, data classification. So now you can even get those styles, like somebody was saying, Carnatic music, right? Like there are so many styles within that as well. So you can actually have that data and classify and get it in the right style. And another reference to Markov chains had happened. So this particular paper on the South Indian classical music is using Markov chains for ragas and the patterns and everything. So yeah, like raga is not just a scale, it's a melodic framework. So that's what they're getting at. But okay, these are all like generating music automatically. My motivation for this talk and the creative exploration is from an artist's perspective. And one thing that is more important for most artists than output is the process of creation itself. So how can we create this scenario where there is human and computer composing together? So keeping both human and computer as the center of the creative process, how can we unlock some interesting ways of creation? So like co-compose essentially. And it's not like the traditional way of music making, and it's not like completely automatically generated, but it's like a computational artist sort of a situation where we are at. And then how this idea moves into the real world, and what are some things that can come out of this exploration. Of course, being able to take styles and techniques and procedures from both Indian and Western classical musical styles, take them and integrate into hybrid music making processes in the modern context. Algorithms can help us with that if we are co-composing with the computer. It obviously adds a lot of playfulness because there is a lot of randomness that we can work with when there's a computer, because you can compute so many things, so many patterns at very high speeds. So like the concept of improvisations is very easy with co-composing. And then of course, since we are coding, live coding is an interesting format to explore as a performance format. Which anyway is happening, and this leads us to live coding as the format for performance. And another useful use case is exploring code and music together as a interesting gateway into music and code both. It could be an alternative pedagogy for music education. From a few experiences that I've had conducting beginner workshops for people who have not been into music or not been into code either, it has turned out to be easy and less daunting for people, even when it comes to music theory, when they're doing it with code, even though they are non-coders, because there is an immediate output as compared to like trying to pick up an instrumental skill, and that's going to take you like weeks, or like vocalizing, that's going to take you a long time. This gives you an immediate output. So learning music theory becomes very less daunting in that way. Not that you shouldn't learn the other skills, it's just that it's a good gateway. So yeah, these are some of the real world explorations and use cases that we can get into if we start to think about code and music together. Before I get into it, I thought I'll just give you guys some background from my personal musical journey, so that I can contextualize and introduce the platform or the tool that I'm going to demo on, which is called SonicPy. So in my early years, I received training in Indian classical music in the Hindustani Khyal tradition of Kirana Gharana, and also like some guitar training where I explored popular genres as well on the side. But of course, life happens, and then I moved into a long corporate stint, and then eventually, without realizing, I figured that my practice has taken a backseat almost for like a decade or so. And then came back, life-altering switch, came back to the very different world of non-profits and music and culture and folk music. So I had joined this organization who has been working on Rajasthan folk music for like 15 years, and they were building a new museum. That gave me an opportunity to do some ethnomusicology research on Rajasthan folk music, and some community programming, events programming, and grassroots work, and of course museum building. So that kind of connected me back to music, and I was like, okay, I should try to get back into the practice that I seem to have forgotten, but needed to find a new way to get into it, easily, because we are out of practice for 10 years. So that's when I started looking for new ways, and I discovered Algorave. Shout out to Algorivers. So discovered Algorave, I think in 2018 or something, and figured the wonders of live coding. And I was not a coder at all, but I found it very intriguing, and I was like, I need to try it, and I started dabbling in it immediately and started getting outputs. And I also realized that everything that I'd learned in the classical training, I was intuitively able to translate that into code, even though I didn't know code as such, but it was easy to translate it into coding concepts, because essentially classical music is very procedure based. And now I continue this exploration through a creative technology studio that I run, which is called Ajaibghar, that co-run with Computational Mama, who's also here. Yeah. And so that's not just about creative coding, although creative coding is a big part of it. So it's everything related, everything artistic that we can do with coding, plus other aspects of creative coding. And then there is this workshop format that we devised, which is for beginners, for in music or art or code, where we bring all of this together in the context of making city soundscapes, which seems to be a very accessible sort of concept, and then see how we can bring like beginner friendly ways of introducing these gateways of coding music and coding visual art. So yeah, this kind of made me believe that yes, coding is in fact an accessible medium for music making and performance, from my own experience as a non-coder, as well as all the other beginners who've been in the workshops. Yeah, cool. So what made me, who's a non-coder, get into creative coding and coding music is the platform and the tool called SonicPy, which I guess some of you will know. But if not, I'll like introduce it and demo it fully for you guys. This is basically an open source programming environment to compose and perform music. It was originally made as an educational resource for schools to teach students coding concepts through creating new sounds. So in a way, it is built for music. and built to learn coding concepts. It's built over the Ruby programming language, so it's quite intuitive and easy to understand. And it has a lot of unique commands and functions that are made for music, both in terms of music theory and sound engineering. So we'll see how that works out when I demo it. And yeah, so now it has evolved into this very like a full solution for professional musicians as well as a live coding instrument. A lot of new things are adding all the time. Since it's open source, people are contributing, new things are happening, new features are happening, source code is available. So I've left the link also here if you guys want to ever check it out. So yeah, I think we can do a demo, I guess, but let me know if the sound is fine in the stream. Okay, so just to demo, this is the most basic, the most simple thing that you can do is just like play a note. This is how it starts. It's just it immediately starts to give you output, and this is just playing a MIDI note, and there are different ways to write the same thing. You can play the note as regular Western notations that we know as well. And then it has this whole way of like playing chords and scales and play them however you want to play them. You can randomize them and a lot of other things. So these are all the functions that are built over Ruby on Sonic Pi. So, that's how it's very interesting for musicians. You can just directly play a chord like that. Then you can also create arpeggios, because again, it gives you more functions to do that. And you can even play scales fully. So this is showing some potential in terms of composing very easily. Now, if you can just take a chord and like start to make melodies out of it. So this is just going to keep running in a loop and keep choosing random notes from one chord and start to give you some results. If you keep playing around with it, it's going to give you newer melodies. So just the previous one was like a 3-note melody. This is an 8-note because I just changed it to 8 times. So the loop is going to run 8 times. And then you can change the number of octaves. So add more stuff, more notes into it. You can like make it faster. And coming to effects, studio effects. There are like all these studio effects that you can actually work with very easily. There are a lot of parameters also. You can also work with cutoff and frequencies similarly. Yeah. So this is just a short demo of how it's bringing sound engineering aspects slowly and like musical theory aspects very easily in a very easily understandable code block. I don't think I even need to explain this. It seems to be pretty understandable just by reading it. Yeah, and then just we can do the same with scales. So like people were mentioning, right? Somebody said that there are Indian classical scales on Sonic Pi and other tools. So yeah, this is one of them. This is Bhairav scale, and it's just randomizing. So right now, this one's not randomizing. This is just playing the scale as it is. And then we can start to improvise within that. So now this is improvising within the scale of Bhairav in 1 octave. We can increase that. 2. And then melody, some other pattern will be picked. Change the seed, change the octave. And you can see it gives us a lot of synths to play around with also. So you can form your melodies, you can play in any synth and you can add any effects to it. So yeah, that's yeah, another way to. Oh yeah, and then of course you have your beats. We'll also get to making beats from scratch. This is just one of the samples that we have. So we've already kind of started composing in like Rag Bhairav, just by using the power of code to randomize and find new patterns out of a set that we have given. Yeah, so that was the initial demo, and it's going to come back. So, sorry. Okay, so yeah, so how code is inherently suitable for composing and music writing? I think we've already seen it. But basically the idea is that classical music is a good way to start coding, coding music, because it's based on rules and procedures. So it's like a guide essentially, you already have a guide that classical music, both Indian and Western, they provide you, which you can just translate into code, and there you have it. You're already composing something if you're not yet able to compose things out of thin air. So it's a good guide to go with. Yeah, so I don't think I need to stress on this more, but just if you look at the basic meanings of an algorithm or a raga or a canon, for example, from the Western styles, they are all talking about the same thing. Like algorithm is a finite sequence of rigorous instructions to get you an output or to do a computation. Raga is a melodic framework for improvisation in Indian classical music. So basically it is a procedure-based thing. And canon is a contrapuntal compositional technique that imitates a melody and layers it together. So that's again another process. In a way, this music is algorithmic. So if you do make classical music with code, you're doing an algorithmic composition. Whether you actually do it on code or you actually just do it traditionally, also it is still an algorithmic composition, because that's how it was devised. So what we'll do is we'll just look at a few concepts and a few techniques that are used both in Indian and Western music, and then try to replicate them in code. So the first one, of course, people are aware that in Indian classical music there is alap and taan, which are both improvised melodies within a set of rules. Alap is of course slower and without rhythm, and taans are on a faster rhythm, which is called a drut lay, and they are all improvised on the go within a framework of a raga. So let's do the comparison. So this is Rag Bhairavi, and as I said, like it is a framework of melodies. So there are all these rules here that, okay, these are the notes that are to be used. These are some of the Vadi, and Samvadi means like these are few important notes that you must stress on, that you must use. And then a few combinations, patterns that should be a part of the raga to get the right mood that is essential. And like there are some things like a pakad, which is like very definitive of the raga. Like if you play this particular melody, you will immediately know that this is the raga. So it's not necessary just the scale going up and down. It is a combination of notes, which is very essential to evoking the right raga. So that is the original Rag Bhairavi, as mentioned traditionally. And then on the right side, these are some bots that I've made in SonicPy that create alaps and taans based on these rules, which is not just telling that these are the notes that you have to use. It is also, there is some level of human intervention here, where the notes that are put here in the ring are decided based on which notes we want to stress more on as well. And then what is the time interval between each note, we can also define. So for alaps, we'll have longer intervals. And of course, we are choosing out of everything. Like we are choosing what is the time between each note. And like every time it will be a random one, but they'll be longer because this is the alap bot. And then, of course, the melody, the notes are being chosen from the selection. And then there are some randomizations on how long the notes are sustaining also. They're not always sustaining the same value. Even that is being chosen from a range. So it's like it's trying to imitate how actually alap is done in Indian classical music. And then same goes for Tanbot, which will then work on a beat. It'll be a little faster. So I think we can demo this. Yeah, that's what the deck says. So there we go. I will just play the scale once, and then we'll the random. So that's just the scale playing, Bhairavi, and then we can just do the alap part. So this one is just going to keep going from a seed of like 20 to 200, because alaps can go on for very long. So you can just decide how long you want it to go on for. And one second. Yes. This is the Tanbot. Yeah, so this can go on forever. Like, it can go however fast you want, or so Tanbot can just go on forever, keep changing it's essentially exactly what classical musicians do. Okay, so we're running a little short on time, so I'm gonna do this a little faster. So the next thing is Tal, which is a cyclical measure with a fixed number of beats and allocation of beats. I think we've kind of already covered it in George's presentation. Again, a comparison between the traditional way of writing it and then the same thing in code. So the first one is a Rupak Tal, which has 7 beats in a measure. The second one is a Teen Tal, which is 16 beats in a measure. And you can see like it's created in a loop anyway. So, in Indian classical music runs into a cycle when it talks about Tal. Similarly, a loop is also running in a cycle. So it's essentially the same thing. And just gonna do this demo quickly. This is the Rupak Tal. I think you can hear it. Yeah, and so these are just all these are just defined here. The bowls, these are called the bowls of Tala, right? Like Dhadinda. So these are just defined here how the sound is coming out correctly using certain samples. So like combining a few samples to get the right bowl, and then using that in this loop, and then using an array to place it correctly where which bowl should come. That's what this is doing. Yeah, and then the final thing. I mean, not final, but for this demo, of course, it is. We have canons, which started in the Baroque era of Western classical music. Like I said, it's an imitation-based contrapuntal compositional technique where you have a main melody, and then you use an imitation of that melody, and then you play it together with the main melody. You could play it after a few beats, or you could play it together. There are different ways to do it. So there are many types of canons, and Bach was very popular for making this kind of music. So a simple canon, which is just an imitation of the main melody after like a certain duration. And then you have a crab canon, which it plays backwards and forwards at the same time. So it's like mirroring it like in this way where it's showing. So it's playing both ways at the same time. Then you have a very funny thing, which is canon on a Mobius strip, where you have to kind of reflect the staff first. So all the notes become some other notes, and then you play it together with the main melody, like a canon, after a little duration. And then there is a retrograde inversion, which goes even further, where it does both of these reflections, like the crab canon reflection and the Mobius reflection. Like it basically flips it vertically and horizontally on the staff, and then it plays it together. So yeah, these are all the puzzle canons that Bach was known for. And what we're going to do is just demo this. So I'm not going to apologize for this meme. I think you all will appreciate it. Okay, so I'm just going to play. This is the Pakad of Rag Bhairavi, which is the main melody that I'm using. Okay, so a simple canon. So now the melody is starting to change just by doing these simple procedures. No, not simple, but yeah, I mean, in code it's simple. So this is playing it in reverse together. Finally, the Mobius. So this melody you can actually draw on a Mobius strip and put it together. It's gonna fit perfectly on a Mobius strip because it's a reflection of it, and then you have played it together. And then finally the retrograde inversion, which is the flip everything, flip both vertically, horizontally, and then play it together. So essentially it's just one melody, but we have like 4 or 5 ways of playing around with it, and it totally changes it. Ideally it should be in 2 different voices as per the actual way of a canon, but I have just used the same voice just to see how we can find new melodies. Just by one single melody you can create so many. So these are the kind of techniques that lie at this intersection of classical music and code. And even more interesting, when you put Indian and Western classical music together, that is something that I've been exploring. So these canons are now canons in Rag Bhairavi, which I don't think people have thought about it, or maybe they would have, but it's a very unique thing. It's like, it's now you're multilingual in music. So, and then the next thing that I'm kind of trying to do is do some fugues. Fugues are much longer and more complicated, but trying to do fugues on rags. So like a fugue in Rag Meghmalar or any, any kind of rag from Indian traditions. Just leaving a few links for you guys in the QR codes if you want to look at a full rendition of Rag Yaman in Teen Tal, all done in a live coding performance. And then there is some snippets of a workshop that I conducted on crafty melodies, where we use the same concepts, which is a bit longer, on using algorithms and puzzle canons. I think, yeah, that's about it from me. And if you'll have any questions, I'll try to answer, else I'll DM you on Instagram. Thank you.
Just in the interest of time, I think you all can meet during lunch break and have discussions around it. Because we're already at 1 p.m. and we have a lot of talk. Right, so
Thank you.
A round of applause for them.
Thank you, guys.
Yeah, hi everyone. I forgot to mention the most important thing. So lunch will be on terrace. You can take a lift or you can take stairs. If you have any questions, you can ask any of the volunteers. Look for the blue tag, and that's how you'll know they are the volunteers. And yeah, have fun, have a lot of food, and we'll be back. We have to be back at 1:55 p.m. because the next session has to start at 2 p.m. So please help us keep things on track. All right, thank you. Sorry. The speakers who are going to present exercise in the morning where we try to see how loud this crowd can get. And now that we have eaten, let's try it again. So yeah, how is the energy? Yeah. Did some people like eat less or something? Okay. Okay, so let's just try one more time. How is the energy here? Yeah, much better. Yeah, the food definitely works. All right, so we had in the first half, we had a great talk by Aaron about procedural sound and how he made us listen to the sound. And now we have the Harman team who is going to present us something very interesting. So a round of applause to the Harman team.
Hi everyone. I'm here to present AudioWorks. My name is Ravish. I work as a distinguished engineer / director for AudioWorks. Briefly, I will touch upon Harman as a company, what we do, and some of the brands we are associated with. And then I'll walk you through how we accelerate audio development using AudioWorks. We'll end the session with a small demo by my colleague. So who we are? Harman as a team, we are 30,000 professionals worldwide. We have 15,000 engineers and 80% of them belong to software. We are across 30 different countries across the globe and 16 legendary brands. We have many patents on our name, many awards, and 3 Grammy awards as well on our list. So as a Harman, as a company, have made 4 different divisions out of it. Of course, it's not the reality. You have many divisions in it. For the talk specific, I've made 4 different. We have connected car, lifestyle, professional, and connected services. Connected car deals with any of the connectivity side of it, where you have a BT5, Bluetooth connectivity, display, safety, security solutions. And in terms of lifestyle, we work with branded audio products and the sound management side of it. We do a car audio, home entertainment, all of this comes under lifestyle division. And then we have professional solutions where we do audio, lighting, and video solutions for concert halls or theaters or any of the bigger events. And then we have a connected services who works on a cloud and mobility as a service division of Harman. So we are house of brands. We have many brands under lifestyle. You might have heard JBL, Infinity, Revel, Harman Kardon. These are the lifestyle brands. And then you have a professional as well as a JBL branded in India, AKG, Lexicon, DBX, and also there is something called Martin Lighting, which provides a lighting solution with audio as part of it as well. So I'll start with a small video and on what Harman is and what it takes to build a car of a complex audio system, and how we manufacture this, how we wire that, how we rip off the car to give us the best audio system. This, the video shows audio processing system, which is having 32 speakers in it. It has 14 high-end speakers, I think 8 mid-range speakers, and 4 subwoofers. And all in all, to power all of this, it uses 5 JBL amplifiers in this car. Let's see the video. All right. As you see, there's a huge amount of audio processing being done. As a company, as Harman, right, we have professional solutions and car audio, home entertainment, consumer speakers, headphones. Everywhere you need audio processing. And we need to develop this fast, and we need to make quality product. We need to make sure we get it to the market faster. So that is where our product comes, AudioWorks. And let me start with some of the challenges what we have, right? So you see there are three different cars in a venue. Left side car is a pretty high-end car, which is, might be having 16 different speakers in it. And the right one is a basic mid-range car, and the leftmost is the low-end car. And then you have a concert hall, which might be having 40 different speakers. So you see here, we need to build our audio system quickly to adapt to all different conditions. And you should be tuning it according to the acoustics of the car. For example, you have a high-end car which has a leather seating or a cloth-based seating. You have a different sound absorption there. There is a different acoustic conditions, the wood there, and it is entirely different conditions. And then you have width of the car, the distance between the two speakers also is different. And you need to, if you want to give a good sweet spot for a driver side, you need to make sure you adjust your delay, gain, and of the speakers to give you a sweet spot for the driver. And that's our tuning. So you need to, and also the first car, maybe it's a pretty high-end car which has a huge amount of processing. It will have very high-end audio processing requirement as well. And whereas the mid-range or the low-end ones, it'll be a basic cars. When you come to the concert halls, you have 40 different speakers. You have a completely different acoustic conditions. The amount of processing requirement is also huge. And we should have a framework, or we should have a product which is scalable. So we should be able to scale in terms of number of speakers, number of processing. We should be quick in the market, and we should have a quality product out of it. So our solution is basically AudioWorks. And as just describing the process with AudioWorks with some Lego blocks. So your vision is to have build a house, right? And how we do with AudioWorks is like you will have smaller components in it. So you have step one, you have 10 components using that you build one smaller box, and you can make this box also as a component so that can be replicated in multiple places to build your house. For example, if you're doing a window, it is made up of multiple steel rods. Each steel rod is a component. You make a window and then keep that as part of your setup. Now you can instantiate it multiple times to bring your house. Plus, you might have customer-centric algorithms which you need to integrate and make the customer proprietary algorithm also part of your car. And that, with the addition, you will end up with a pretty good house, which is better than what you visioned. The reason for that would be you have already tested algorithms, you have already acoustically proven performance of those algorithms, and that's been grouped together to give you a better performance compared to what you had visioned as well. So our solution basically is AudioWorks. AudioWorks has how we do that is we have a DSP library. You load that into a UI component, and in the UI component, it will let you design your audio post-processing pipeline. And you design this pipeline, click of a button, you can realize that onto your simulator or onto the target. And on this simulator and the target, we are running our framework, which will be understanding what UI is popping it out, and it will be able to reconstruct your entire audio pipeline on your target or the simulator. You perform the tuning, you might do a virtual tuning on your simulator, or you go to the target, do the tuning, and then you can bring back all of these outputs together back to your PC and compare whether the simulated output and the implemented target output works the same or not. And what do we have? In AudioWorks, we have 3 different layers. We have XAF, AAT. XAF is Extendable Audio Framework. AAT is Audio Algorithm Toolbox, and GDT is Global Tuning Tool. So XAF is a DSP framework, and what it does is it defines standard APIs for your audio algorithms to be implemented. And it also takes care of memory management, interface to the hardware, interface to the external world in terms of tuning to the global tuning tool which we have, and also to the any of the RPM data or any of the control data which is coming in as well. And then we have AAT, Audio Algorithm Toolbox. This is a house of different algorithms across Harman being put into this. You would be able to use this in your UI to drag and drop and make your pipeline and build your audio system. The global tuning tool is a UI basically, and this lets you drag and drop all of your algorithms, make a pipeline, then perform tuning, acoustic tuning with it, and then also you could do measurement. So you can run the measurement module there, run the measurement on your car, get your measurement, analyze that, tune that system to get the best results out of it. All of these layers are connected through a protocol called XTP, Extendable Tuning Protocol. Continuing with same architecture, this is I've given an example how it looks like. You have a PC where you have a global tuning tool running there. You drag and drop all your algorithms in it, make a pipeline which you want to realize onto different units. So in this example, I have connected the PC to a head unit and an amplifier, and head unit has capability to run 3 different audio processing elements in it, amplifier which is having around 4 audio processing units running there. All of these things can be tuned together with the global tuning tool, and all of these pipelines can be flashed together with the interface connected to the head unit or the amplifier. All these units runs XAF framework in it, and that's why whatever the tuning tool which is popping out, this is able to realize and run that. So you have first you have the pipeline ready, which is run on the head unit and DSPs you have here, and then you make an additional tuning to it or additional algorithms you would add, enhance. You don't need to go and change the code again. You don't need to recompile the entire code, burn that. You don't need to do anything of that sort. You just click a button on the global tuning tool, you have the whole thing realized onto your head unit and amplifier. It also has capability to get maps and memory. It tells you when it is out of memory. You can place your memory the region you want to do in DSPs. As you have multiple L1, L2s, you can configure any of them. So I'll briefly touch upon the features of our tool, as in some screenshots, and then my colleague Harish will take you through a small demo on this. So as I mentioned, this is a basic car, the audio processing which I have put in here. Each of these modules are basically your audio processing modules, and you can see that you can do a metering, get an RMS value of every output of the audio object. We call that as audio object, which is nothing but audio algorithm actually. So all of these pipelines can be realized. You have panels for tuning them. So left side one is an IAR panel. So you can graphically go and configure your cutoff frequency or quality factors in this IAR graph, and which will translate into coefficients onto your embedded device. And the same way, the right side one is a example of a tone control, which is realized as an loudness module here. User can define their own panels as well. I mean, you don't want to expose all the parameters to the end user. You have a big pipeline put up, and you don't want to go and expose everything into end user. So you can develop your own panels using the internally panels created using our tool. Here you can embed your own image onto it. The left one has an Harman Automotive AudioWorks logo in it, and you can expose only the basic, like increase of volume, mute of the master mute for the entire car, and bass and treble maybe. All of this can be done over here. And then you have the right side where you can emboss your own car video, image, and then go each and every seat, passenger seat, mute, unmute, take the polarity change, everything you can position and give as well. Then we have something called measurement module. This measurement module, basically you can measure your car. So how we do it is we probably use 6 mic array inside your car. You place this microphone array physically in the car, and you can configure the measurement module to depict the car, which probably has, in this case, it is 9-speaker system. 9-speaker system is configured in this example, and you have placed one mic array in the driver's seat. So you can configure this measurement module in such a way that do a one microphone measurement, or do multi-speaker measurement, or do a measurement of individual speakers with all 6 mic arrays. You can configure all of that, press start. It will go do the measurement of the car, multiple sessions, wherein first time the speaker 1 is turned on, speaker 2 is turned on, speaker 3 is turned on, and all the speakers turned on with 6 mic arrays. All of this can be configured, do a start, and it's only possible because all of this is integrated into one tool. The global tuning tool knows what is audio processing which is running on your target. It can reduce the gain, mute a channel, unmute it, and do the measurement as well. What I've shown is an example of the resultant measurement, what we have here. And if you want to do more analysis on the measurement which you have performed, we have something called central viewer, and wherein you can get the individual measurements displayed. You can do some banding, you can do some smoothing. All of these operations are supported on this. So next comes I talked about how we build a pipeline, how you can tune it. We have panels, we have measurement module which can do measurement of your car, and then comes the technologies which are part of AudioWorks, right? So I've classified broadly around 3 categories: sound performance, acoustic, and passenger convenience. So in terms of sound performance, I'll pick one example here and walk through a bit. Clarify. So it is basically an algorithm which tries to reconstruct the lost bits due to the compression. And that's one of the modules we have. We have quantum logic, which does the upmixing. In the same way, in acoustic environment, we have something called virtual venues. Basically, what it means is it tries to mimic the venue in your car. So we go to the particular venues, concert halls maybe. We get the measurement from the row number 1, mid rows, and the last rows, and bring that environment back to your car. So you choose a venue 1, it sounds like a particular concert hall. And that's virtual venues. And then we have some of the halosonic algorithms, which is basically sound synthesis, cancellation, road noise cancellation. All of this comes as part of the halosonic area. And then we have passenger convenience, for example, ISZ, which is actually individual sound zone. So what it tries to do is, let's say you have a navigation prompt which is coming in. So the navigation prompt need not be heard by all the passengers in your car. So what it does is it pops out the navigation prompt only to the driver's side, and it cancels out that prompt onto the other speakers. So the passengers are not being disturbed at all from the music which is being played. So the same way it is applicable for some phone calls as well. It does tries to build an individual sound zone so that the 2 phone calls which are happening in parallel is not getting disturbed. Yeah, so we have around 100 plus audio algorithms which can be used to realize your pipeline. And yeah, next Harish will show a small demo on how we can do it using a synthesis.
Right, so hi, I'm Harish. I work as a senior software engineer. 1 minute to go. 1 minute left. Okay, I'll just keep this quick. Might go over 1 minute. But yeah, what you're seeing here is the one tool that a DSP engineer and an acoustic engineer would need, right? DSP engineer to basically rig up a signal chain graphically, much like how you've seen over other presentations. And an acoustic engineer would go measure in a car, with the car, and also tune the experience within a car. So what you're seeing here is an abstraction of what your audio system has. Audio system might have multiple devices, like he said, multiple cores. So what you see here are only the cores that are capable of doing audio processing, right? Let me go into one of these modules which does the signal processing, and you have all of these audio objects in the toolbox on the left, which you can basically drag and drop. Ravish has gone over multiple. There are also like, you can also make abstractions within your SFD or the signal flow design with basic objects, right? And we call them compound audio objects. You can also create panels for controlling the entire SFD with drag and drop methodology. You can put buttons, faders, knobs, whatever you want. And then finally, we have IVP and RTA, which is basically for simulation of your SFD, right? And you can also visualize the signals coming through the simulator as well as from your sound card, which would generally contain sounds from your target device, right? So what you see here is basically the microphone input, which is shown as a spectrum, right? There's a spectrum analyzer, and we're going to go over a simple example of car sound synthesis. Aaron did a very good job at explaining what are the challenges in designing sounds for a car. He also went over things like AVAS, which is acoustic vehicle alert system, and also the engine sound enhancement, right? You want to be able to play engine sounds within your car. So, you hear that? This is basically an example showing what an engine would really sound like by modeling the vibration orders of the engine. So car manufacturers would basically tune their engines to sound a certain way. He mentioned V4, V6, V8, V12. Each car has its own sound, right? So a car manufacturer would give us the analysis of what are the orders, how are the orders placed, how do they sound, how do they interact, all of that, and then we basically put everything together, map them to control parameters like RPM and torque that actually come through the CAN bus. And we can form any complex mapping between the control parameters. For example, I'm showing you RPM versus gain of each of these orders of vibration, right? You can have something like this. And finally, here what we have is fader representing what the engine RPM is. Well, we have so much capability, why just limit ourselves to just mimicking an engine sound? You can even add other forms of synthesis to get more complex sounds and basically play around to achieve any given sound and map them to different parameters within the car. I'm sure this is very rudimentary. If Aaron had, had access to this, he'd come up with a killer sound, but this is what I could. Yes. Here the speed is also mapped to road noise and wind noise, right? Which is simulated through stochastic noise being filtered by two-pole bipolar, right? And then pedal sound, pedal can be mapped to something like volume of certain oscillators to let the driver know how much he is depressing the pedal. So we can generate a variety of sounds all within GTT through these drag and drop tools, synthesizers, and basically tweak them on the fly. And that brings us to the end of our demonstration and our presentation, and we can open the floor for any questions.
Is this only available for in enterprise solutions, or can someone who wants to get into this field, who's like a technical sound designer, but wants the background, so that if there's someone who in the future, if a company in the future is gonna use it, can we get access to this, or do you have to be an enterprise to only get it?
We will soon open up into the public, but currently it is not. So we have few of our customers using this for sound design. We make the primary model and give it to them, and maybe customer will add their own algorithm on top of it. Then probably you need to do a retouch in terms of tuning. That's how it has been shipped to our customers as well. So we
Thank
will
you.
soon go to public. Yeah.
Yeah, so we just got some messages that a few folks from ADC are also watching the live stream. So hello, everyone. Okay, so now we have a very interesting talk. It's by Vibhor Saran, and the talk is titled Towards Emotive Speech Synthesis. So before you clap for him, I asked him a question. Can he replicate nice? So let's see what he has to say. Round of applause for him.
Hello, everyone. I think it will take a couple of minutes. Should I put it?
One second.
Can you increase the brightness also? Which one? This one? This one. Here, right? And there's your HDMI board. That's it. Share sound, everything. Do you have any audio? Yep. Share screen, share sound. There's one optimals for me also. Hello, everyone. I'm Vibhor. I'm the co-founder and CEO of 4E. 4E is actually derived from 4-year. So what we are building is a AI-based platform that can help you localize and dub your content into multiple languages. So for my talk, the topic is towards emotive speech synthesis. So as we know that whenever any AI voice is generated right now, it's very much mechanical. So how can we make it more emotive? So there are some voices that we like. Let's say Amitabh Bachchan.
Parampara. Pratishtha. Anushasana.
Right, some instant connection with this particular voice. Then we have Morgan Freeman.
Where are those of us who like the unexplored, to see the beauty in the strange?
Awesome. And then we have our favorite Arijit Singh.
मैं तो लुट-पुट गया मैं तो गया
Great. So then we wanted to make our own voices. So we started making the voices. So this is the generation 1 of the voice. It would hurt actually. So the volume can be a bit down. One second. Right. So if you remember, 90s kids would remember these kind of voices, the robotic sounds coming in. Then we moved to the generation 2, which was much more human-like.
Hello, my name is Sam.
Right, so now the relatability factor increased, but the voice is still a bit mechanical. Then we have the generation 3 of voices.
Hello, my name is Sam.
So there were like certain pauses in there. The voice was much more better, much more clear in this particular thing. So let's talk about speech first then. What exactly is in speech? You have characters, basically A's and B's and C's, ka, kha, ga, ga, right? The combination of these basically creates phonemes. So phonemes is something like when we speak, there's a specific way everything is spoken out. So we have 26 characters in English. We have 44 phonemes. So like when we are saying dog, D is basically one type of phoneme there. And when we are speaking something out, there's a spectrogram. This is basically how our speech looks like. So can we view speech? Yes. So there's one simple way, a digital signal that we have been seeing throughout. It shows you the complete timeline. You have the sampling rate within the signal itself, and you get the amplitude. So you get a very basic information around any form of speech in a digital signal itself. But then there is a spectrogram, right? It gives you the complete specification about the speech. So you have the timeline. On the y-axis, you can see the frequency. And the colorful things means, this is black and white because I had to show it like that only. So those curves which you are seeing denotes the pitch at a particular frequency at a particular time, right? And this basically forms your speech. With the spectrogram, you can get all the things which are there in digital signal, like the amplitude. You sum up certain things and you get the amplitude and all those particular features as well. So voices can be beautiful. Means I find this voice very beautiful. It's Morgan Freeman's voice. You see that there are like certain pauses. The black parts of certain pauses are there. Then if you see different curves, something like here, here. So this is how basically a sound would basically look like. And then it can be as bland, the one which I showed you, right? Everything is very much static. It's just going straight, and there is no beauty in this particular spectrogram. So speech synthesis. So what is speech synthesis? What do you need to do in a speech synthesis? It's something around voice cloning. Can we clone a particular person's voice? And can we make those voices more emotional in nature? And if it is multilingual, it's even better, right? That if I can talk in from English to Hindi to Tamil to French to Spanish, it would be amazing. But just because we can doesn't mean that we need to, right? So, but why we need this kind of a technology? So, first is, if you can clone a person's voice, you can actually maintain the actor's voice. So the relatability factor would again be very much higher. So let's take an example of Bahubali, right? So Prabhas shouting that, okay, that he wants to take revenge or something like that. Then if it is in Hindi in his particular voice, then the relatability factor is increased. Preserve voice. We can actually preserve our loved one voices. It has an emotional question to it. People get some form of stability when they hear their own people's voice. Global audience, when you are going multilingual, you can actually reach out to much wider audience, people who don't speak your language but can actually relate to your content. And then increased engagement. So more people can actually talk to you, can tell you that, okay, what they are doing, the exchange of ideas increases. And all this results in a very much connected world, right? So that is why speech synthesis with all those particular voice cloning, emotional speech, multilingual, is something that we need to work on. So history and present. So the first one, when we started back in 90s and 2000, it was a very phoneme-based approach. So why those voices were very much mechanical? Because we were sticking all those phonemes, those 44 phonemes together and putting it in a particular voice. So that is why it was sounding very much mechanical, very much robotic. Actually, that robotic thing also came because the algorithm was developed like that. Then came Tachytron 2. Tachytron 2 was a paper by Google. It was I believe it's a game changer by Google here that actually talked about how you can make voices sound more human-like. Post that, a lot of work has been done. Means there's hi-fi GAN. It's around something around voice cloning. Then you have WITS, fast speech, and very recently Open Voice is also released. And there are many, many more. Actually, in every 2 weeks, we are getting some or the other thing related to text-to-speech. So what exactly are we training on? You have a speech. So you have to collect a lot of speech data to actually train your models. You need text. You need text in which the speech is set. And then you need phone. When combined, can actually be used to train any deep learning model or a machine learning model to actually give a voice in a particular tone or in a particular emotion. So this is what Tachytron 2 architecture looked like. So you had input text, you had character embeddings. There are a lot of LSTMs and CNNs which are working out, but it is always about attention, right? So do you have information about what was happened, what is going to happen, those kind of things. If it is there, it helps you create something which is much more meaningful in nature. And this is how Google was able to create something which was much more human-like. Not very emotive, but something which was very human-like. So what was the result of it? So this is Shah Rukh Khan's voice. So you will hear a lot of SRK from my end because big fan. So this is what his voice sounded like.
प्यार दोस्ती है अगर वो मेरी सबसे अच्छी दोस्त नहीं बन सकती.
Right. So this is what his voice was like. But now if we do the AI voice which was developed with Tachytron 2, it sounds something like this.
प्यार दोस्ती है अगर वो मेरी सबसे अच्छी दोस्त नहीं बन सकती.
Right. No relatability factor. There is no emotion in this. So you won't enjoy this kind of a sound. So this is where the next type of concept started coming in. Can we clone a person's voice? Can we actually copy the intonations which a particular person has, and can we clone their voice? And then it sounds more like them. Can we have a particular kind of pauses? So this is one of the architecture from Hi-Fi GAN. So what it takes as input is a lot of speech in a MEL spectrogram format. So I'm assuming here that everyone is aware about MEL spectrogram. It's a specific type of spectrogram which basically on the x-axis is your time, your y-axis is your frequency, and the colors which you are able to see is power or pitch at that particular frequency and time. Right, so you get a lot of data from a particular person. You train it on your model, you show that, okay, this is how a particular speech looks like for this particular person. So you have a generator, and then once the model is particularly trained, then if you write any particular speech, it will come out in their particular voice. Right, so how a cloned voice would sound like. So this is original Morgan Freeman.
There are those of us who like to venture to the unexplored, to see the beauty in the strange.
Right. So now, can we clone Morgan Freeman's voice? So it sounds something like.
There are those of us who like to venture into unexplored.
Right. So it sounds much more like him, and the expression itself is a bit more copied. That when the pauses were there, when the specific changes were there. So if you look at the spectrogram as well for this, this is something called a spectral roll-off. So those things are also changing. Means when there was a high, then there was a low, right? So this is how the modulations in the sound is actually happening. So this is what can be achieved with cloned voice right now. But going multilingual, let's say I have some content in English, and then I can produce it in English. That would be something which is amazing, right? Means, and in the source speaker's voice, that would be amazing. So this is what SRK's spectrogram looks like. And this is the spectrogram, what the English AI generated voice looks like. Again, if you look closely on the generated one, now it is much more, I would say, beautiful. It has certain kind of curves which are there, which represents emotion. It has different kind of power at different frequencies, which can actually be more relatable to the people. So let's see a video then. So it's from a very
प्यार प्यार दोस्ती है। अगर वो मेरी सबसे अच्छी दोस्त नहीं बन सकती तो मैं उससे कभी प्यार कर ही नहीं सकता, क्योंकि दोस्ती बिना तो प्यार होता ही नहीं। सिंपल, प्यार दोस्ती। लव इज फ्रेंडशिप। If she cannot become my best friend, then I can't love her, because love cannot happen without friendship. Simple, love is friendship.
We actually cloned SRK's voice from Hindi and cloned it for English. So the model which we are talking about here is something where we actually can clone a person's voice from any language to English. What I wanted to show was from any language to Hindi, but it is still in the making on our GPUs right now. Might take nearly 10 days more. So that is ongoing. But yeah, so the idea is, can you do from any language to a particular language? So suppose if we had content in Portuguese, let's take an example of that, and we give it to our model, it's a zero-shot learning there, and we can clone that person's voice in that from that particular language to English, and with the same kind of emotion. So if you heard in this thing, the pauses which he took, the way he said, it was actually replicated. So, but it's a single speaker thing, right? Means there is always limitations. So let's try with few more characters. So this is a trailer from the movie Donkey, which is recently released. Again, SRK references. I'm really sorry.
ये कहानी शुरू हुई थी 1995 में, जब मैंने लाल्टो में कदम रखा, where I found 4 duffers who wanted to go to London. बल्ली बाल काटता था,
बाल छोटे करने हैं। You can increase the length, do it.
बगू पिजामियां बेचता था।
Why are you showing me such big sizes? I wear small size.
Auntie, it is for your legs, not your fingers.
And with the same kind of intonations, these like you want the pajama for your legs, not your fingers, right? Means it was said in a particular tone, and we were able to replicate that particular tone. So the idea is that with this kind of technology, what we can achieve is distributing content in multiple languages, in multiple regions with the same type of emotions. So the connectivity factor becomes more and more and more. So that's it. That is it from my end. Happy to take any questions.
Yeah, thanks, Vibhor. Another question from Vibhor, fellow Vibhor. So this is 2 questions packaged in one.
Yep.
The first thing, you mentioned how the last part of the video where the person was showing saris and
yes,
they were talking about you showed the English translation as well.
Yeah.
You mentioned that the intonation is such which was probably there in the original as well.
Yes.
Now I understand and I believe that most of the Indians and even the native speakers, they speak their native language in a certain intonation.
Yeah.
And they might carry over some of that when they talk when they talk in another language, but it is very much possible that they have a certain type of intonation in that particular language as well.
Yeah.
So when I talk in English, I probably have a different set of intonation which I have probably learned along the way.
Yeah.
So when you actually do the translation, is it the intonation is carried over as it is in the original language, or is it like you also train on the intonation a person could have in another language?
Okay. Yeah,
I'll ask the second question later.
Yeah, so it's basically very interesting, right? It's a very valid thing that whenever you are translating, are you maintaining the same emotion, and is it actually colloquial or not? that let's say a person in India can relate to that kind of English, but person let's say in US might not be able to relate to that particular way of saying. So this is where I would say these all things are assistive technologies and not replacing technologies. So here you have linguists. Now they are enabled to do certain tasks. When they are actually translating, if the target audience is Indian folks who understand English, they have to translate in a particular manner. They have to use certain form of slangs, certain form of speech. Right, but when you are doing US, it might be that in India, let's say you say something like damn. On the other hand, in US, you might use some curse word. Right, so they have to change it accordingly so that particular feeling is retained. That is number one. Second is what we are doing here is that we are actually maintaining the source emotion, that if the actor is saying in a particular manner, it is actually set out in that particular manner only. But now, the idea is with our release, what we are doing is that we are giving the option to the user that if they want to change it, they can simply record, okay, say it like this particular manner, but maintain the speaker's voice. So they can just simply record it, and we will mimic your characteristics, your way of saying to that particular speaker, and then put it in the video itself. So that is how it will be solved.
Great, thank you. That probably answers my question as well. The second part of the question was, like while training and while working with this, and this is an open question to anyone who's also working in this kind of a setup, do you believe that, or do you think that it was easy to have a text-to-speech for certain languages over others? So for instance, in English, we sometimes have pronunciations which are very different for like similar looking words. Like for go, it is go, and for do, it is do.
Yes.
Although it might seem like, the intuitive thing is that O is following D, and it should be said in a certain way.
Yep.
But as opposed to Hindi or Sanskrit, which is said exactly the way it is written, because we don't have any other way of, we don't have exceptions per se. So is it easier to do that kind of a translation, like text-to-speech translation over certain languages over others?
So I would say that it actually depends on a lot of data, right? Why we went ahead with English over any other language for our first trial was for the reason that a lot of open source data set is actually present in English. And you have different type of phonemes particularly present for that. So while you are training that data, you have a lot of data sets. And as I mentioned, you have to take out that phonemes particularly and then train that, okay, this is how it particularly sounds like. Similarly, you have the same thing for Hindi and Sanskrit as well, right? That you have phonemes whenever we are saying something. So whenever the model is training, the model which we are training at the backend right now is doing that only. We are passing on particular phonemes on that this particular speech contains these phonemes, and it is getting trained on that. Now, with pronunciation part, when it is coming up, you can actually from the I'll give you an example of nature and mature, right? That's the most simple one which I can think of right now. So in that, if let's say if mature, it is coming as mature. So there is a pronunciation methodology that you can actually give that, okay, this is how it needs to be pronounced. You can give it to your systems, and then the characteristic change of the speech. So it becomes mature rather than mature. So this same thing can be replicated in different languages as well. Yeah.
Got it. Thank you. Thanks.
Hi, Vaibhav, it's me.
Yeah.
I mean, it's lovely work. Amazing. So I had a bit of a technical question. So I mean, you did show a lot of spectrograms, right? The
Yes.
Fourier analysis part. So does that get used in training as well, or do you use it mainly to visualize and understand how it looks after?
So actually all the training is happening using the Myles spectrograms only. So the way it is happening is, if I just go very, very basic on this particular part, whenever you are doing a speech to your machine, speech has no significance, right? Generally our models are trained on, let's take an example of convolutional neural networks, right? It's image based. You can do 1D, but it's majorly image based. So whenever you are training, you have to give a lot of spectrograms that this particular speech has this spectrogram, take out features from this particular spectrogram, attach it with the phonemes which we have given it, which we have given to the systems, and then train. Then look, okay, how a thing looks like. So you generate a lot of spectrogram, and then you generate a speech on top of that. So spectrograms can be changed into digital signals so that the wave file can be generated which sounds like human.
Got it. And so the second part to it was, so the LSTM things, do they work at the time domain or they can work at the, the spectrogram level?
So LSTM is required because for the referencing point of view, you need LSTMs on that. But now we have like attention, so that is a bit more better on that particular aspect because you know how the particular sentence has been said, and so you can modulate it accordingly.
Okay. So finally, as inputs, you're still giving the time domain signal along with the frequency domain characteristics?
So for inference, we are just giving an MP3 file, and it is just giving us back an MP3 file.
Okay,
so
the cloning part.
The cloning part. It is one shot, so 0 shot. You give it, you'll get the return in within a few milliseconds.
Okay, brilliant.
Yeah.
Thanks. Yeah. Hi, Vibhor. Great presentation. Thanks for that.
Thank you.
So I think emotion is multidimensional. You spoke about intonation and you spoke about volume modulation, leaving pauses and all of that. But have you considered the fact that even words contain emotion?
Yes.
In that, to give you an example, right? In English, you have this phrase of comparing apples to oranges.
Yes.
In some other language, it might be comparing apples to pears.
Yeah, definitely.
Would those things also add to this whole emotion thing? Are you considering it in your...
Yeah, so we can take it in a particular manner. Means, let's say you are shouting in English, right? English in general is a compressed language as compared to, let's say, Hindi. So a 3-second sentence in English can become a 5-second sentence in Hindi when you are translating it. Now, first thing which you need to focus on is that your translation needs to be within 3 seconds. So let's say when a movie is getting dubbed into multiple languages, the translators make sure that, okay, it is in a particular frame only, and the translation is according to that particular aspect. Now, let's say in your anger, you had an active voice in English, and your anger was on a word, let's say, cricket. Right. On the other hand, when you are dubbing it in Hindi, cricket can come first, and then the other word can be in the second part where the anger was there. So then that particular part would become angry. Now here the aspect of the linguist will come into picture, that how they are framing that particular sentence, so that the emotion, because ultimately it has to be with a video. So with the video, it is particularly attached, that anger is shown at that particular time frame only. So the words will remain. So coming to the second point. So like you're saying, oranges can become pears in a different language. So orange is like 0.3 seconds and pear is 0.2 seconds. So while pear is getting spoken out, pear will also become 0.3 seconds. It will become pear, something like a slower version, but with a louder voice. So it will become something like that.
Okay. I'm just asking, are you also working along those directions?
Yeah, so it basically, these kind of things are automatically taken care of, because if we are able to clone that particular emotion itself, it is automatically taken care of.
Okay, so it's not something that you explicitly...
That we don't have to do explicitly.
Okay, thank you.
Hello, I have a question here, over here. Also, thank you for your presentation. And you just said shouting in English, and I was thinking, like, is that English or a language?
That's an expression.
That is an expression. Maybe laughing is different in different languages. I was thinking, I have a voice, and it's pretty relatable to me, and it has a lot of emotions and stuff. And maybe I can reach out to you as a company to use my voice in some things, and perhaps if Shah Rukh Khan was in the audience, maybe he'd be happy or upset about this. Yes. So from your perspective in building a business out of this, what do you see as the opportunities and challenges of protecting like my voice or my identity, whether it's with working with or without such business?
So there always, with any technology, there has to be the responsible aspect attached to it, right? And with all the generative AI on the deep fakes which are getting popular, there needs to be some form of privacy and safety that needs to be maintained. So here what we are doing in the backend, we are putting one signature that this particular voice is created by our thing. So if we look into the signature itself, we can find that, okay, this particular voice is created by Fori. And the other aspect is we can create our systems. So first is policies, that the kind of policy which we have, you can only upload your data. That is why we don't allow YouTube links to be uploaded on our platform. You have to upload that data. So that gives one form of a guarantee that, okay, it is yours. Second thing is we can take down that content if that is reported that it is generated via our platform and it is someone else's voice. So those things we need to maintain.
Cool. Thank you so much.
All right, so in the interest of time, we'll have to wrap this session here. But feel free to reach out to Goa again during the networking.
Thank you. Thank you, everyone.
All right, so the next talk is going to be by one of our sponsors, Embody. So it's by Dr. Kaushik Sundar and Krishnan Subramaniam. And the title is Virtual Studio Production Tools with AI-driven personalized spatial audio for immersive mixing. So a round of applause for both of them.
Hello. Okay. Thank you so much. All good? Okay. Oh, yeah. I have to share the screen. I need to go back to the first slide. Thank you. Thank you so much. Thank you. I would first like to thank everyone to be here. And thank you all the organizers. It's been an amazing conference. To see so much of such a thriving audio community in my hometown, it's been absolutely a pleasure to be there. Thank you so much. So today, my talk is going to be on virtual studio production tools with AI-driven personalized spatial audio for immersive mixing. So a lot of spatial audio and immersive stuff in this particular presentation. So I'm Kaushik Sundar. I work for Embody. Embody is a spatial audio startup based out of San Francisco Bay Area. I have my colleague here, Krishnan Subramaniam, who's a sound designer at AM Studios, and he works with AR Rahman. AM Studios is one of the main studios that AR Rahman works out of. So yeah, we are going to collaborate on this particular presentation. We are going to talk about virtual production and all things spatial audio. I want to first give a quick primer on what spatial audio is, right? Spatial audio is the art of creating an immersive sound experience that mimics how we hear sounds in the real world. So that is one part of it, how we hear sounds in real world, right? The other part of it, you can extend this, extrapolate this to creating soundscapes, immersive soundscapes that does not exist in real world. That is more virtual. You know, you can have AR, VR, XR environments. You can enhance the immersive experience with spatial audio. So our vision, we have a 180-degree field of view, but audio, our ears have a 360-degree view. So why not use that, right, and create immersive soundscapes? So a couple of interesting basics about spatial audio and how we as humans localize sounds, right? How do we localize sound? How do you know if a particular sound source is coming from the left or the right or the front or the back or the top? So we primarily use two different cues. One is the timing differences between the two ears and the loudness differences. So in this case, for example, you have two sources A and B, and based on where the source is with respect to the two ears, you know if the sound source is on the left side or on the right side. So same thing here, like you have a sound source, you have microphone at position 1 and microphone at position 2. Now there is a block in between them, so the sound at microphone 1 which is, you can consider that as one of the ears, is more intense than the other ear, and it also reaches sooner in one ear than the other ear. So you know that the sound source is generally in this particular area, right? That is two of the very important cues that we as humans use in order to localize sounds. Now, so this is what I was talking about, and these two cues are called the interaural time difference and the interaural level difference. So interaural time difference is the time difference between the left and the right ear if there is a source, and the interaural level difference is the level difference between the left and right ear, right? What is simply fascinating is these time differences for any source between the left and right ears are incredibly small. Now, if you look at this particular figure here, so you have I as a human head, I'm right at the center. Now, if there is a sound source right in front of me, there is an ITD of 0 microseconds, right? So which means the sound reaches my left and right ear exactly at the same time. The same source, let me take it right behind me, the same thing. The sound reaches exactly at the same time between the left and right ear, right? Now, there is a position where the time differences are the maximum, that is at the extremes. So something like the left extreme here, you see that the time difference between the left and right ear is 640 microseconds. Again, this is generally, it's different for different humans. It depends on the size of your head, but generally it's around this range, around 600 microseconds. So the next time you realize that the sound is coming from this particular direction, your brain is actually decoding this 600 microseconds and it knows that the sound is coming from this direction, which is simply fascinating. Now the same thing with the level difference as well, right? So it understands the time difference and it also knows that there is a level difference between the left and right ear. Now, what is interesting is, I mentioned that, right, for example, let's look at 20 degrees over here. The time difference is 200 microseconds. And if you look at 160 degree, right behind, symmetrical location right behind you, that also has the ITD as 200 microseconds, right? And the level difference is also the same because it's a symmetric location behind your head. Now, in this case, this is what we call as a cone of confusion, where we often get confused between sound sources which is in front of you versus sound sources right behind in a symmetrical location. Now, in order to, if humans were to localize just with time difference and level difference, then we would get this confusion all the time. But that doesn't happen in real life, right? So we actually use another set of cues which is dictated by your external ears, the pinna, right? So these are called the pinna cues, like the pinna spectral cues. So what happens is when you have a sound source, it reaches your body, your body, diffracts it, and it reaches your external ear. You have a lot of reflection, diffraction, all kinds of things going on in both the left and right ear. And then what happens because of this, there are certain frequencies that are amplified and certain frequencies that gets cut out. So there's a pattern of frequencies that is created at the eardrum for you, right? And this pattern of frequency is very, very unique to you as an individual. So our human brain knows this pattern of frequency for every person. Like it has learned through my childhood what this pattern of frequency is for me. And that's one of the other cues that I, as a human, used in order to disambiguate between a sound source that is right in front of me versus something that's right behind me. So all this together, we spoke about the interaural time difference, we spoke about the interaural level difference, and we spoke about something called the pinna spectral cues. All these three things are encapsulated in something called the head-related transfer function, or in short, HRTF. So in spatial audio or binaural audio, you'll be hearing this term HRTF quite a bit, right? But this is what HRTF is. So when there is a sound source, if I put microphones at my eardrum, I'll see a pattern of frequencies at the eardrum. That is what HRTF is. Now, what is very unique about HRTFs and our human ears in general, is our human ears are as unique as fingerprints. So what happens is the HRTFs for every individual is very unique because the pattern of frequencies that is created at the eardrum is very different. So in a hypothetical scenario, if I replace my ear with someone else, I'm going to start getting all these confusions and localization issues. I cannot localize clearly. This is because my brain is very used to my set of pattern of HRTFs, my set of pattern of frequencies at my eardrum, which is unique, very, very unique to me, right? So it's very important to know that HRTFs are highly individualized, highly idiosyncratic. Now, this particular graph shows how different HRTFs are. So what this means is this is a set of pattern of frequencies measured at the eardrum. So suppose this is some subject, some human. We place microphones at the eardrum. You see there are notches at something around like 7-8 kilohertz and 11 kilohertz, and then there are peaks. For a different subject, these HRTF patterns are different. So these notches are very, very important for human sound localization. And you note that these notches, the pattern of these frequencies, HRTFs, are very, very unique for every individual. Now, it's also a painful task to really measure these HRTFs, okay? So one of the things that I was talking about, like how HRTFs are very unique, and if I swap my ears with your ears, how we get localization confusions. These confusions are typically of this particular order, right? You often have front-back confusions. So if I'm listening a binaural audio of a generic HRTF, for example, what happens is you often, if there is a concert going on in the front, if you close your eyes, you would actually think it's happening behind me. So there's these front-back confusions. There's elevation confusions. Often sound sources you perceive inside the head. There is no externalization. And then there is a lot of tonal coloration. So it's very, very important, even if you're synthesizing spatial music, spatial audio, especially for localization purposes, you really need to have personalized HRTFs. Now, how are these HRTFs measured, right? You have to place a human. If I need to measure HRTF for you, for example, I have to take you, place you in an anechoic chamber or semi-anechoic chamber in a lab, right? Place speakers all around you and play sine sweeps in order to measure the impulse responses at your eardrum. Now, this process is extremely time-consuming, and it's very, very painful. I've spent a great deal of my career measuring HRTFs, and it's still one of those things that I really hate to do. It's very, very time-consuming. But the cool thing is you appreciate what your human ear does on its own, even without all these measurements, right? So it's main thing to note here is HRTFs are extremely, extremely difficult to measure. It takes a lot of time, and you need a large setup and money. Now that we have understood some of the basics of spatial audio, HRTF, let's come to the topic of the presentation. Virtual production tools. What do I mean by virtual production tools? Why do we even need it? Immersive content is on the rise, right? Like especially on headphones. You have AirPods Pro, and you have the headphone market is huge right now. Most of the music consumption, audio consumption is on headphones right now. The amount of immersive content is also huge, right? You have Dolby Atmos right now, Apple Music having spatial audio, Apple TV, Netflix having spatial audio. So just the content, immersive content is huge. With AR, VR, XR as well, there is so much immersive content and so much need for spatial audio, right? On the flip side, you do not have a lot of studios which has this Dolby Atmos setup, which has speakers all around you, right? If I, as an independent producer, I don't have the money to really place all these speakers in my house, then I need to find an alternate solution to mix spatial music. So that's why there is a need for immersive mixing on headphones, which does not cost millions of dollars in order to place speakers all around you. The goal of this virtual production tool is to virtually produce, mix, master immersive music on headphones in some of the world's finest music studios, right? You don't need to travel to the best music studio today in order to mix spatial music. So that's the goal. In order to do that, there are three important things. If I want to transport you to that particular music studio while you being here, I need to do three things. I need to model the acoustic space of that studio accurately. Second thing, I need to model the human ear. I need to model your ear, right? And how you would perceive music in that studio if you were there. And then I need to model the playback medium, which is the headphones. I need to compensate, I need to know what headphones you're using, and I need to compensate for the headphone response. We'll talk a little bit about headphones very soon. Now, the thing that we have been doing at Embody, I spoke about how hard it is to measure HRTFs. And I did mention that in order to virtually transport you to that particular studio over there, I need to measure your personalized HRTFs, right? So what we do, we've come up with an AI-driven personalized HRTF methodology where you just take a video capture of your head and the ears, and then and on the cloud, we do a 3D reconstruction of the ear, and we use neural networks to predict your personalized HRTFs. Typically, measuring HRTFs in an anechoic chamber takes several hours. This particular method takes only 30 seconds. There are quite a lot of papers that we have published on this particular topic. If you're interested, you could look it up. But what we did here is we took this elaborate, complex process of measuring HRTFs in a studio lab, and we made it very frictionless to an end user where you can just use a smartphone to basically capture your head and your ears and get your HRTFs. So what we are doing is we are factoring the user design. It's easy for the user, inexpensive for the user. There is the perceptual experience. All our AI models, of course, at the end of the day, you need to have a ground truth. We developed this whole training data set. We measured hundreds and thousands of people. And then we also did localization experiments to make sure our AI models, our predictions are really good. And then everything happens on the cloud. That is the first part, modeling your human ear, modeling the personalized HRTFs, right? The second part, as I mentioned, is measuring the studio acoustics. On the left here, this is the dummy head, the BNK HATS dummy head. We are measuring this dummy head. This particular studio is Alan Meyerson's Studio M, which is Hans Zimmer's studio. On the right, we use this dummy head. We are measuring the studio here. This is AM Studio, which is A.R. Rahman's AM Studio. We have Krishnan, who will be talking a little bit more on that. What we primarily do is we take this dummy head to these studios. We place the dummy head in the place where a mixing engineer would sit. And then we measured binaural room impulse responses at the ears of this BNK HATS dummy head from every speaker in the studio, right? And then we also captured the speaker responses. We also captured the entire signal chain that the studio has, right from the console and any EQs that the studio has. So everything is captured in these binaural room impulse measurements. So the measurement procedure is pretty straightforward, a pretty common acoustic measurements. So what we do is we have the BNK 4100 HATS simulator. We have an excitation source, which is a speaker. It goes through a preconditioning amplifier, and we use the RME UCX as this is a sound card. You can technically use any sound card. And we use sine sweep methods in order to measure these impulse responses. One key thing that I want to mention is personalizing even the binaural room impulse response. So if you look at any impulse response, any room reverb, you have the direct path, which is the very first signal, and this is the direct path from the sound source directly to your ears, and then you have some early reflections followed by the mid and late reflections. The early reflections are very, very important for localization. As human beings, apart from the 3 different cues that I mentioned, we also use the early reflections to get an idea of sense of space. And how large is the space. Even if I close my eyes, I do have an idea of how big is the space, that it's some kind of a hall and not like a small room. And a human brain uses these early reflections. The key thing is the early reflections has some of your ear features. So what we do is once we measure the dummy head, the binaural room impulse response with the dummy head, we replace the dummy head's ears with your personalized HRTFs and personalize the early reflections as well. So the early reflections now also has your ear characteristics. Something about headphones. It's very important to know, and this is something not everyone knows about, is headphones are not acoustically transparent, right? What goes into the headphone is not the same thing that comes out of the headphone, right? If I send a flat spectrum into a headphone, no matter however good the headphone is, it's going to do something to the response. And sometimes in a good way, sometimes in a bad way. But it's important to know what it is doing to your original sound spectrum. This is a very interesting plot here. This is the headphone responses of pretty much like close to 300 headphones out there in the market. And you can see the variability here. Like every headphone is different, and it is so different. The variation is extremely high. So you do need to account for the headphone that you're using. So how do we do that, right? Like suppose this is the headphone, you have the headphone acoustic transducer, you have the headphone foam, and then you have what we call the headphone ear coupling. Now, the other crazy thing here is if I place a microphone in my eardrum and I place a headphone and I measure the headphone response, right? It's very different from when I do it on your ears. Why? Because again, your ears are coming into picture, and like we discussed, ears are very unique. So again, headphones, the way it interacts with your ear, the way you place it on your ear, makes a huge difference. And all of this affects typically the high frequencies, and high frequencies are very, very important for localization. So headphone equalization or headphone compensation is also very, very critical in this. So in this virtual production tool that I explained, the overall architecture, if you look at it, you have an input multi-channel audio, right? Like it can be Dolby Atmos or any surround format. We apply the personalized HRTFs first, which is predicted using the machine learning techniques. Like I explained, you have a video, you take a video of your head and your ears, it predicts your personalized HRTFs. And then we have the studio acoustics that we measured, obtained by binaural room impulse response. We apply the speaker response in order to simulate the speakers of this particular studio. Other key thing is the speaker delays. Often in studios, you have different set of speaker delays applied to all these different speakers in the studio. And then finally comes the headphone EQs, and you have the output binaural audio. So this is very interesting. So what we did is we have been virtualizing, simulating different studios in our product. One of the key partnerships that we have is with AM Studios, with A.R. Rahman's AM Studio. I would like to invite Krishnan, who's going to be talking about how we approached. So there is, like I explained the math and the science behind how we are doing this virtual production. But at the end of the day, engineers like Krishnan, who are in the studio working day and night, they know the sound of the studio perfectly, right? So they are the ones who listen to this plugin, listen to the final sound, and judge how close does it come to the speakers. At the end of the day, what we want to reproduce is, if in the plugin, on the product, when you listen on headphones, you would actually feel like you are in that particular studio as if you're sitting in real life. So yeah, Krishnan, that's all yours.
Hi, I'm Krishnan Subramanian. I'm sound designer, re-recording mixer working for AM Studios. My part of this entire chunk is pretty easy, more like an end user and major chunk of the work done by the Embody. Before I get into the subject, just a small story which will help the reason why the whole process is very useful. So when I did my post-graduation, we had only one studio, and both undergrad and the grad student, the post-grad student has to use that mix stage to do all their work. So it's more like 1:20. So major chunk of our work done in the headphones, and then we take to the mix stage and we work on it. Initially, when I started, I still remember my first time when I did my mix in the headphones, and those are the days that you thought that you can give tips even to Randy Thom. So I played it in the mix stage, it fell flat, and it doesn't even make sense. It was sounding so nice in the headphones, and then you go to the mix stage and you feel that something is not right. Then I realized that whatever that you're doing in the headphones is not going to translate exactly. So initial days, what I did, I learned that you need to adjust your workflow when you're working with the headphones. Do some basic EQs to make sure that whatever you're doing in your headphones translate in the mix stage. So what I thought was that when I heard about this from Kapil and Kaushik, I jumped onto it because it was a huge struggle initial days for me to understand the translation from headphones to the mix. So I thought what they are going to do is going to be a huge help for the future generation. So if this is going to work, anyone who's going to work outside, who doesn't have access to the major chunk of studio, can still do their decent chunk of work, come back to the studio and tweak stuff. So that's the first point. Often, the challenges when you work with the headphones are that it's misleading. It feels like when you work in the headphones, everything is done. It's almost there until you take it to the main mix stage, realizes that there needs to be more work. And each headphone has their own coloring. You need to understand what sort of headphone you are working on it. And what happens because of this process where you do major chunk of your editorial work in the headphones and then come to the mix stage. In the mix stage, instead of doing the actual mix, what you will do is that you will be focusing more on the editorial process, doing corrections rather than focusing on the creative part, where major chunk of your energy is being wasted on the editorial work rather than spending time on the actual mix. So these were the challenges. So when the initial part of the process was the dummy head was taken to the AM studio, they took all the readings, and they took some time to give us the first build. So once we received the first build, what we did was that we were comparing our mixes running through the actual studio space with the plugin with the headphones. So we were basically doing A and B with the plugins. And we were giving them feedbacks like how it could be how it could be calibrated further to make the experience, to make the plugin sound as close to what we listen inside the studio. So that process took almost a month. And during the time when we received the second build, what happened was that we thought, I personally thought that I should try out on a real project. So I asked one of the collaborators, I asked the director if I could start working, use this plugin, do the entire chunk in headphones, and then can we just test it out? So that was, it's a short film called Kodai, and we worked on it. I completely used this plugin from the scratch, right from the editorial, design, and the mix. And it was quite fruitful, though. What happened was that when I finished the work in the laptop with my headphones, with the immersive plugin, and I took it to the AM studio to check, what happened was that most of the EQ decisions were almost there. Well, the changes that I did with the director were all on the creative side. So what I realized was that with this plugin, the major chunk of editorial process could be saved, and the actual focus could be more on the creative process, which could be useful for everyone. So it's a win-win situation for the producers, the studio, and the engineers, and the director. And Any questions?
Yeah. Good. Yeah.
So thanks, Kaushik. Really interesting presentation. I couldn't help but think that you talked about HRTS and also binaural hearing. Have you ever worked with, and this is like not a technical question per se, but just out of curiosity, have you ever worked with people with unilateral hearing loss? So for instance, who can only hear from one ear and are deaf in the other ear? And how does HRTF work in that? And if you've ever had that kind of an experience.
I haven't worked with like completely tone deaf on one ear, like unilateral hearing, but we have worked with definitely with partial hearing loss. And I must say that, so even when you have partial hearing loss, your human brain, like on their own, they have kind of figured out the localization, right? It's not that the localization is extremely poor because of the partial hearing loss. So it translates pretty well when you have their personalized HRTFs over there. I would imagine the situation is a bit different if you are completely unilateral hearing, because you don't have any of the interaural cues and you probably only have the spectral cues. So even if you have some localization, for sure the externalization is not going to be that great. Yeah.
Thank you. Thanks.
Thanks, Kaushik and Krishnan, for your presentation. It was great. I have seen something like this before. I think Waves had a plugin along the same lines. But my question here is, you said you also model the headphones, right? Do you also factor in the age of the headphones? Because the longer you use it, the characteristics change, because it appears that you're using a generic, like let's say for the DT 900 Pro, whatever IR you have, you'll probably just apply it on the final mix, right?
Yeah.
Do you also factor in the age? Do you also factor in maybe the non-linearities of the headphones or the speakers? Speakers not so much, but headphones mainly, because that's what you hear from. And is it such a big deal? Is non-linearity such a big deal after all?
I mean, so first of all, for the first question, Waves NX, it does similar stuff. They basically primarily model Abbey Road Studios with head tracking, but what they don't have is the personalized HRTF component, and that makes a very, very huge difference in overall experience. On the headphones, non-linearities, yes, makes a huge difference, but not so much the age. Like when you, I mean, again, it depends on when you say age, you're probably not talking about decades. In that case, we should probably not use that headphone at all. But over a set of few years, I mean, the frequency responses, they don't change a whole lot.
Okay, yeah. Thank you.
Hey, nice presentation. I had a question regarding the scanning process for the HRTFs. So I witnessed the demo and I noticed you scanned the entire face using your iPhone. And is it photogrammetry? I'm just curious about how the processing is done, and because it was pretty quick considering that it made a 3D model of the ear. So
yeah. So we converted to point cloud and meshes, and then get a 3D reconstruction of it. Over time, we've gotten better, like the times of measurement, because again, this is a one-time process. Like you get this thing good enough and to an extent, and then you can start using. And we're constantly updating the models as well. So when we update the model on our end, on the product side, you just get a notification that there is an update for your model. So we're constantly improving the models as well. But yeah, to answer your question.
Yeah, because it was interesting how accurately, like considering it's making a little 3D model, how quickly. Thank you.
Hi. So along the lines of his question also, other than the outer ear and the external features, also the psychoacoustic aspect, like have you come across, say, somebody based on your system where you generate your HRTF, but it still doesn't sound right, though it's physics perspective, everything is fine. But so in that case, how do you adjust it to make it work?
So it's a two-part question. I think the first question is it's interesting because it's fascinating that not all humans are good localizers of sound. Like I'm a decent localizer, but some are extremely precise localizers. Some are terrible at it. Right? They cannot, even though there is absolutely nothing wrong about their hearing, they just cannot localize a particular sound, right? And it's important to know that all our models, everything, right? We are trying to, your ground truth is kind of measured HRTFs. You can only get as good as your measured HRTF, right? But what is interesting is we also respond well to training. I can train myself to be a better localizer. You know, if I wear some headphones and I'm constantly told that, okay, this sound source is coming from there while I'm localizing it over there, and I'm telling you that make an adjustment of 15 degrees. Our brains are really good at learning the tonalities there, what is the difference, and readjusting it. But at the end of the day, you're going back to your real life. You know, so you're learning again the things that you're good at. So there is a lot of learning involved. There is subjective learning, which is a lot of studies that does it, and it does work well.
I have a question. First of all, yeah, I really enjoyed your presentation, and the demo was mind-blowing. But again, sort of building on their question about the scanning process, when you're taking a video of the external parts of your outer ear, I'm wondering what sort of an impact does the middle ear and inner ear actually have on this model, and is there a way that you're accounting for that, if it is not insignificant?
It's definitely not insignificant. It's very, very significant, and we do model the inner ear. But the thing is, it's not as unique as the external ear. So we do have some standard models that we use in order to model. So typically, I don't know if I have it here. Make it quick. Okay. The effect of the ear canal is often this peak at around 3 to 4 kilohertz. That's what the ear canal contributes. And you look at any person's ears, the spectrum, you will see around that region you have a peak in your spectrum around that region if you're doing any measurements at the eardrum, which has the ear canal.
Great presentation. I just discussed with Kaushik before with that headphone. It's working fine. Only thing I have to just know that that height is that ADCx dealing with the ILD, and if it like to second question to Krishnan, like how you really getting when you mix with the headphone, and are you really getting the top, and how you dealing with the LFE? How you treating with LFE?
So what is the first question again?
When you dealing with the ADCx, so are you using the ILD for that?
Yeah, so ILD for sure, but often most of the height cues, how we as humans perceive anything that is above you or below you, is because of the spectral features. Especially these notches over here. One of the key cues is this particular notch. For this particular human, as it goes up, as the source goes up, this particular notch will move higher in frequency. So that is one cue. So, and again, the number of notches. So those are some very important cues for height perception. And that's why you do get a pretty good height perception here, because we are doing this personalized HRTF prediction over there.
With the low-end LFE, I think when compared to working with other plugins, the signature edition has more options. Like I could actually, normally what I will do is that I will not take any of the low mids, low low frequency decisions with the headphones. I'll leave it to the mix stage. But with this plugin, I could actually take few of the creative decisions using the plugin itself. It's quite nice, especially how the low and the low mids are translating through the plugin. And the height layer, it's still, I'm coming to terms with it. Like, it's not that much of a decision could be taken when it's spinning over the top or it's here. So I don't focus too much on the height layer.
Yeah, because I just take the headphone, but I'm not really that much in the top.
Yeah, the translation and the pan around your head is pretty evident, but then when it goes to the top, it's still you're working on it.
Even I try with the Apple AirPod also, it's all not getting the proper, So it will be, you have to think about it.
But when compared to other plugins, the lows and low mids, the translation is pretty good with them.
Thank you. Yeah. Thanks for the presentation. I think it was very good. So my question is, now since we are talking about HRTF and you say that it is unique for every individual, which makes sense, from personal experience, I would assume, between the left and the right ear, that also would be a significant or at least a bit of a difference. So I wanted to know, how maybe you have thought about that or factored that in as well.
Yeah. No, absolutely. You're right. There is asymmetry in the left and right ear, and which is very important factor in sound localization, because if your ears were exactly the same, your ITDs and ILDs are going to be same through. We do factor it, and if we have, I would encourage everyone to check out the demo. We have it outside, and there is a scanning process that we do where we actually scan both the ears, and we actually predict the left and right HRTFs separately. Yeah, I would encourage everyone to check out the demos and give us feedback, and yeah, listen to it. Thank you.
Yeah, so I have some questions from the YouTube chat as well, the live stream. So there's one, there are a few of them by the mastering project. So first one is, how is the overhead and back speaker positions accounted for in the HRTF?
I'm not very, very clear about that question, but
so basically, like how the height layer is being
accounted. I mean, if the studio has those speakers, like for example, AM, we have the overhead speakers and the back speakers. I mean, we do measure every speaker, so we are able to, and we measure even the exact position of these speakers. So that's how we can account for these HRTFs. That makes sense.
The second question is, how is a room with no reflections or very minimal reflections, BR, IR, accounted for distance?
How is
how is a room with no reflections or very minimal reflections, BR, IR, accounted for distance?
Okay, I'm going to guess what that question exactly is, but I think the question is, if there are no reflections, how do you account for distance?
Yeah, because like the studios live there, the reflections are cut.
Oh, okay. Yeah, I mean, if the room does not have any reflections, then it does not have any reflections. It's a anechoic, semi-anechoic room. There is nothing to do over there. Accordingly, the distance perception is also going to be bad. Even as forget about headphones, but as a human, if you just go in a room without any reflections, you're not going to get a whole lot of distance perception. So the localization is going to be, distance localization is going to be pretty poor.
Okay, next one is, how is the low frequency accounted for the main speaker and the LFE channel when monitoring on headphones?
Yeah, I mean, first of all, on the measurement side, we do measure how the exact low frequency specs of the subs. And then we do a lot of careful tuning of these LFEs when it comes to the final sound. Probably you can answer a little bit
And
more.
also like the workflow that we are following is that we are sending the signal to Dolby Production Suite, and the sound is going to come, the LFE channel is going to go straight to the immersive bridge, and from the immersive bridge we are going to listen to it. So it's the actual reflection of what's coming through the LFE channel.
And the last question is there any form of gain reduction or limiting happening so that the binaural downmix that happens for the headphone doesn't clip when the speaker summing happens?
Oh, that's a great question. The answer is no. We don't do any gain reduction or limiter. We have an option of a limiter on the plugin, but that's not a decision we as plugin manufacturers do. We make sure is our entire processing chain is in such a way that the levels match really well with the stereo downmix, but we don't do any gain reduction as such.
And the limiter can be switched on and off. It's
Yeah.
not. It's not like always on. You have the option to switch it on and off.
Yeah. Okay. Thank you.
Thank you, everyone.
All right, so it's a great presentation, and just in case you have not already experienced this whole thing, you can still do so in the ground floor foyer. The embodied team is available to do that. Yeah, I mean, I think this is also like a great example of artists and developers coming together, right? So there is somebody who can code stuff, and there are people who need this specific scenario of, oh, you know what, we have only one studio, and we don't want to mix in headphone and have a different experience, and these two entities collaborate, and you get this. So, I mean, whatever was shown before. But I think it's also like an inspiration for all of us to maybe use these moments, because in the audience we have artists, we have sound engineers, we have developers, we have hardcore developers, and yeah, it's a great moment to make that happen again. So one of the main agendas, and this is going to be an emotional moment for me. So one of the agenda for ADCx India has been to bring people together. And we thought, why not do that? Why not literally do that? So we would like to invite all of you on the stage so that we can actually be together. I'm not kidding, yeah. Please join. Hello, hello, hello. Yeah, okay. So now the idea is that we are going to have another networking break. We will be back at 4:30 p.m. And some exciting stuff is remaining, by the way. We have a panelist. We have like bunch of panelists who will be here on the stage. We'll have a discussion about building an ecosystem in India where everybody is required. We also have a few more talks remaining. And then we are also going to reveal some of the hacks that were done the last 2 days. So yeah, just be prepared for that, and please be back by 4:25-ish so that we stay on track. All right.
Um, Yo, yeah, yeah. Join with computer audio essay.
Ableton. Wimbledon Live.
Yeah. Oh yeah, should I make this one? Oh, okay. He was there this year.
Why? Huh. So I have no shame, but yeah, yeah. I mean, basically, oh, मेरा voice clone हो रहा है यहाँ पर. हाँ, ethical dimensions.
People who go there.
I mean, in that folder, remove like all the non-DSP DLLs. Can we just start when you? Yeah, great. I think if Ableton will select the switch output, it will come because we saw that output. I think these two will test out. Yeah, a bit later. Come on, we can. Should I?
Thank you.
Get out of Zoom right now or Zoom as well? Yeah, Zoom you can just stop sharing. You can be on Zoom.
Yeah. So ugly to see yourself. Sorry. Yeah. As a name, it's just I changed. Okay.
You don't have some switch.
Oh.
session. So now we have. So now. Check. One. It's coming from this weekend. It's fine. Check. It's from the Zoom. I think. Switch. No. Can you get the audio on the stream? Hello, check. Yeah, perfect. All right. So yeah, let's continue with the sessions. So we have an interesting talk about RNNs and Hindustani music by Tejaswini Kelkar. A round of applause for Tejaswini.
I'll share screen. No, I have shared screen.
With sound?
With sound, yeah. But there's no screen on the screen. Ah.
Just a heads up. Audio.
Yeah. Yeah. What a shit software. Yeah. Okay. It's not feeding back, and hopefully everyone can hear me if I'm not hallucinating about the speakers. Today I'm going to probably be talking about RNNs and Hindustani music, which means that that's my shoehorn into something else. About my work, my name is Tejaswini Kelkar, and I am an associate professor at the University of Oslo in music technology. And I'm teaching on a master's program called Music Communication and Technology, and that's what I do for work. I wrote my PhD thesis on melodic embodiment, which is a little bit different from the auditory embodiment stuff that we were just listening to, but I'll come to that a little bit later. In my life, I studied North Indian classical music for an absurd number of years, after which point I was interested in computing and trying to model what was happening, but everywhere you look, there is this idea that pitch is what needs to be modeled, and pitch is a sequence of symbols, and these symbols can be modeled, but what it is has no real definition. This is the oldest one that I could find, which is pitch is the stuff of which music is made. It's a pretty succinct and beautiful definition, but obviously does not talk about Fourier transforms. This is how music is notated in North Indian classical music, as many of you might know. And it's a very symbolic world. So the text of what is to be sung in the khyal is the second line, and the top line is the notes. V.N. Bhatkhande, who developed this notation system, borrowed, of course, heavily from the Western style. So there is also always this kind of conflict of when we're talking about oral traditions and trying to model them using their written versions, which are maybe 100 years old at best, that we need to keep that in mind. So what I was doing with this material initially was trying to build a repository where all of this information could be contained. So I wanted to build a visual, kind of a scrollable map of conceptual ideas within the space of rag. Because when we are speaking about rag and the number of types of which there are, there is always this notion of proximity and distance, right? That some rags are more like each other and others aren't. And I was trying to build this algorithm which would map them using a series of only symbolic references with various different features of rag included in them. And within the symbolic world, I was also interested in mapping how other conceptual spaces would kind of lay upon this chart neatly. So I was looking at, of course, timing and the relationships of consonant and dissonant notes to each other, and which of them kind of tend to cluster around each other. And we kind of landed on this thought wheel of which multiple iterations have been shown during this day. But what I was interested in doing with this was not just to the level of being able to map rag on space, but also think about what kinds of relationships we can draw. And I was thinking about this thing called the color wheel that many of you might be familiar with while working with graphic design, which rotates on these ideas of hue, value, and saturation. And I thought it would be a really interesting metaphor for rag map, because one of the things that you can do with color wheels is to draw out lots of different types of combinations of these elements, right? So I was looking at harmonious, dissonant relationships and triangulated relationships and those kinds of things, which then we can find for rag from this rag wheel. So while working within this symbolic space, I got interested in recurrent neural networks, which are composed of recurrent layers. So there are multiple layers within the network, out of which one of them also feeds back into itself. So it's a forward and back propagation, where the hidden layers can also have a different time chain composition, which can make kind of things unfold within time. And RNNs are used a lot for sequence modeling, including, for example, genetic sequences and so on, like Gattaca and so on. And I thought that's really nice. We have a conceptual space of from 5 to 12 letters at a time. And it's just kind of this space of letters that rotates around in rag improvisation, right? So you start from small phrases, and then maybe notes get added or subtracted, paused, emphasized this and that. But then they're always notated within these kind of long sequences. So I was trying to model these with an LSTM model for sequential modeling. And there are two kinds of typical problems that arise while trying to do RNNs. This was really popular in way back when, in like 15 and 16, to do text modeling. And the reason that I'm in today's talk approaching sequence modeling through RNNs is because despite LLMs and blah, 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 other technologies of sequence modeling that have come very far, there are these kind of typical problems that still kind of continue to arise. One of them, which is repetitive sequences, and the other one is that things get emphasized that did not need that much emphasis, also called vanishing and exploding gradients. And I used this corpus called AU Trim, which was a project between UVA and NCPA, where there were transcriptions of a lot of sung material. And then I was able to create kind of this long list of what was supposed to be Khamaj. Khamaj is a rag that you learn quite early, maybe year 2, 3, something like that of your training. But it's not really that simple to kind of be in this rag. It's a complicated space. And what does it mean to be in a rag? Well, it is kind of just an exclusive property, which means that means that you're not in another rag. And that's really just it. But the conceptual space of what it means to be in either of these spaces is not really neatly aligned. It's also kind of socially deterministic. And I think while learning kind of sequence modeling and things like that, we really should remember this property of something else that might be going missing. However, as we will see later on, I was able to use some of these RNN outputs in creative work where I didn't want to compose anything. Creative work using computing is often lazy work. But this is not the way in which I studied in the Hindustani classical music, which looked more like this. Where in front of a person gesticulated, that you repeated and gesticulated. And exactly this aspect of hearing, which is not just related to notes and note timings, is really important to me. So audition is not really just a single sensory. It's not just a singular modality. Of course, as we've seen earlier today, hearing itself is not unimodal itself, on top of which kind of the metaphor of melodic and rhythmic material gets even more complex when it comes to how we react to it with the help of our bodies, as illustrated by air guitar contests and lip sync battles and performances gaining popularity. This is what was the thing that interested me within improvisational space of Hindustani classical music, because it was not only not recommended to avoid gesture, but it was almost impossible to avoid co-gesturing while you're singing. But we might think that this is some unique property of Hindustani classical music. It really isn't. This is an old French impresario, very problematic man. But what I was looking at was something like kinematic modeling, which is used a lot for signature sequence modeling. So I was trying to use these ideas that also appear in early notation. So this kind of clean note-based notation is much later than early notation, which looks like the one on the left, which is, they were called neumes, which were kind of melodic lines drawn on top of words in order to tell people how to sing. But on the right, you can see Tibetan chant notation, which also looks very much like this. And you can hear a Tibetan chant that's probably sung from a piece like this. It's not the same piece anyway. This concept of kind of moving lines also influenced some of the earliest work done in not just Fourier transforms, but music analysis. So at the time of kind of mellographs and phonophotography, referenced here, where people are trying to really map pitch heights in various ways. So what I did was get people in the lab to kind of make a phonophotography by themselves. So if they listened to a melody and then they had to draw what they thought the line went. And here are some examples. The categories chosen are kind of 4 phrase categories, contour categories used in Hindustani classical music, where kind of ascending, descending, kind of back and forth, and stable are kind of the big 4 contour categories that are used in phrase modeling. And why we are talking about phrase modeling, I will come to in a bit. These are some outliers from my experiment. The one on top is someone who played harmonium, for whom their spatial model was very much related to harmonium, and one on the bottom is a child, which, as you can see, the gesturing is much more free and not related to, I don't think they've seen so many graphs in their life yet, they're just 8. So what we did from this was that if you're able to model contour, then can you regenerate phrase information or recreate? I think we've heard about 7 or so times that RAG, what was it? RAG framework is not just about notes, etc., etc. But what is in the framework, right? So I was looking at how to model kind of generated phrase based on contour categories. If you're interested in the math of it, then we were using kind of knotted splines for modeling. And them using rules. What notes should be weighted? Notes should be weighted less. Notes can and cannot have stop conditions, so you cannot pause on here, just as we have multiple. And so on. The idea about gesturing that is most interesting to me is that of gesturing as visible utterance. This is from Adam Kendon, but what we also know from kind of behaving in music is that suppressing gesture, even during speech, is actually cognitively really heavy. So if you're doing a task and you're asked to not move, stay absolutely still, then you're going to take longer to perform the same task that you can do in a shorter time if you're able to move freely. And this sort of thing is really interesting to me because gesturing is seen as this kind of overflow, kind of excess production of what otherwise should be produced, which is kind of cerebral music and so on and so forth. But what we actually see is that without all of these modalities working together, you would not actually end up in the same place, even in speech, let alone music. So I'm going to run through some kind of qualitative studies and references that you can look at later because maybe the decks will be shared or on YouTube or something. So what are the problems to solve with this, right? So what is the kind of modeling issue with this? Well, at the simple level, there is the issue of time scale. So notes are obviously not kind of a representative unit, even though they've been used to write the same music. So what I'm doing now next in my research is using motion capture, which is an infrared camera technology used to capture position markers in kind of laboratory space. That one is a position marker. This is an infrared camera, which both sends and receives infrared light. And when 3 of these cameras look at the same marker, when they're calibrated, they know exactly where that marker is in a local coordinate system. So using this, I kind of picked a set of melodies and got people to kind of act to them. So these are various people kind of performing these melodies. Which is a weird task, but most people find it very intuitive to represent a melody using their hands and kind of just show you the shape of a melody, which also I find interesting. And then we used some, search and modeling methods to see what is actually happening. But what I'm interested in is also kind of the musicological dimension of this, which is what is a melodic entity and what kinds of treatment for melodic entities okay for what kinds of cultural agreeability or connotation, right? So sometimes when you listen to a child saying happy birthday kind of completely wrong, you can accept it as the same song. You can accept a very good, violin player play happy birthday in a minor key as the same song in certain contexts. And there is this huge range of various different types of melodic distortions that we're willing to accept as the same melodic entity. However, time scale is one very tricky one because within kind of a melodic framework, there are various different connotations of what is similarity, compose a style like I know that that's Ilaiyaraaja, whatever, or that this is definitely Khamaj, or that this is from Peking opera, for example, or whatever it might be. There are all of these kind of categories that we are very certain about. So I'm going to end with showing some applications in performance, because that's how far as I have come with melodic research. But what I want to end up saying is that before we know to model sequences, I think, especially in Hindustani classical music, it is a very useful question to ask sequences of what exactly, and how are they supposed to relate to each other in unfolding time. So I perform with some of this material. And what I found is that while performing sequences that are kind of neurally generated, the hardest part is actually trying to create music from them, because it's actually far too easy to kind of compose algorithmically, but the hardest part is actually make it meaningful. And if that's not what we learn as musicians, then I don't know what. Like a theremin, but not electrical. And that's the kind of second voice that you've been listening to. Here are some references, and here's where to find me and the program that I teach on. And now I'll leave for questions. Thank you so much.
Yeah, hi. I loved your presentation, by the way. So my question is more one aspect about the presentation you made in terms of mapping the gestures based on specific melodies. So I have two questions based on that. One is, did you find a certain pattern in the visible gestures that were made in those melodies by different people? And if so, let's say in a hypothetical scenario where there is you take a bunch of people, you kind of listen to a melody and there's a specific gesture that they made, and then you take the second set of people, and in this scenario, you make them move in that specific manner that the other people have. Do you feel like that the way they perceive music is in some sense changed, or like what is that?
Yeah, I can take the first question really quickly. So those experiments are done in 3 different sets with 32 people in each set. One of them was the sketching one. And then the motion capture one are also 2 experiments with 64 total people who are repeating melody. So there's quite a bit of data. And yes, there are lots of different patterns to see. Some of them are really different. You can find all of them in kind of various papers that I've written. But some most salient properties are that depending upon the phrase of music, kind of the highs and lows of pitches are very different sounding to people, which means that if it's a melody where not much happens, a high note, or like that's not even that high, a third in that phrase sounds very elevated as opposed to kind of someone using the entire range of their voice in the same phrase. So things really kind of compress and distort. We also have a paper in Nature Scientific Reports on this and the effect of visual confusion on pitch distortion effects, which you can also find. But so that's question number one. The second one that you asked was about whether we learn from other people's gestures to kind of map or model or visualize. And I think I have not done this experiment that you were talking about. There is, of course, an infinite number of experiments to be done in music and gesture. But what I do know from practice and performance is that especially performer gestures are very kind of tightly tied into improvisational structure. So oftentimes kind of specially experienced performers will have very specific ways of moving to music and not moving likewise. And I think that is one of kind of the things that makes performed live music, especially for I can speak for the Hindustani tradition, to be so unique because it's kind of the multimodal reception of the melodic object really shows you kind of a new dimension. I myself find this every time I listen to Ulhas Ka Shakar, that there's just something in the gesturing that lets me know something more about the melody that I don't hear already in audition, right? So that's, I guess, a way of answering the question. Hi.
Hi. So I found the overflow part of the human body quite interesting, as you had mentioned. And that got me wondering about the LSTMs and the RNNs. Like, do they overflow as well? And are we not observing them? Is there anything like that? You're aware of, maybe?
Well, neural nets do overflow in multiple ways, but they don't overflow in modality, which means that data that you do not put in seldom comes out, right? So especially the form of data that you never put in definitely never comes out. So we cannot expect a computer to start gesturing anytime soon unless we train it on gesture data. It's that simple. But there are, of course, other forms of neural net overflow.
So the overflows can be observed? Like, the way I see LSTMs are like you're giving input and the black box and that output's coming out, but like we generally don't focus on the overflow, and sometimes the output's also predicting wrong. Maybe, like I thought since we're blocking it, maybe it's showing up.
I think it's a very interesting and productive idea, the one that you're talking about, and I feel like Deep Dream, when they did the whole dog eye thing, were kind of going there, right, with what you're saying. I'm sure there's like a lots of like that data bots, ghosts in the machine type stuff that is kind of exactly this happening in the music. But I would stay one step shy of confounding this with the kind of multimodal experience of living. That's where I stop. Yeah.
Nice. I was just curious. Thanks.
Yeah. Thank you very much.
Thank you. So now we jump to the most exciting part of the event. So we'll go to the panel discussion. So I welcome Sneha Kanwakar, Manasvi Misra, Siddharth Bharadwaj, Krishna Chetan, and Prashant to the stage.
All right. Hi, everyone. So first of all, a round of applause for all the talks that have happened so far. We do have like 2 more talks remaining, and then we also have the Music Hack Day reveal that's going to come in. But yeah, I think we can get to the panel. And I think one of the important reasons of doing an ADCx India and a Music Hack Day India, the whole point was to bring everyone together. And yeah, we did that photography thing as well. But the whole idea is that there are a lot of people right here sitting in the audience doing a lot of interesting work in different pockets of India. And the way to build an ecosystem is, I mean, we have done a lot of discussions offline as well. And what we realized is that if you want to build an ecosystem, there needs to be work done across different fronts. So in terms of audio tech, the examples could be, you need somebody in the industry who's building a startup, like actually making some products. You need some people who are doing research, and the research does not have to have an aim of making something as an output, but just explore what's the possibility. There is the end user, the artists who use these audio products day in and out. And there are also sound engineers who help the artists get all their creative ideas to an actual audio output that we get to listen, right? So we thought, okay, let's have a panel where we actually discuss about building an ecosystem and actually consider all of these 4 parts of making that happen as a possibility. And that's where we have Krishna Chetan on my far left. And he brings in the sound engineer point of view to this panel. So Krishna, would you like to introduce yourself a little bit to the audience?
Hey everyone, I'm Krishna Chetan, primarily a music producer and a mixing engineer. I primarily work for Mr. A.R. Rahman for almost 2 decades. So during the pandemic, I built a music tech startup, and we're now making on plugins and tools for music creators around the world. And I'm happy to be doing it.
Yeah, awesome. So yeah, round of applause for Krishna. Next, we have Siddharth Bharadwaj, who represents the audio tech industry. He has a startup. So Siddharth, would you like to introduce yourself to the audience?
Yeah, hi. Thanks for all the wonderful talks. I'm Siddharth. I'm the co-founder and CTO at Beethoven. So we are a generative music startup out of Bangalore, and we are building a background music creation tool for content. It could be games, videos, podcasts, anything that needs background music for it. So we want to build the most customizable system, like whatever you have in mind, whatever vision you have for the audio or music, you can realize it on Beethoven. So that's the kind of motivation that we have.
All right. And next we have Manasvi Mishra, who represents the academic side of the whole industry. So Manasvi, would you like to introduce yourself?
Hello, everybody. It's very nice to meet a lot of familiar faces, many new friends and faces I've been making. I'm Manasvi. I'm a PhD student at the MIT Media Lab in a group called Opera of the Future. And my research is all about designing new musical instruments, thinking about generative AI as a musical instrument. So how can I express my ideas, shape it, and make and perform music live? That's what I'm interested in now. I have been in universities for the last 10 years. Maybe I'm just afraid to go out into the real world. But I like it there, and I'm very happy to be here in this context.
Awesome. And next we have Sneha Kanwarkar, the renowned music director. Who I'm sure everybody would have heard her music already. Sneha, would you like to introduce yourself in the context of the audio tech world?
So I've been working as a music director in not so Bollywood really, but Hindi film industry. And recently I have kind of, started an experimental startup. I mean, experiment for us, because we don't know how to create a startup to begin with. And so baby steps into a startup called Soundcake, which is mainly to, bring musicians together and see if they can work with each other from their homes.
Yeah, that's awesome. So yeah, I think to begin the conversation, it would be interesting to get to know from each of you about when we say like building an audio tech ecosystem, like what's the thing that comes to your mind? So we can start probably with Krishna.
Can you hear now? So when you say ecosystem, it's exactly what you said. Like, it's bringing together the researchers, the people who make products, end products, and students, and all these people together under one roof. And I think that's what we are doing exactly today. And when I started my company, Pitch Innovations, back 2 years, during the pandemic, there's no such event, no such possibility to even find one person who's doing audios in C++ in India. So I think you've already done a great job, and towards in this direction. And I feel like we do need masters in audio program in India, which I feel is really missing in India, because if I want some hardcore DSP development people, I really need to find someone abroad, because most people who go from here to study masters abroad stay there, they don't come back. But yeah, I think things are changing, people are coming back. And I think we are at a great starting point, and we are at a great point in terms of even the economic growth of India, where the tech startup ecosystem is in India, and all of that combined. I think we can see some great companies and products coming out of India in the music tech space. So.
Yeah, Siddharth, yeah.
Yeah, so to me, the audio tech ecosystem is, of course, like it's an amalgamation of all of these different stakeholders. But I think it's also about like a lot of about the economics of the whole space. So it's pretty much centered around like Bollywood or the film music industry on the whole, and like that's where the money is, and that doesn't flow through all of these different aspects like the academia or the startup world, or so that it needs to flow there. And of course, like communities need to be there to talk about such things and just meet each other and learn and build some more. Building is the most important thing, and I think if other like some startups or research problems are interesting enough for the ecosystem as a whole, I think that will also, the money flow will also come in, and hence that will also accelerate the growth of overall ecosystem.
I agree with everything that has been said, and maybe what I can add is, even though we realize in this space that there are so many different meanings of what music is and what it means to people and how to interact and be creative with it and what kinds of technologies to build. And it is obvious in every technology that ideas of our culture get immersed into the technology the way it's built, because it allows to do certain things, doesn't allow to do certain things. So when we are using technology built by other cultures, we struggle with it, and we heard from some of the talks some of those struggles. So I can add that maybe we should vigorously encourage and cultivate creating in new and different ways, in ways outside of the capitalistic tools, just to push music in the directions that we think it means, because every generation has new musical instruments and what music means, from acoustic instruments to electronic instruments to live coding that we heard, and maybe future AI. I don't know what is to come. That's a few cents of mine.
Yeah, I think that's great. So, Sneha.
I mean, I have an example. Recently, a few of my friends are here who I sometimes hang with only so I can learn a little bit of their tech world. But we were trying to build this community called Noisoizois, and we have built it. It's just that we don't have any money to do any major concerts, festivals, etc. with the people we have, the performers that we have. I feel like I'm still in the commissioned music space, and so I know that there can be projects. Like there was this this animation film called Shirkwa, which was a German-French production, but the director is Indian. And I think it was, it had a lot of scope for experimental music, to just put everything in one umbrella. And the director was also super open, and there was money. There was a package, a budget. And at this point, I think, considering the deadlines, I would have loved to do a boot camp Shirkwa somewhere and got together all my friends. And I think I did discuss with one or two people whether we could get together and make music using other ways. But, things have to be more, I don't know, more mobile in that scenario, because then we did the project, we had deadlines, we finished it off, and we did what we could, but it would be amazing to also have more minds on it and new ways on it. So there is a small bridge that can start happening. I just feel like we haven't been talking enough with each other. Just to, 10 years ago, when I was traveling in the US, this is just to show where I come from. And I was traveling in the US, and I saw this meetup that was posted by some guy called Dave. So I went there and I was looking for Dave, and turns out it was Dev. So anyway, so what I mean is that, there's a whole lot of gap between my kind of musicians and your kind of coders and, developers. And we just need to talk, really. That's all.
I think so. I think what I'm hearing is that there are some things happening already, and there are some action items that can be taken. But and I think all of you have explored that already. You have already tried some stuff. So where do you think we are at right now in the context of India, from people who are exploring coding in making some things, or people who are doing activities? Where do you see as of now, what's the current state, in your opinion, for people who are based in India and are into the audio tech already? But they might be doing things in small pockets. They are not collaborating yet. But based on, for example, Siddharth, you have been in touch with many startups who are also kind of exploring the voice-related things, for example, right? So what's your visibility into that, and what's the current state that we see here?
Yeah, I think in the startup ecosystem, we definitely are trying to solve some really nice use cases like Dubverse or 4D. So those are some names in the text-to-speech domain, and they are trying to do, as 4D already mentioned, what are the use cases, why is there a need to do that kind of speech-related research. In the music space also, we have lot of artists that are using these tools to create some amazing, crazy, weird, avant-garde music, and also some really nice music in maybe independent films or documentaries, or where they can experiment. They have the bandwidth to experiment with. And I think that's happening, but maybe some bridge again needs to be built out, where more tools need to be built out for those musicians to experiment with, or in collaboration with them, not in isolation from them. So I think that's the most important bit. Whenever there is a development going on, it's more in the startup style, where there is no space for a musician or an artist. I think that could be done, especially in the musical context. In the speech context, again, as you mentioned, linguists are already involved. So I think that's one thing that can help build the bridges on both sides. It has to end on both sides. So musicians, more tools need to be known, explored, and on the startup side, musicians need to be involved as well.
Yeah, any other of you who has visibility into what's happening in India right now? What many people here might not be even aware of activities that are already in place, right? So for example, we had some amazing talks, and we never realized that many of these folks were hanging out in Bangalore, and we just met here, and then we realized, oh yeah, you were just here, and we just never connected. So are there any more examples, or where do you see the current status of the audio tech community in India already, that exists?
Sorry. So I recently met Jagan, who's from Algorave actually, and we from Chennai actually literally like just few kilometers away. But he has done great DSP work, but we've never connected before. So only through this ADCx it was possible. So and same in the music tech company side, I met Mariano from Swarplug. Shout out to Mariano. So we all know Swarplug. Swarplug is from him. So I always thought Swarplug was an Indian company, and then got to know it's from Switzerland, from that beautiful person. So yeah, so I think there are talent, but it's all pockets, and it's we really needed events like this, more of the events like this, and to connect and do something together.
Yeah, I think so. On the context of like collaborating and doing something together, I think so. Krishna, you and Siddharth has been already making companies, and I think you would have also gotten into the process of finding the right people. So how has that experience been, like connecting with and finding developers who also have like some kind of music background, or maybe the right people who you think will actually be able to understand your vision? So how has that experience been?
So yeah, so this was tough for me, right? Initially, we started 2020. That time, like I couldn't find one person who knew C++ and audio and was able to do juice stuff for us. And so literally, I had to send out a project to Israel and outsource the project. But then for our second plugin, we built I kind of found few people and then put them together and said, here's the code base of my first plugin. I want you to decode this, and then help me build my second plugin. And then who turned out to be good in that, we hired, and then we kind of literally built the first few audio developers in C++ in India, right? So, so that's how it happened, and I really feel like there are a lot of pockets of talent, and it's difficult to connect with these people, right? And also the interest in audio domain is also only recently started, right? Like in terms of academics and all that. So as I said, it's still at very early stage in India, and we still have a lot of work to do that. And the second part of your question is, we always look at people who know music rather than hiring someone who just know C++ and then training them on music, which doesn't make sense for us, because in the musical side of things, you have to know so much in order to code a music plugin. Like you need to know what's a music instrument, what's scales, rugs, what's tempo, time signature, what's a DAW, what's a VST, blah, 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 the list goes on. So it's very difficult for us to train all of this. So I rather try and find someone who has a knowledge of all of this, but even if their C++ talent is a little bit, we can always train them on what we need. And that's what we've been doing. And today we have some of our developer team here, and they're all enjoying. So I want to give a shout out to my team in Chennai as well. Yeah, thank you.
Round of applause for the team pitch innovations. So Siddharth, how has your experience been?
So yeah, for us, it hasn't been very difficult actually, because like we have been connected to the community in terms of like my co-founder he belongs to a gharana of sitar players, and he is connected very well to the musician community, and also he has done a music tech masters as well. So he also has some connections in the tech space, and like quite a few of us here, like we have built out music tech community, and we have hosted some meetups in the past, hack days in the past, and there we met like our first employee, who's Ashish, is sitting in the audience somewhere, and yeah, so that so through this community, through the network of network, Ajay is here, who has also helped us with some of our hiring, and yeah, so that's how, like through network, through meeting people, that's where we hire usually. We also have a few research folks in Europe, since we couldn't find the exact talent that we wanted in India. So we also have a couple of folks who have joined us from Europe, and I think it would still be a mix, like since we are a remote startup, so we can afford to have like a a mixed team, a global team, and yeah, we need not stick to Bangalore itself, and yeah, so
Yeah,
that
okay.
gives us a bit more flexibility on that front.
Yeah, of course. I think so. I think the stories are very similar for both of you. I mean, you kind of figured out people who are interested in this, and like for Krishna, I think you had to find somebody like with some search and all that, and that even then it was connections of connections, right? And then for Siddha, it was like he's already connected with the community, and he was also building one, and that way there was like it was a little bit comparatively easier. I wouldn't say like completely easy, but yeah, comparatively easier. But I think it's really interesting how doing these kind of meetups and discussing ideas just opens up so many possibilities, right? And I think one of the things that what we have realized is that there are a lot of, because I think everybody here is also musicians first, and or sound designer first, or audiophiles first, and then a developer. I think majority of us. So I think even when we do the discussions like that, or when we let's say we use we use a DAW or we use a plugin or we are experimenting with voice, like what you do, Manasvi, you also kind of start to realize the problem statements. Hey, you know what? This is not very easy to do. So this is a question for all of you. What are the possibilities or challenges that you first of all notice in the audio world, both from a creative standpoint and also from the tech standpoint? And what are the ideas and that you think can actually be solved out, or how can that be enhanced? Like how can that process of solving those problems be enhanced? Like how can we collectively find problems, or how can we realize that, okay, hey, you know what? I was experimenting with this stuff one day and it did not work for me. I should probably connect with somebody who is also in that space and then try and build something together. So have you already like explored that aspect? Like for example, when you're making music on your own or like experimenting with stuff?
I know the answer you want from me. So basically, I have been traveling to collect samples, right? You can say one is a sample musician. And I really believe in that process because I feel like the kind of authenticity is too much of a word, but I feel like somebody who's living a certain kind of a life and then plays a flute instead of somebody in the industry who's just playing flute for their career and may not think too much of every recording they go for. So there is that difference, right? So I seek out certain things specifically and travel to find them. And sometimes, you want that industry jaded effect. And that's when you record a veteran and, sometimes you also want that skill over heart and things like that, or both or whatever. But having said that, this travel experience cannot be done all the time. In 2020, I delivered my first baby, and somebody wanted to do sound tripping all over again. There was this show that I had done for MTV that was even like 10 years ago, and they wanted to redo it. So COVID happened after 3 months, and of course I wouldn't have been able to travel. So then I was thinking of some hacks so that I still can do sound tripping. And then I thought, why not sound tripping online? And then I thought that let's do this experiment where 6 or 7 musicians came on Zoom, and then we would start with one idea and gamify it a little bit. I would send a file and then would give them 90 seconds or 120 seconds to do something to it and send it off. So Chinese whispers with music, and trust me, it was so much fun because at the end of the day, at the end of the loop, the music piece would become something else, and it was funny and it was really fun. So we were experimenting with different ideas, and then I felt that there is somebody sitting in a small gully in Banaras, or somebody sitting in Israel or Egypt or wherever, and who wants to work with me right now, and my other team people do not because it's 3 a.m. and they don't want to pick up my call. But there's somebody who might be available to work and would be correct for that piece. How do I connect all of us together? And that's how Soundcake happened. Of course, it started with great dreams, like, I'll start one idea and go to sleep, and then things will come and attach its, to the piece, and then it'll become some hybrid something. The next morning I'll wake up and but yeah, so can be done, but needs a lot of developmental discussion. So yeah.
Yeah. I mean, so any like possibilities that you have come across of people coming together and building something and.
Well, this is an example, but it's really great to hear from these answers. I mean, I have been in a university, so I meet a lot of people that come to university for so many reasons. Some are curious about research questions, some want to upskill. So to think about like your question, which is, so you're asking like what are ways to build these bridges, I guess, in these ecosystems. We've already talked about each of us making efforts and being in the same spaces together. I think, to me, it's like, I guess there is the bridge. There are people that want to build the bridge. What you just described sounds so exciting. I want to be in this Zoom call and participate as well. I think many people here would love to try these ideas out. So again, it's that thing of like, ideas are in small spaces. Connecting them seems important. Finding the people that will cultivate and enjoy those ideas, take them in new directions seems important. I've been working now for a long time in the generative AI space, and there also you can think of that as like finding the statistically average version of an idea, right? Like, I want to make rock music, and what is rock music? Or like, I want to make this picture, and what is the average version of that idea? And we're all playing with these the common data sets and things like that. So we're trying to find, like, go away from that average idea maybe. And again, that's like building these bridges. Maybe those bridges are like going away from the center. But again, you want to find the endpoints, find people that will help you build the bridge. Yeah, I guess I don't know your answer because I've been in university, so I'll come out and then maybe I can be hired by you.
So, but I think you have worked with a lot of live performance kind of stuff, so that's also one way. So just experimenting with actual musicians, actual artists in a live setting, and those experiments need not be very high fidelity, like it could be a smaller effort, like a 1 month, 4 month, 3 month cycle. You can build something, experiment with these artists on ground in real performances, and maybe like if something sticks, if something is needed by 100 more musicians, and that can be built out.
Yeah, for sure. Yeah, I think Krishna, you have to say something? Yeah.
Yeah. So for me, collaborative sometimes, like since we make plugins for the music creators, and sometimes we just make like a MVP, and then I go and directly install it on the some of our mentors, some of our top users, and some very high level people. There are some tech finicky users also, right? So you send them the beta versions, and then they're like, they tell us all you want to hear. Sometimes I might have 20 more ideas to build on top, but when I get when I get feature requests of let's say some 5 or 10 from them, then that's my checklist of, okay, in my 15 ideas I'm going to build these 10 ideas in the next version. So that's how we work, and I feel it's really important to stay connected to who it is that you're building your product for. So that way, it really helps. Yeah.
No, for sure. I think so. One of the things that is very common in the whole discussion is also that you also need people who are experimenting stuff already. Like, for example, so when Krishna, you were looking for C++ developers, they were already like musicians who knew C++, and it was easy to teach them juice and so on, right? And Manasvi and Siddha, you all have also done spend a lot of time in the academics world as well. You have visibility into what's happening there. So, and Sneha also she's been helping more live coders as well to experiment more and create soundscape and all that. So in terms of connecting with researchers or people who do stuff just without any vision of making a product, but just for the fun of it, because sometimes that's where the good ideas come in. So what do you think about that aspect of this whole ecosystem, where there are people who are just researching in academics and there are people who are doing some experiments elsewhere, and then how can that help in the building of ecosystem?
I find it so funny how you're describing a researcher is like, I just do something, and that's actually me on most days. But then there is like a seriousness to like a research question which you want to explore. And part of like how I see this academic environment is your research question need not be fueled by the next investor rounds, and so you can kind of focus on more meaningful questions that might take time to discover. We have talked about building ecosystems in terms of the bridges and the people, and what more can be said, according to me, is maybe in research, in academia, there are challenges as well. Like we said, there are no master's degrees, PhD degrees in like music technology overlap in India, or not enough, even if there are a few. So there could be more like efforts to build resources for research and creativity explorations. That is a frustration we all share, whether it's university or independent explorations. Building data sets that we can kind of evaluate and hold each other accountable for. So yeah, I think there are many other things to talk about in this building of the ecosystem, and so much to be done still.
Okay, so Sneha's question is, are there already like music tech courses in India? I think the answer, I mean, there are some things happening in Smalltalk. I think you can have like more visibility into it.
Well, I don't think there's any master's program called music technology. I mean, there's sound design related courses. Yeah, Ajay, yes, please. Oh, all right. So Ajay is telling us that there is one now in IIT Hyderabad. IIT Hyderabad? Yeah, super exciting.
Yeah.
Oh.
Yeah, but it's only accessible to IIT students, right? I mean, it's not for somebody like, you know, who's not doing IIT. No, in this sense, okay. Yeah. Exactly.
So I think even that didn't exist, as I've been like going abroad and being pulled by like. So first, like even if that exists, that's at some points, but then we have to build, of course, more accessible points to get into researching this and seriously, and not just like trying out a toy example.
Sorry? Okay, so you should probably say it on the mic, yeah.
No, I mean, if there's no music tech course, I think I'm sure we all can think about building one. No? No? Is it?
Yeah.
Because it's very, it's weird that you didn't find somebody to work in C++ in music tech. Like, it's bizarre.
Yeah, I mean, there's lots of C++ people, but not working in the audio domain and in the DSP domain. I mean, even if there are, they probably learned that via studying abroad, and then in rare cases they come back to work on companies that actually not Indian companies, like some Samsung, something like that, like, you know,
Yeah,
working on automotive DSP, those kind of stuff.
I also think it as a problem of, like, it's a cycle, right? Chicken and egg problem. So there is not enough demand of such audio tech folks, maybe. There are not enough companies that work in audio. And why is that? Because there are no developers. So it's kind of a cycle, and like people who study abroad right now can create that demand in India by coming back, building companies here, building some other kinds of projects, maybe artist residencies of sort, because that is, you don't need to have a university going for that. Anyone can build an artist residency or a maker space of sorts. And that's where, like, that could be smaller starts into this, I feel.
Yeah.
You mean it's not a feasible career option as yet in India itself, is what you're saying? Sustainable.
Yeah, I think so. What we could, I think this is, I think we should get to the audience questions as well. So you want to say something before we do that?
Yeah. I think just the fact that we are discussing this and
Yeah.
surprised by this, and the audience is like, yes, we should build it,
Yeah.
is a great step in that direction. Frustrations we share, we're bringing it to the same stage.
Yeah, I think so. Before we do that, I just wanted like any like one action item from you all where you think which should be taken by everybody here or some folks here that will be in that direction.
I think we just came up with like a massive action item.
Yeah, so it's a
Building
music.
school is a great
Yes.
project.
Okay. So we are doing that. Also, any I think. Yeah. So any other action item before we go to when we open it for the Q&A? Yeah.
So I really think we should reach out to some big universities like VIT, IIT in Chennai, VIT in Vellore, those kind of other great universities, and then and then pitch this idea basically, and then because they are already a lot of engineering talent there, and they already have a portfolio of master's programs, and this just needs to be added in there.
Yeah, for sure. So yeah, I think so. We can take up questions. So feel free to ask away.
Yeah, and
We already-
just to add, like, it's not that there are no students working on it. They're in smaller pockets under DSP groups, under some audio research. People are working in smaller pockets. They do some kind of music research. They do acoustic modeling. We have RAG related research, so much of it. So they are still doing it. It's just that there is no formal course as such where which people can Google online, like, can I do a music tech course in India or something? There isn't any such course, but yeah, still people are doing it. So yeah, just to clarify on that.
Yeah.
Hello? Yeah. So thank you all for this amazing panel and a great question to kind of end it and move into questions to audience. So in terms of building bridges and communities, how do we as a community and as individual entities address funding for art and technology exploration and experimentation? And how do we leverage instruments and vehicles like private investment, governmental and non-governmental financial grants, academic grants, etc.? And in the absence of vehicles like these, how do we go about making changes through governmental policy changes and private institutional participation? How do we go about facilitating all of these? I guess it's a three-part question.
We'll have to build a board to begin with. Somebody will have to be regularly in touch with each other, at least to begin with a WhatsApp group. I mean, I'm just saying that it'll have to be organized by you and the society, and yeah. And that's what I think.
Yeah, so definitely government intervention is required there, government side funding, especially for art projects, because like the monetization out of an art project is still a very scarce in India. Like if you build an art project, you can break even at max, I feel like, if it's not a commercial project, high level project, right? And so usually outside of India, it's like European Research Council funds most of these projects in Europe. Similarly, I don't know about the funding scene in US. I think it might be both privately funded as well as publicly funded. But yeah, I think again, like it comes down to like how you are tackling those, how you are posing that problem to the government, like in what way, shape or form. Like, does it help the government expand on like Indian classical music? That might be more feasible to them than saying like, I want to do Desi pop in India and I want to do a project on it. So you can still get some kind of funding. I haven't done it myself, but I think policy making going into those areas, I think is still, like at least I have a long way to go before getting into something like that. And privately getting funded for it, again, like depends on how huge the market is, then all of those sort of questions, right? Like how much money can you make out of it, or I can make out of it, and only then I can fund you. So yeah, and that's not very much in the art space, unfortunately.
So I think just adding to that point, so I think there are some projects, for example, Doordarshan archives, right, where some of the IITs are exploring that and trying to help the government in some way, right? I think the IIT Kanpur does some work in that domain. So I mean, there is like some kind of requirement that the government definitely has. It's just that they are not aware that there are so many people in India who can actually solve it for them. So what they by default do is just go to these specific few IITs and because they know there are people doing that stuff there. So I think making it more visible has to be a very important thing. Like starting a conversation that, hey, we are all here can actually help, right? Because then, so right now we all know that we are thinking the exact same thing, right? So even all those things can help. And maybe if we somehow make it visible to the government, they'll reach out. Yeah, hey.
So we are definitely in touch with the government through NASCOM, which is a bridge between startups and the government. And government do indeed wants to build LLMs for music in the Indian classical space, for folk music, archiving them. But yeah, it's still like, of course, it's government, so it will go a bit slowly. It's just been 1 year since the LLM rage has been happening. So it might happen, definitely. In the research space, of course, like with IIT collaborations or with some of these university collaborations.
It's funny how the question always comes down to IITs. Why are we looking at IITs? Right? There's other engineering colleges, right? And it's not like IITs themselves have the monopoly on great tech in the country, right? There's a lot of, and even the idea that music tech itself needs to be done by engineers. Why we keep saying that? Like,
yeah,
it's
absolutely.
music tech, right?
I think we are sharing that frustration to say that why does it go to that? Doesn't it go to like the artists and the engineers? Totally agree with you.
Yeah, no, and so there's design schools. So I personally have taught some in design schools. And it's just like a tiny push that's required of getting those same students that explore a bit more, and then you can do more things around it. Talking about, we had some mention of live coding and all of that. I've taught courses in filmmaking, design, sound design, creative coding, and in all of these courses, I would put in like a 45-minute segment at the end of the week-long class. And I just show them like a basic live coding system. And that simple thing just gets people excited so much. So, I mean, with ADCx India, we've been doing workshops all over the country. You just throw like a little tiny bit, even with your startups, that get people involved, playing with your tools. And it's, I mean, you don't have to do it for the whole community. Maybe focus on your startup, just get that going. Even that itself would get enough people involved, I suppose.
Yeah. I think that's a great suggestion, yeah, for sure.
I agree.
Several years ago, I used to work with a project for dissemination and education of classical music in a government-funded virtual lab. And we were making a virtual lab for Hindustani music, and it was great and everything. And then we wanted more funding to grow the project. So we went to the Minister of Culture at the time, which, by the way, we don't have because it's culture and tourism in one, which is a very important thing for us to remember in general. So he had this long proposal about music education, blah, blah. And then he read the whole thing, thought about it for a while, maybe 2 days. Is this on camera? Sorry, I got really conscious suddenly. It is? Oh. We'll protect you. Thank you. And the question that was raised was whether there could be a system to discriminate better and worse artists from each other, so as to send them abroad for, like, to embassies or something. And we were really shocked, but I'm not shocked anymore because, like, the thing is that every funding agency operates with its very specific myopic interests. And I think it would be weird to forget about this while discussing funding in general. I just wanted to make a controversial point.
Adding on the government side of things here, right? Uh, so the way to access public funds is through public entities and public universities, and IITs are one form of public universities. And then that's the closest to the technology people here. Of course, there are a lot of universities that could be targeted, right? So again, so the core aspect of government funding is that it should benefit people and not the specific people who are receiving the funding. As long as we can convince the government of that, it'll happen. And then as she said, culture and tourism go together. So when you say heritage of India, and then you want to work on music or audio, if it is tied to the heritage, and if you could say that we will recreate this particular space of a very famous tourist attraction in terms of music, and then that gets you the government funding, and then the research for that will drive the people. And then these are some efforts, right? I mean, so there needs to be a livelihood aspect associated everywhere whenever there is a government funding needed. And whenever they're looking at speech technology, it's the same thing. They are looking at, is it actually benefiting the hinterlands of India? Is it benefiting the 300 million farmers who will use this technology to get something out of it? And then as a part of that, the technology development happens. And this is similar in most of the even in the US, Europe, it's similar, right? There is a public good associated, and then going towards the public good, there is a technology development that happens.
Sorry, no, I'm just going to add one more last point, which is that because I teach in I agree with what you said, and also because I teach in a music tech program, because we're discussing about feasibility, viability, blah, blah, blah. I've never seen a single one that is not in a little bit of an existential crisis, because it's simply not a field where things work kind of one after another. People find their niche, and all of these things happen with artistic journeys and all of that. And I don't know if that's right.
I didn't get that. So what?
Yeah, students and even the programs are always in this like element of threat.
Right. Okay.
Yeah, all over the world. Yeah. I just.
Sure. So students who do your course, your program, what do they end up doing in life? How do they? Or put out music.
Or do music. My students don't do yoga that I know of with me.
I think we have a question over there.
Yeah. It's a long dude.
So something I want to bring up in the context of funding, and there's something else that came up in the panel earlier about doing things which are not in the capitalist framework. I think something that's often forgotten is open source, and that there's like a massive culture of college fests and other forms of, if I were to use the word communion, in India, it's very easy to create a culture around sharing. And I think maybe it might be nice to seed something. In Bangalore, a very long time back, we used to have something called the Sunday Jam. And there were a few sponsors, but a large part of the festival was put together with just contributions from small businesses. And it was one of the favorite, like everyone who was doing something interesting musically and experimenting with, at the time there was very little coding there. It was mostly just live electronics and sound and music. It was one of the most fun festivals we had today. I think the amount that people spend on events in Bangalore is way, way higher, like probably a couple of orders of magnitude higher today. But it's not as fun as Sunday Jam, which was like a community event, which was sort of crowd-funded and very, Burning Man-esque, if I were to draw that parallel. So I think doing this kind of a shared Creative Commons sort of effort with shared code and shared electronics and shared spaces could be like a nice way to like kickstart something.
Yeah. I mean, so.
Hi. So I'm the developer that Chetan was looking for many years. Okay, so hi, thanks. Okay, so but yeah, I mean the capitalist thing that the gentleman said just before me now is a wonderful thing, because a lot of us experimental coders and musicians, we are kind of we see that. I mean, I'm not to blame the famous composer on stage, but generally it's driven by music in India is generally driven by the film industry, and so things that we do is kind of not that format. So we are trying to create these small events ourselves. Like Akash, we created a gig yesterday. I think many of you attended that. And then this gentleman that talked about the Sunday Jam, I would love to talk to him again. And also, I want to just to go parallel, especially with the capitalist stuff that somebody, I think Abhinay has talked about it a bit. The capitalist stuff is driving a lot of this discussion, I would like to say, like, at the threat of my neck or whatever, that you can die for your art, You can die for your art, sacrifice yourself for your art, work hard, just do your art, like put your art out. There's so much possibility to put stuff out. Like you can release Bandcamp albums, a track for hours and stuff if you want. I mean, they're giving you all these facilities. You can stream 8 hours on YouTube. Somebody plays one sax phrase for 11 hours on YouTube. So yeah, I mean, all I would like to kind of put it out is that, be like Van Gogh or somebody, you could die for your art too, so that's something that you could consider. Yeah. So yeah, thanks.
I just want to add, like, this is great. It's this discussion. There are so many ways to approach this answer of how to build the ecosystem, how to fight it, how to find funding, how to pursue art, and I think that is true in general. Of like my belief when I was saying was like music means so many different things to so many people, and there are different reasons to pursue it. We are talking about the challenges, and there are so many, and articulating it and bringing it on the stage and saying it out loud on camera in front of people is so important. Then we are finding the answers here as well. So I'm really behind that, and I want to build these schools, find these fundings, find reasons why culture, tourism are together, can be separate, what are the different ways to detangle that. But at the same time, I want to just bring also to the opportunities that we have found. Coders in this, startups are starting to form. You just mentioned there's much more like investments coming in here, and so I would like to invite everybody to find those opportunities as well as we are articulating these challenges.
Also to answer just a part of your statement, in the music industry itself, there's a lot of push and pull, okay, and one is not really in a happy place. Because one is not so Bollywood to be able to join the circus and enjoy it. I wish I did. I wish I believed in the fact that song and dance and that this is a creature and I should make music for it and I'll be happy. But it's a problem when you're in the middle. So and there are phases in life and you can be that Van Gogh type artist, and then there are phases when you cannot. I don't know why, but we can have that separate discussion. However, I just feel like there's no real revenue thing happening in the industry, music industry either. The entire industry is some 1,500 crores or something, out of which half of it is earned by T-Series. There's no streaming monies. The streaming monies are so meager that it's shameful. Royalties are also, they're muddy, I would say. Some people have complied, some people haven't. So there is a lot of issues there. The only industry that is thriving revenue-wise is the events industry for musicians. So people, the singers also, they come to the studio, they dare not ask for any money because they know that if they start asking for money, then the producers, music directors will stop calling them. I mean, I'm not talking about creme de la creme, Mr. Rahman, of course, but but there are people who then they get to sing songs, and then they go and do a lot of shows. And these shows are really well paying. So all I'm trying to say is that I don't think being in the music tech community is so sad, really. It is going to, in fact, leverage a whole event system that might work better than a lot of musicians community.
Yeah, for sure. I think so. Yeah, we'll take from Sohit.
Hi, my question is to Sneha specifically. I am a tech guy who wants to understand how to distribute his software in a way that it reaches you for when to solve problems that you have. For example, when you had a problem, when you wanted to use experimental music, you had the budget, you had the time, you did not have the time. So where can I put out my software? Where can I put out my profile in a way that it gets discovered by people when they need it?
I think that was the first reason why Soundcake, I was trying to imagine it, to bring, musical content creators together or something like that. But yeah, the industry is very small, So once you, let's say, reach out to me, I'm, let's say, a semi-level something, middle level kind of a person who, I'm talking from rate card point of view. And then there are so many biggies who will actually use the plugins regularly and a lot more than some of us will. And they're just 10 or 15 people in,
Okay.
and you can start there. But yes, through Soundcake, then not just you, but even other people who are maybe somebody sitting in like Gorakhpur or something who wants to reach out to the industry. We are trying to open avenues for that.
Could you talk a little more about how Soundcake is doing that?
Abhi to Soundcake kuch nahi kar raha hai. It's just listing people and giving shout outs so that people can come into your session and submit their samples, and you can buy the samples off them. We have a very strong legal companion with us, Khimani Associates, and we are still working out. We are currently doing everything manually, but hopefully we will open it up for maybe inviting collaborative tools like yours, your tools, etc., and to see how it can become a part of Soundcake, and then the whole community of Soundcake can use them.
Understood.
Something like that.
Understood. Thanks a lot. I just have one last question, which is how often, my knowledge of how I can distribute my software is that I can build a plugin and hope that it will get used someday. So is that something that viably you see people in the space using, people around you?
I can give you an example. We're working on this film called LSD 2. LSD 1 was Love, Sex or Dhoka, which we done in 2008. And the same director, Dibakar Banerjee, is directing it, and Ekta Kapoor is producing it. So for LSD 2, when we made this song and we were all sitting in the studio, there was a lyricist, there was a director, there was a sound engineer and 1 or 2 musicians, and we were all discussing lyrics and melody simultaneously. And then I quickly would put down the melody with the new lyrics on just an SM58, and then we saw the final output, and Dibakar, my director, said, "Ye to Ekta will not understand this voice of yours, because my voice is not a singer voice, right? That shines bright, and the song needed a certain kind of a voice." So we AI'd the voice, and we immediately, what is that, Musify? So we found Renee to sing it for us, and we played it to Ekta, and she obviously didn't ask who the singer is, but loved it.
Wow,
So
that's
I think
amazing.
we might release it that way.
That's really cool. And you found the plugin through, how did you how did you find the AI that you were using is what I...
So there are a couple of nerds in the studio.
Okay, got it.
And so there is this really dear friend of mine, Venkat Iyer, who I think, Krishna, you reached out to. You reached out to Venkatesh Iyer? I think so, okay. Or maybe okay. He was kidding. But he found out about, he also finds out stuff, and I think people are really there's so much on Insta
Okay.
coming up all the time that people have found their way around it.
Thanks a lot. Thank you so much.
So I think what in this whole discussion, and again in the interest of time, because we have few more talks, we'll wrap and we'll conclude. But I think the nice thing about this whole discussion is that we have not just talked about solution, but also more ideas and more problem statements, right? Like for example, if you're building something like a good tool which a film industry can actually benefit from, how do you directly connect to them? And that's a problem statement. It's not solved yet. Maybe like somebody will come up with a solution, right? So I think there are a lot of discussions which actually kind of gave us visibility that at least we are all on the same page. And we all are like kind of from different backgrounds, but the mission is the same, somehow to have like a support system, and I think we should head in that direction for sure.
Yeah, panel hopefully was not too grim. It's like we have 100 people in the room. We have Sneha, who is from the film industry. We kind of went overboard with, but yeah, I think that's one great example of tech being used in the studios. A lot of labels have been reaching out to us, so they are more open to using technology within their ecosystems. So it's still opening up. We have more, with more demand will come more supply as well. And I think it's not that grim as we make it out to be.
Yeah.
Hi. Actually, I want to also say, like I was saying before also, I'm not afraid of saying out the grim parts. We're all actively saying it out loud, not to be upset about it, but face it and look at it. And then generally to conclude, the last 3 days we've been doing music hack days, and today we've heard all these talks ranging from so many different ideas, from analysis, synthesis, building tools, softwares, companies. And in general, that leaves me happy. I mean, it's maybe this field is grim, but I'm happy about being in it.
Manasvi, I really want to add one more thing about the commercial viability of what we do in music tech per se. I'm also an artist, and I'm an independent songwriter. So whenever I'm based out of Chennai, and whenever I go perform, no matter what kind of a indie-focused event it is, people still want to listen to film music. There's nothing wrong about it. We all grew up with film music. One idea that I pursued per se was, as a technologist, it doesn't take a lot to have a visual, a visual reflection of your performance. You can just listen to thresholds, or you're just your drum hits, and have something visually appealing. A kind of immersive a concert, right? And that is so easy to pull off as a music techie, because most of India consumes film music. Their best form of entertainment is film. Right, and in this domain where we are, it is so easy for us to create an alternative experience, and it's so easy from a tech perspective, right? And what I see is that individually we have so much knowledge and talent, and events like ADC that pulls people together, and something like a monthly meetup online or something, right? The organization. Because I've also seen the communities in Los Angeles, both musicians and technologists, they're organized in a certain way, and I see that that we could be better organized in order to make this commercially viable and sustainable for us in a lot of ways. And it's just right there. The biggest thing is organization. The second thing is using our tech knowledge to propel whatever our music that we make forward, and to take it everywhere in the world, along with film music.
I think that's a great point to conclude at, because I think that's a great summary as well, and it's a great suggestion. And I think we should continue the discussion throughout. Yeah, I mean we should keep on talking about it, keep coming with solutions, and let's again make this ecosystem together. We are all aware of the challenges. Yeah, I think Krishna has to add. Yeah.
So. I just want to say thanks to Prashant, actually, who put together ADCx for us in India. These events usually only happen in the US and Europe. So thanks so much, Prashant, for putting all of this together. So one more thing. See, all this discussion is about connecting, right? So why don't we just create a Discord group of like ADC,
So
whatever, and then let's connect. right?
For sure, it's a great idea. And I think there are, so first of all, I think this, and I'll be talking about this in the conclusion of the event, that the event that's happening today is actually accumulation of things that have happened in the past. And yeah, we'll talk more about it. Like, for example, Music Hack Day India has been happening since like for 4, 5, 6 years now. So yeah, I think it's a so all collective effort, and we'll keep on doing that. And we'll have some action items to us in the conclusion, which will actually bring us together, and we'll yeah, do something together. Yeah. All right. Thank you everyone for listening, and we'll get to the next talks. Yeah. So we have like 2 more talks, and like the presentation from the music hack winners as in the best ones. So the next talk that we have, the next talk we have is by Akash Sharma, who will be showing, who will be talking about using convolution for archaeoacoustic conservation. So a big round of applause to Akash.
Hello. Hi. So I'm Akash. I run a research lab called Sound Codes. I operate as sound artist, and I make microphone and Eurorack synthesizers and do like other stuff. So this convolution has been the body of my work because this is something I've been doing since 2012. When we say convolution, what do we mean by convolution? So in a sound or in a music term, convolution hosts a very specific meaning, but in computation, convolution we use in general all the time for many complex calculations. So let's talk about convolution from an audio sense. You can use a speaker and have a microphone in a space. And if you produce a sound like this sound is nothing but a logarithmic sine sweep going all the way from 10 hertz to your sampling rate, which can be anything, 24,000, 48,000, or 96,000 based on at what you're sampling. Once this sound has produced from the speaker, it enters the space. All of these frequencies interact with the material and the geometry of the space. Some of the energy, like the amplitude of that specific frequency, is absorbed. Some is reflected back into the space. And now this dance of frequency keeps occurring for n number of times till we have nothing left dancing in the space. Now, if we use convolution as a process, we come to know, okay, how the room precisely sounds. And the other word which is used for this is impulse response. This is what we use in general in modern DSP for convolution reverb. And like in augmented reality, in VR, in gaming, we are always introducing realistic reverb sounding compared to algorithmically generated reverbs. But from a human sense, I like to think sound is physical because all of this language, all of this, the choice of my language, the words, is very new, very modern. And a lot of these historical spaces were designed purely by listening. The architects or the designers were able to tune the space by having this ability to acute hearing. And over time, we have, as a collective, we have a lot of lived experiences on those spaces. And this is not just Indian idea, this is a global idea. We have examples of such spaces across all the cultures. This is some of the examples, like we find this specifically designed spaces for sound almost everywhere. And convolution, or like this impulse as an idea, gives us an insight into how can we hear the past. Can we listen to the stone? Can we say what would be the lived experience of the past? Or can we augment ourselves in that experience now in this reality? These are some pictures, but like there are like tons of examples of such acutely designed spaces where listening was the core ability. And we can use this data, this idea, and we can just travel back in time, and here sound becomes the medium. Today, we have bunch of institutes, bunch of other individuals who are researching into this aspect. But the major problem, what I see in this idea is, when we deal with history, your quality of data is as good as the research related to the history. The objective, what we achieve afterwards, is also dependent upon the context of the current world. We would perceive it with the some data of what I gathered during traveling through India helped me understand certain practices, certain approaches. So this object, what you see, is a bronze megaphone. It weighs roughly 680 kilogram, and it's a acoustic amplifier. Like, it amplifies human speech, and it really does. So here, while listening to the stones, while gathering these impulses of these old sites, I came across questions. How would a king address to the court? How would an army general address to the army in an open field? And then what common link I found across culture was this sort of a cone geometry is universal. Every culture had some or the other horn structure. And horn as a geometry, this cone is super efficient to create this simple idea of impedance mismatch, which is nothing but speech amplification. So my idea was, okay, can I create a simulation model where I can see the limitations of the geometry? What if I am saying I am amplifying speech? What is the max? So in a limited research, I just did it for 3 years, but I figured, like, okay, 2.4 meters is what I think is the limitation, and this 3D sculpt, like, I had to do somewhere around 60 iterations of the object, and afterwards I could not see any change in efficiency, and if I increased more, I would see decrease in efficiency. But anyway, so just the simple idea here is listening and listening through ears, because we have lost the ability. We tend to hear through our eyes. Another image of the bronze object. Now, moving on. Today, we have this information, but today, when we look at it, all these historic sites, the heritage of what we speak of, where we have spent this collective time, or we have shared experience, or we have a lived experience over time, these all sites are hyper local. I need to physically visit. Is there a way can we have this sort of a experience in a global sense? Convolution on the web allows us to approach that notion where we can have this experience in a collective sense. Like, the web audio APIs are super easy, super simple to approach, and we can just go about it. Like, a simple idea would be this is on the web, you guys can access it. This is a project I did as a part of art festival in 2017. So I guess I think my computer audio is mute. Yeah, it's on.
Yeah.
So this is
So
a
this is
super
super
simple.
simple.
There's a
There's a
latency
latency
because I'm
because
talking
I'm
through
talking
my
to my
computer,
computer microphone,
but
but
it's
it's
a
a
simple
simple
idea
idea
where
where
now we
now we
can,
can,
from
from
Bangalore, we can
Bangalore, we
just
can
go
just go
to
to
this
this
tiny
tiny
cave
cave
in
in
Revona.
Revona.
I
I
just
just
augmented
augmented
myself in
myself
this
in
tiny
this
cave.
tiny cave.
Or
Or
if I
if
like
I like
some other
some other
space,
space,
let's go
let's
to
go
a
to a
underground water
underground
tank.
water tank.
It's a new so this connection of these gateways
It's
Part of The the image what we see here is something what I call as Khan. It's I had access to roughly 800 human years. This was not, I mean, not organic human years. I mean the digital anatomy. It would be cool to have them, but yeah, I just had digital file. Mm, but yeah, so basically, if we look at humans and perception of sound, it differs. Like we have cultural specific perception of sound. Not all of us are uh, willing or being able to perceive certain sounds. Like for instance, Gagaku music from Japan is discarded by majority because of the pure nature of the microtonal existence, or like the way they approach dissonance. Uh, we like harmony, but at the same time, culture-specific people may move away from harmony and explore dissonance or microtonal. Here in Karnataka or Tamil Nadu, Carnatic music is there. Even they have like microtonal nature. Like they don't follow standard Western 12-tone scale. They have like their own 17-tone scale. Anywho, the roughly 800 human years I could examine, and this was across culture, like African, Caucasians, Siberian, Tibetan, Indians. And then you can write a simple software, like a simple script, which would compute average. How does an average human hear? Because the shape of my ear canal, the shape of my pinna would absolutely, definitely change my perception. The canal would add a resonating frequency to everything I am perceiving. So can we have an average of hearing? So something this I constructed in 2016, and after analyzing it for further, like another 5 years, I feel now comfortable, it's ready. So yeah, this data set is mixed using some really high-end microphones and the Khan, the microphone I built. But it's just the idea of augmenting yourself in time. Thank you. That's it. Thank you. Yeah.
I just wanted to ask, how did you choose the location within all these places of where you wanted to place the mic? Was there some kind of documentation that spoke about maybe that's where like people used to speak from, usually in that area, or was there some factor by which you decided where you wanted to keep the mic while recording the impulse response?
So while recording impulse response, there's no one absolute position. So while doing it, I do take like more than 100 readings. So yes, and I take a note, okay, now my speaker is center, my microphone is 5 meter off center, 5 meter center, 10 meters, depending on the size, shape of the room. So, but also I am mindful while gathering this data, because if I go to certain caves, I love caves in India. So many of the caves we saw like in 6, 7, 8, 9 AD, like this large 400 years, we saw like an influence of Hinduism, tribal Hinduism, mainstream Hinduism, Jainism and Buddhism, and this all spiritual belief of Sufi and Tantra and all those things. This created like a very pollinated area where you had this different beliefs acting in one place. So when the Jains and the Buddhists came to those caves, they used pitta. Like pitta is something like a teaching ground where the teacher would sit and students would like face the teacher. So this would meant if I keep my speaker over there, I can simulate a speaker. And if I rotate my microphone, I know the listener's environment. So there's no one position, but yes, I do keep a note. So if I do a installation or I do some like license it to some game or like I don't know VR thing, then these specific data sets can be tagged rather than an average.
Good. Thank you.
Hi, Akash. You talked about in the past people listened with their ears, and now we are listening with our eyes. I think it's awesome. So could you do you have any ideas about how they used to listen with their ears, especially that they didn't have the tools like you have at your disposal that you've created yourself and so on. When those tools, these sort of computer analysis tools were not available, how was their listening so acute and good that they could design these spaces?
A simple example would be internet is filled with like one very popular idea, which is anechoic chambers. If you visit them in 20 minutes, you feel uneasy and you have to escape it because you start hearing whatever. My experience in anechoic chamber is exactly opposite. Perception-wise, if I am visiting high mountains, early sunrise, it's absolutely zero reflection. I hear absolute silence. There's no wind. I am in a ridge. There's no reflection. Many caves are not really anechoic, but 3, 4 econic, like only 2 or 3 early reflections I would observe. So these sort of physical lived experiences we don't do. Adding on more, publicity, it's a super big business. Before this, all sorts of advertisement used sound as a medium. Image or language was not really like this image. I would say even the language in a printed form is an image because type is a great design. But all sorts of publicity was sound-based across culture. We had specific sounds related to specific skill set also, like the person who would refill your mattress with cotton created a very specific sound. Person selling, they all publicized with the sound. Now we create noise, but we also illuminate everything with LEDs or typeface or like hyper design visual ideas. So similarly, moving, biology also plays a role. When we were hunters and gatherers, we had to highly rely on our perception of sound, because if I am moving in a forest or a jungle, I have to be aware what's happening in my left, right, front, back, because it's bushy, wooded area, I can't really see, but I have to be attentive. I have to have acute hearing if I want to live beyond 30 or 20 for this matter. Now, I don't have that concern. Over the last 200 years, this concern is absolutely deleted. I am comfortable. I am cold, I can increase heating. So like this, we have so many these small factors which have trained us to not hear.
Coming to the matter of the hour, how do you sustain yourself?
I do a lot of things. So this, half of the time I get some grants from random institutions. I sell my microphone. I sell some synthesizer like Eurorack. I am diving deep into electronics. I'm enjoying it.
Who do you sell your mics to?
Mostly artists at the moment. But I feel the use case is super broad, but I market only through word of mouth. Or like, yeah. People who know me, they tell about others about me, and randomly I get an email saying, bro, I want a mic. I said, okay, cool. Give me 20 days, I'll send it to you.
I've seen you over the years, and I've seen that your model of working and sustaining yourself has been one year after the other, if I'm assuming it right, in the sense that you don't really save and, I don't know, or you don't have any, I don't know if you have an inheritance, but I'm just saying that do you ever get clouded by the fact that, this might maybe get difficult or something, or maybe there's no takers, or
I think difficult is communication. I think takers are definitely there because binaural technology is not new. I think it's all came out of a French paper from 57. Newman were the first individuals to develop their mic. It's a beautiful mic, but what differentiates between me and Newman is the canal idea, because for me, perception is hyper important, not just the technicality of stereo sound or this binaural sound. So just because of this unique factor, I think there are many takers, but how do I communicate to them? How do I reach? That's a very different business and a marketing idea. Second, the point of sustaining is, yes, it is definitely difficult. I am highly driven by certain ideas, but not all are sustainable. Earlier in the discussion panel we had, so in 2015, I had a program in Mumbai called Music Tech Sundays. It was running for 1 year, and it was awesome because I never had much of new audience, but whoever came for the first session, they kept coming for all the sessions. So it was like a super small, tiny, warm community. There were some people from the Mumbai film industry as well, but a lot of other hackers, tinkerers like me. And I had little support, like this one Indian audio company called Modi Digital, they supported me. Then Abbey Road Studio, London, they also supported me. But having good people to speak, you need to make them travel. That's super difficult. So that's the point, the feasibility is absolutely there, but sustenance is not really there. So what I do is I do 10 different things. I get some funds here, I spend over here. And it's total chaos. I am like a monkey with a symbol.
Hi. Hi, Akash.
Hi.
So to do with the point you were mentioning about how, in general, people have, people tend to listen less and visual is more, right? This is more like an observation, I guess. But what I feel is that difference in visual and auditory is seen in almost all multimedia industries. Like, I think anybody who's worked on films, the audio for films, it's like the last thing many of the times, right?
Yeah.
Including budget-wise.
Yeah. But that's, I think, education also. People are not educated to pay attention to sound.
So what I found was also, I'm from a tech background, and I'm not done that much music-related work, but at the initial stage for almost all the music software, excluding a few, the professional softwares, there's a lot of overwhelm when you try to do something a little bit beyond basic. There's just so many tools, so many visual cues and things at a professional level. I understand where it comes from, the legacy of actually having the hardware with you. But what surprised me actually at ADCx is, and at the Music Hacked, is there are quite a few visual people here. Their profession is visual, and they're interested in the music. So I feel there is a gap, at least in getting a lot of people into this domain, where the getting feedback audio-wise is instant if you know what you're doing, but visual feedback captures a lot of people's attention. So I was just wondering about how, is there any, what do you feel about the development in that phase? Is it stagnant? Is there scope? Just a curiosity question, I guess.
There's no real development. I think it's purely education. That's it. We have to educate ourselves just to listen and understand also the difference between hearing and listening. Alexa listens or Alexa hears? Do we know that for sure?
Thank you.
I want to add to the the visual versus oral thing. Ties into pretty much the hunter-gatherer example that you gave. 20, let's say 30, 40 years ago, right? There was not this much light pollution, and TVs were also non-existent. Today we go into bed, like we sleep like by looking at Instagram or some YouTube or Netflix or whatsoever, and somehow that overload of visual stimulus has somehow trained us to respond to visuals even more than sound per se. And the kind of sounds we hear on a daily basis is we've learned to trivialize it. It's mostly noise for the most part. You have to find a place to to actually hear natural sounds that people have always been hearing, like not less than half a century ago, and I think that's why visual has more appeal than audio, even though like on a survival evolutionary basis, like sound is more important.
I would add a little thing. There's an individual called Helmholtz. He coined a word in psychoacoustics called auditory roughness. Visual is more universal. Audio is not. Sound is not. As previous example, Carnatic music, you play it back someone in North India, they would hate it or say ask you to like shut it. That's purely is am I able to hear what's being played? No. So, but if I if I put a same rag or a tal text in the type or the script being used and put it across, I might not hate it. I might just ignore it. But if I play back the sound, I would hate it. If I'm not used to hearing that thing.
Don't you think it's visually true too?
Visually, it's easy to ignore. And it's easy to comprehend also. Yeah.
Yeah, hi.
Hi.
Just to add on to him, I forgot the book, but it claims that all senses are a touch-based senses. Visual is the least touch-based, whereas everything else is a touch-based sense. I'll share the book in the Discord when it gets created. But anyway, coming back, I want to ask a question related to your presentation. Have you been approached by conservation people taking your work, like say a monument which is being demolished for whatever reasons, or it's not so important and they want to conserve that? Have they approached you saying, okay, we'll use your research, saying, in our efforts to conserve that particular monument or a space or a cave or anything like that? Or did you think in that direction yourself?
Yes, I do. I work extensively with Indian department called ASI, Archaeology Survey of India. But we have to know ASI has no money. If India, we talk about heritage, there's so much, there's tons of it, and they don't have even a money to put a proper board stating, okay, this thing was constructed in 800 or 880, 780, 280. It just has one generic board which is heritage site. If you like deface or like whatever, some section, that's it. There's no name of the village or the place or whatever. But saying that, I was invited by this institute called Klingenthal Ostengam in Basel. They had a church which was built in 1400. So I had collected the data of the church earlier. So they used my data to restore the church. Now the church acts as a cultural space, but the attic of the church, we tried to make it sound the way it was. Because most of the time, this impulses, we can think of it as a snapshot of sound in time. We know how a structure looked like in 1900s from either a sketch or a painting or a photograph, but we don't know how it sounded. So if we can have a slight computational comparison, because ISO is so nice, they have released a list of natural decay rate of all the known materials. So I know limestone over a 500 years would decay in certain rate. Of course, humidity, temperature, human intervention, they all play a role. But I have an idea, and that is that change perceptible? Like if there's a 0.01% deviation in my data and the reality of limestone, so is that 0.01%, can I perceive it? Is that, what sort of a sound difference is it creating in absorption coefficient or the reflection coefficient? That's another question, because again, like there's certain laws, right? Like RT60, there's like tons of math and law which we can follow for our personal experience. So yes, indeed, but Indian government has no money. They do care. The ASI department is operated by like what, 6 people maybe, and that's it. Like it's super small, super poor.
In interest of time, we have to move on. And
Yes.
thanks, Akash, for a interesting.
Cheers.
Yeah, we would like to welcome Padmanabhan to present Orca Beyond Generative Music.
This is going to be fun. No.
So Zoom settings are already there.
Yeah, I haven't.
using the conventional tools and the other sounds that are there in the natural sense, in the natural space, and creating a language out of it. And then from there I went to this one, which is Brian Eno's music for airports. This again is another notation in some aspect for the sound or the music that he has created for this piece. This doesn't have anything close to what, am I still audible on the mic? Oh yeah. This doesn't come anything close to what Murray Schaffer or Beethoven did. That doesn't have any musical, the notations as such, which for me was very interesting in that aspect. So then my next question was, okay, we can maybe represent it in a very, experimental style and, very perceptive in that aspect, intuitive. How do you make this a performance? Like people play guitars and pianos and keyboards and whatnot to make like musical compositions as a live performative stuff. Like how do I create sound as a live performance in some aspect and, create that same immersive experience and narrate a story and, do all that. In that, I came across Orca, I guess. Well, part of it. What I understood of all of this was there was a small algorithm in some aspect for soundscapes, which was a set of patterned sequence of events with a controlled chaos or randomness. It's not always like you'll get these notes at these bars and such. There will be some randomness involved in the natural soundscapes, which are, well, quite controlled in the aspect of, okay, this depicts the sound of this particular, environment. But there is always this surprise that comes in with this. The most closest example I could think of is bird calls and bird sounds, for that matter. So then, with Orca, I experienced like we could patch it with different tools, different softwares that can synthesize sounds and that can use samplers and whatnot. And using Orca as a tool to control those synthesizers, those samplers to trigger sounds in real time for performances. And this kept me, had my interest going. For theater performance and such, and for dance performances, I began using Orca as a tool. But what is Orca essentially? Is, okay, what can Orca do? In some aspect, is this. Programming language in some aspect. Have validation error. And create soundscapes and create compositions. But yeah. Sorry. What is this? Okay. What is Orca? Before this, I wanted to show this. People can on. Yes. So since Orca can take in anything as an audio engine, you can connect it with your super collider, you can connect it with pure data, MXP, Max MSP, and such. I primarily use Ableton as one of my audio engines. Switch, right? Cool. Let's see if this works. This is like a small demo to show like what Orca can do and the syntax of it. So primarily, you guys are able to see the screen, right? Okay, clearer, I guess. So primarily, it is a sequencer, and you have these functions that these are the only functions and codes that are there in Orca, and it essentially runs, the entire program runs on these alphabets and some special characters. That's it. So you don't have to learn new functions or learn new syntaxes or such. and certain things have certain specific functions. Like T, for example, is a sequence creating tool where you can create how many ever sequences that you want. And then you can have a clock function, and then V for variable, assigning a variable and such. And then whatever value you add over here can be called back over here. So this kind of helps me quantize whatever that I'm creating in real time. And so right now I kind of made this using this logic, which kind of goes like something like this. And over here, oh, I forgot about this part, sorry. Over here, colon and whatever that I'm writing over here, this syntax is basically colon and sending MIDI signals to whatever program that you're patching into. And then the first dot, or the first thing, is the channel. So 0 is 1, 2, 3, 4, whatever, how many ever channels that you have. And then the next is the octave, whatever octave that you're having. And next is the note, whichever. And then we have the volume or the velocity and the length. This pretty much makes up the entire Orca's, interface in that aspect. So it's basically you're combining and reworking this language in a way that is flexible for you, using it as a mixing tool, using it as a tool for live performances and such. Keeping that in mind. Play around with live performances, and especially in theater and choreographed performances, where improvisation is part of the act, or becomes part of the act. This is just an example where I'm using like a very synthesized sound, but we can go ahead and use like samples and whatnot, play around with other tools and whatnot. Right now I don't think my laptop can handle that much. So yeah. So Orca, as per the website, is just like a two-dimensional esoteric programming language. It doesn't have a synthesizer in itself, but it can patch in with Ableton, Renoise, whatever. VCV also. Essentially a MIDI, anything that can take in MIDI, OSC, and UDP. Even if you have a hardware that can take in MIDI signals, you can patch it to Orca and perform through it. Some of the performances that I've used in the past is this small theater performance, experimental theater performance called Agents of Malarkey, for which we had like multiple projections going on, and I used Orca as a live mixing and performing tool. Another one is the story of Gargalian, for which I've used the sounds of the earth, like sounds of nature and whatnot, as the evolution of a planet, and that narrative was being built on through live coding synthesis. Yeah, this is pretty much it. Any questions? Thank you. No. Hello.
Okay, so there's a whole bunch of live coding systems. Why Orca?
Amazing question. Next question. I mean, you can use other tools for the same. For me, I found Orca very simple and interesting because, well, again, I'm not a coder or a techie in that aspect. For me, the compilation error becomes the hindrance in even learning a new programming language for that matter. In this program, you can pretty much code whatever, and it will either take it if it is right, or it will just let it pass. In that aspect, Orca is like kind of flexible. So yeah, that's why Orca.
No errors.
Huh?
No errors.
Yeah, no errors. Whatever error is very sonical, so you'll probably go tone deaf at some point. That's a different error altogether.
Oh, one more thing about the
Yeah.
error, right? So have you experienced anything like MIDIs being skipped? I mean, either or delayed, like because these are two different softwares, right?
Yeah.
So, like, and how do you, especially being a musician, how do you perceive that, right?
Yeah, I call myself computer musician for that exact point. I'm like, that's part of the improvisation. Let it be. Let the computer also, glitch and perform.
Right, good.
So, yeah. Hey, okay. Oh.
Hi, thank you, man. That was cool. I
Thanks.
have one question. Does Orca allow you to not follow time?
It goes by frame rates, frame per second, so it has some BPM and some
Okay,
level.
so it's
it
always
doesn't,
locked
it
in
doesn't have,
BPM,
yeah,
always. Okay, cool. Thank
it
you.
doesn't have like a timeless model.
Nothing in between, do you
Sorry?
think? Or does it only do notes and nothing in between or
That
something?
is, yeah, so I've thought about it, I've tried around with it. So I personally find instead of playing with Orca for it, I play with the synthesizer instead.
Okay.
If you detune the synthesizer, then it becomes detuned, right? Please don't.
He says it does OSC, so it can, in theory, play any pitch, basically.
Yeah, no, or any gesture.
Any gesture. Okay, cool.
Sorry.
Cheers.
Fine. Cooper Z everyone. Okay, thanks. That's it.
Can you play a 10-minute live concert on Orca?
Yes. That was the first question.
Do we have 10 minutes?
I don't think
Prashant?
we have time. Do we have time?
4 minutes?
Live coding from scratch. Let's see, it'll be noise, noise, noise. I'll be just playing this then. From scratch. Let's see. What? No. No. Let's see what happens. Errors.
was awesome. Hello. Yeah, thanks for that performance. And yeah, it was awesome. And these 3 days have been like really, really rewarding. And I just want to talk about the last 2 days that like not like a lot of you were there, but yeah, not everyone was there. So just some glimpses of the Music Hack Day. We had like huge participation, 13 hacks during the like over 2 days, lots of workshops. Yeah, just a second again. Yeah, so we had almost like 50 folks participating in the hacks, lots of interesting workshops, some modular synths, some hardware hacks, some software hacks. And like there were 5 prize winners and 3 of them are here to present their hacks as well. But yeah, right before that, I just want to showcase one small video with glimpses from the hack day. Let me share that again.
insane guitar solo by Slash. There's this one section where Axl Rose is going, where do we go now? Fun fact, that was actually because he had no idea what to do with the song once they were done with that solo, because it just blew his mind. For that, I'm actually going to get Ritesh on here to talk about problems that musicians face.
From a perspective of a songwriter and also music producer, the problem is usually we get into this creative block, like, where do I go now? You know, like you've written a melody and then you have like beautiful lyrics. It's, you wish you added just like 2 more lines or just this tune. Something is missing about it. Or sometimes you have it produced completely, like my current track. It's fully done, but at the same time, I feel something's really missing about it. So when I want to look for inspiration, right, like, what if I can get a song that's already out there that's topping the charts and just, you know, can I have like a few songs that are similar to mine that I can draw inspiration of? Or maybe I could have some generated music, you know, and maybe I could listen to a drum beat, you know, probably give a prompt, give me a drum beat similar to the audio that I'm feeding. And then I can draw off of it, or maybe a melody that I would really like to hear. And that is a problem we really try to solve as a team.
So what we did was we built a system where the user interacts with it by giving us a description of the kind of vibe they're going for, describing their goals for the song, ideally, as well as an unfinished melody or like a little snippet of the song up to where they're stuck. This system is then going to sit and scan your music and search for released hits that are sort of as closely sounding to your song as possible. And we're also incorporating a little bit of generative AI, conditioned by the melody or song snippet that you share, along with the description of your goal, to create several ideas that you can incorporate. Bit of a disclaimer, these ideas from the released hits are all from Spotify. They're probably copyrighted content. Please don't steal them. Not our problem if you guys get in trouble for that. Anyway, we've got a little bit of a demo for you. I hope the audio works. So as you can see, we're just running. So you hit upload, it does its magic, and there you go. So as you can see, we've got 3 songs from Spotify that sound kind of similar.
Don't fade away either. Why did you leave?
Hopefully the content's not long enough to get copyrighted. So yeah, that was basically a quick demo of what we built. Let me escape out of this. Yeah. There we go. So just in terms of the overall system flow, like I mentioned earlier, you're entering a little bit of a description about what you're going for, and you have the melody that you're stuck with. We're using the Cyanide API to get similar tracks to what your song has. That's sort of returning a Spotify ID that we're using the Spotify embedded player in our web app. We're also using MusicGen by Facebook, which is an amazing generative AI model to generate these ideas that we've put back in there. But yeah, in terms of future ideas, one thing that we were discussing is allowing musicians the ability to hum their ideas in, because you don't always have a fully fledged, like flushed out idea. Sometimes you just have a melody that you want to hum in. So this is something that we were thinking about, but all of these things were features we wanted to incorporate, but in 24 hours, you don't really have the time to do all of this stuff. Another thing was incorporating stem splitting. So the ideas that were both returned from Spotify as well as generated by MusicGen, the idea was to split these into the individual stems so that it really allows you to zone in on the instrument that you want to focus on. Another thing was identifying the regions within the recommended releases that are the most relevant and the most similar to your song. because you don't want to listen to the whole track. You just want to see that bit that's actually relevant to you. But yeah, I mean, we had a lot of fun working on this. Thank you for your attention. And if you do have any questions, we'd all be happy to come and chat right after the event. We have our contact emails up there if you guys want to hit us up. But thank you so much. Thank you.
So next up is Team Quilio. Is that the right pronunciation? Yeah.
That's a good question. I think I do, yeah. Let's just check. You have to join this meeting ID.
And now disconnect the audio here.
We are Team Quilio. My name is Abhishek. This is Ethan, and this is Sagar, my designer and my product manager. And we are a real-time software company. And today we'd like to share with you a little tool that we've made to try and help budding musicians generate jazz chords easily. So to start with, Ethan, why don't you take it away? Oh, sorry, Sagar, take it away.
Hey guys, I'm Sagar. I'm a product designer at Quilio. First of all, very good evening. I see a lot of tired faces. After, a long conference, let's talk some fun things then, shall we? So, as a musician, whenever the topic of music theory comes, I always vanish because I have no clue about it. Zero music theory, but I want to play chords. Or, you could have another problem like me, where I have a short, snubby neighbor, and he can't play jazz at all, because he has short fingers. Other than that, so this problem that we were facing, Syed had come up to us saying that, we would ideally, the problem was make a sequencer or chord generation machine, especially for jazz, because apparently he knew all about the music theory but couldn't play anything. So I would like to introduce you to Chord Easy. I know the name is like that. I have kept it intentionally Chord Easy because it makes chords easy. Oh, who wrote that? I'm hurt. But I'll tell you what it does. So Chord Easy basically lets you choose and audition notes that would, that if you play together, it would be harmonically, compatible with the root note that you choose for the chord. And you can play very complex chords with this, regardless of any, like, prior history with music theory, if you know anything. So, yeah, another problem that I faced when I was producing, like this little devil spawn that you can see, usually runs over my keyboard and messes up all of my MIDI notations. All of them, and it doesn't sound good. But then, today morning I realized if I had Chord Easy with me when this happens, it would have actually sounded amazing. As you can see, the cat is happy. Happy cat plays happy music. So let's understand what Chord Easy actually is. First, what do you need? You need a system with our VST plugin on it. As you can see, Quilio, big name. Then you need a MIDI keyboard to feed the root note to the system. And then you need a launchpad that we are using as an XY pad that helps in making chord generation be possible. Oh, and like how all good things in life are fleeting in nature, I'm gonna have to end our playful banter and give the mic to Ethan so that he can explain what's happening under the hood. Like, please come here before I say anything questionable.
Thanks, Sagar. So yeah, to restate like what he said about what the problem statement was, it was to be able to, wait, I forgot to introduce myself. So I'm a consulting product manager at Quilio, and this is the product that we worked on to solve the specific problem that he mentioned, which was if you don't know too much music theory, it can get difficult to create complex chords. So our hack over here is something of this sort, where we're using the launch pad, which is 8x8 grid of pads, and we're using that as an XY pad, where you hit any random pad after choosing the root note. You can add to that particular root note different different notes that are relevant to the scale that you set. So you have to set the scale. That was another thing to mention. And the closer the pad is to the initial pad that you select or you hold down, that is going to be far more relevant or compatible to the chord. It's going to create a chord that's more compatible or suitable for the root note that you have selected. So it's supporting it. Right, so as I said, the user first selects the scale in the UI, and after entering the root note from the MIDI controller that might be separate, you hit any pad and it plays the root note. That's the first thing that goes on. Then the adjacent pads become notes that when added to this existing chord, at the moment it's just one note chord for that matter. If you add the next chord, the next note, it'll become a dyad that is harmonically compatible with the root note. But if you choose a pad that's further away from the root pad that you've selected, it's going to be far less harmonically compatible. And what this basically allows you to do, intuitively speaking, I mean, from a user experience point of view, is that you can create simple chords if your pads are closer together. But if you want to make complex chords, all you got to do is stretch your fingers a little bit further apart, and then you get far more complicated chords that are still suitable for what you're playing with the lead or the root note at that point in time. And yeah, so I'd like to sort of explain a little bit about how this is mapping the notes per se, right? All right, so I got to rush through this. But if you can see on this, I won't explain specifically the nitty-gritties. But you hit the root note right in the center there on the left, as you can see. And you may want to choose maybe like the next pad right next to it. And what happens is that happens to be the third, because that's the mapping, the algorithm that we have created that actually maps that to different notes in the scale that you've selected. And yeah, and you can like basically build your chord as you go. And the thing is, it's dynamic, wherein based on whatever pad you last selected, the mapping changes based on that. So you can explore different voicings. You can explore different inversions as well. Yeah, okay, cool. Right. So I'm just going to explain the core concept over here with respect to like theory. What we do is basically select the root note, and then based on the scale scale notes that are available, we sort of add a metric to each note, and we arrange it based on that metric, where if you add that note to this chord, how musically compatible it would be. And then, like for example, if you've chosen E, that's like your, in C major, that would be the minor third, that would go there. And then, yeah, the wrong is there. Cool. Yeah, and then so on and so forth, because like then you can choose. Cool, 15 seconds, guys. You can clap in 15 seconds. Yeah, I mean, I think you'll get the point. So I think we can like wrap it up over there. This is just exploring stuff. Cool. So that's Quillio, by the way. We make music, real-time music software plugins for this, for that matter. And yeah, thank you for your time.
Are we good to end it? Or?
Yeah, so next up is Suhit, who built a game called Fly by Ear.
Hi everyone, I'm Suhit, and I worked on this audio-based game called Fly by Ear, which aims to be accessible to people with visual impairments. So this was there was a prototype that I earlier made with my friend Akshay Bharwani, which is available on the web, and I'll share that link with you guys. And that is made that's to be played on a computer or laptop keyboard. So I thought for the hack day, I would adapt it for the smartphone because it's a flying game. And I thought it would be fun to be able to navigate this game by flying it like a pilot would. So it's like a skill-based game. So I'm just going to explain what the game is like. Keep in mind that there are no visuals whatsoever. And it's a little strange because I'm going to explain it with visuals. So you can imagine yourself to be a player that's flying in space. You're moving forward at a constant speed. And from yourself, you're emitting a pulse. And based on your altitude, the pitch of the pulse increases or decreases. So if you fly up, the pitch increases, and if you fly down, the pitch decreases. So you get to know, get a sense of where you are in your altitude. Eventually, in some time, you'll start hearing another sound, and that's a sustained sound, and you can imagine that to be a tunnel in the air. Because that tunnel is floating at its own altitude, it has its own pitch. So I think you can see where this is going. The basic idea of the game is simple. Using just this audio-based information, you need to try and fly through the tunnel, and that's the basic objective. And in order to do that, you basically need to match the pitch, and then it'll probably play through your right or left earphone. So you try and center yourself in front of the tunnel, and if you do that correctly, this looks really scary, sorry, this is something that I had to just do quickly. I'm terrible at digital, any kind of visual art. And if you do that correctly and line yourself up correctly, you're just going to fly right through, and that's your basic objective of the game that's succeeded. The larger objective of the game is to be able to fly through as many of these tunnels as possible, because you have like an energy system or a fuel that keeps running out over time. And in order to recharge your fuel, you need to fly through these tunnels. So it's a game where you try to see how far you can go without running out of fuel. So I'm just going to do a quick demo of what I came up with yesterday at the hack day. And I'll run you through it as it plays. Yeah. Okay, so there you can see there's no visuals on the phone whatsoever. And okay, I've also done a little bit of sound design because in the previous version of the game. And that's someone running off a cliff, spreading their wings and flying. Okay, we should start hearing that, which is the player's pulse. So you can see that I'm tilting the phone upwards and the pitch is increasing. And if I tilt it down, it's decreasing. So that's how you get to know how high or low you're flying. Okay, and in some time, you should start hearing another sustained sound, and that's the tunnel floating towards you. Okay, I think you can start hearing another softly. It's gradually coming towards you, so its volume is increasing. And it's at a lower pitch, so I'm tilting down. And that indicates that we are roughly at the same altitude as the tunnel. And I guess this is really tough to do. I need to make it a little easier. But I think you can also tell that it's either to the left or right slightly. And I've passed through the tunnel correctly. That's the sound that indicates that I've passed through it correctly. Okay, the next one is a little higher. So I'm starting to tilt up to go higher. Okay, I've reached the same altitude. And it must be playing more out of this speaker because it's on the left. I'm still pretty bad at this, but I think I'll just about make it. Okay, I just made it in that one. So basically we are using this audio information to try and localize ourselves. Let's see what happens if I don't make it through the tunnel. And you can see that the next tunnel is at a lower pitch and probably playing off the right or the left. I forget which one. I think it's that one. And I'm just letting it go. And that means I've missed the tunnel. And you can also see that my pulse has increased in pace, which means I'm running out of fuel. So these are indicators of all the information that you need. And I've switched on something called a guidance system for people who aren't so familiar with music, it's like a shooting down pulse, which helps guide you towards where you need to go if you're not that pitch perfect, I guess. And yeah, I think I just barely made it into that one. So that's pretty much the game. I think the next tunnel is at the same altitude, that's why it's continuing to ring. But yeah, if I tilt up and move away from it, you can start hearing the guidance system once again say, there you go. It's going downwards to tell me that I need to go downwards. Yeah, so that's pretty much the game. And sorry, I don't know why it's playing again. I'm trying to go to the next slide. Yeah, okay. This is a desktop web prototype. If you guys want to take a picture, I didn't put a QR code because it's not playable on the phone. So please play it on a desktop, and please make sure that your left headphone is on your left ear and the right one is on the right. Otherwise, you're just going to run out of fuel very quickly. Yeah, thank you.
All right, everyone.
Actually, need to join the Zoom link as well. You should have done that. Go ahead. Do you have it? Yeah, yeah. In order or not? In this one?
How is the energy? All right, how is the energy? So it has to be louder than the afternoon version. The first version was decent, the second version was slightly better. This has to be the grand finale. We will go for dinner. All right, so one more time. Again, just to make sure that we build the audio ecosystem together, and in that spirit, let's all come together. Okay, 1, 2, 3. Yep, so it's going to happen. Yep. All right, so basically it's a quick wrap up, just giving you some information about where we are at and what some action items are. First of all, thank you so much for taking the time. Before taking the picture, I talked about the emotional moment, but I think this would be the actual one. Yeah, so basically story time. How many of you are musicians here? Okay. Any of you basically who does like music composition? Okay. Yeah, so basically my story is moving from a mechanical engineering into making music, and that is a drastic switch. In my head it was, and the surrounding of me also used to think that's the same way. But the more I met people like you, the more I realized the story is the same. It's just that I was not aware that you all exist, and now I do. My aim for the last few years has been to make sure that as of now, somebody who looks into 2024 does not feel the same. It should be like, hey, we are all on the same page and we'll build things together, and we will come together. Yeah, we'll figure something out. We'll do some stuff, right? And the only way to do that is to just go to people and say, hey, you are not alone. We'll make sure that we figure out some stuff, and we'll plan, we'll host events. If you are like planning a startup, we'll help you find people. But at no point should you feel like, oh, that's a drastic switch, right? So I'm going to cut short of this story and just quickly go to looking into the future. One of the discussions that we had during the panel's discussion was that we need to figure out a way to connect people together, because in India nothing exists as of now which is recurring. It's not actually true. Music tech community has existed since like 4 or 5 years now. Manasvi, Siddharth, Ajay, Alvin, everybody has been putting so much effort. It's just that it was never visible. So much so that I found about them in 2022. I went to the musictechcommunity.org website, and it had like some social media links. From there I found some of them, and then I DM'd them, and funnily enough, some of their usernames were not exactly their actual names, so it was tough for me to figure out, are they them or am I spamming somebody else? But then I reached out to them and I said, hey, I am also in the same headspace as you are, let's do something. But we could not do something at that point of time. And the next time I was at ADC, I met the ADC team, Bobby, Tom, Derek, Andrew. We all basically were discussing about how do we enhance the audio industry all over the world. And I was like, hey, you know what? There are people in India who would love to have this. There are people in India who would love to come together and do some stuff. And the first answer from them was, yes, let's do it. And I was amazed. I was like, okay, this kind of support, I'm not used to this kind of support. The background I'm coming in is when you switch from mechanical to music, you get a lot of backlash, right? So this is the kind of culture that we need to build, and I think we are all on the same page about that. So the first thing that we'll need to do is to help out new people. So ADC already has a mentorship program. So if you go to the ADC website, I'll keep the QR code again. I'll just show you what the website is. You can actually see that you can sign up as 2 members. Either you can sign up as a mentor or you can sign up as a mentee. You won't believe there are so many mentees from India looking for mentors. It's just that they have not been connected. So the form is closed right now, but it will be open pretty soon. So whenever that opens, make sure, if at all you want to spend like a month with like any of the person whose life you can change, it's just as simple as that. You sign up. The team will basically make sure that they map you with a mentee in your time zone, and then you can help them out. It's as simple as that. Now, how do you know if the form is open? Because you cannot keep checking this website every day, right? So for that, there is the ADC newsletter. You basically sign up on the newsletter, and as soon as we have the next ADCx India event, we have a Music Hack Day India, we have anything that is related to your area of interest, you'll basically get notified. Also, the mentorship program, whenever it is active, you'll get notified. The other thing you can do to make sure that other people learn and actually get the visibility that this is not a niche domain. I hear this a lot. It's a niche domain. Look at the crowd here. And we had even more people because like a few hours ago, right? So it is not a niche domain, that's a myth. And I think we need to make it more public. And the way to do it is just by making people aware. So the ADC YouTube channel has all the things. This live stream that is happening right now is also available here. The videos will be edited and also placed on the same channel, and you can also see a lot of past things. Again, if you want to get involved more into Music Hack Day India, there's musichackdayindia.github.io, which you can check at any point of time. And if we are doing anything, like even if, let's say, there was some suggestion of, hey, we should do more regular meetups. If we do that, you'll find that here. We will make sure that the website is up to date, you don't miss a thing. And then there is also the musictechcommunity.org, which is basically the group of people, these awesome people, who basically have been doing this stuff for a long time and are also the ones organizing Music Hack Day India. So you will find a sign-up form here as well. There will also be a Discord link in a couple of weeks, definitely for sure. And that will be one of the first steps that we will take to make sure that everybody is coming together, right? So these are some of the things that I want you all to be aware of, and we should together make sure that everybody else who even is doing it as a hobby is aware of, right? It's 2024, yeah, the things have to change. So I'll keep this slide active for a few seconds. Just in case you missed, the website, the URL is pretty easy, audio.dev/mentorship. The next thing is audio.dev/newsletter, and then youtube.com/audiodevcon, musichackdayindia.github.io, musictechcommunity.org, and yeah. The reason I'm rushing through because you can always rewatch the live stream and you can scan stuff. Yes? I will do it, yeah. Thank you for reminding that.
Also for Music Tech community, I think we are lazy updating the website, so social media is the better place.
Yeah. And if any of you want to help in that, please reach out. We'll make sure that you're also part of it. And again, some of the ideas that we can do as a community that we already discussed today, academia, do more catch-ups. Again, you don't even have to have somebody to organize an event like this. You can just find people in your city and just do something on your own. You can have some hackathons, you can have some local community things. Anything basically to keep the streak going. We have to make sure, and this is the good time. We are starting off the year. It's the first week of the year. Is it? It's somewhere like first week. So, oh, it is the first week because the 1st of Jan was Monday. So yeah, it's still the first week. Yeah. So yeah, it's a good start to the year. Let's just continue the streak. So we will send email to every one of you because we have your email addresses. We won't spam, but we'll send this information where you can give us the feedback. What did we do right? What did we miss? Because we know we have missed a few things, and you guys might have better suggestions. You can give your feedback. And again, like we mentioned, the Music Tech website will also get updated. There'll be a Discord link. All of those information we'll send to you as soon as we have that ready. So it's the most important time to thank all of our sponsors. Juice, Tom is here. Pace, Bobby's here from Pace. Then we have Sharat somewhere in the crowd from Dubverse. And we have Kaushik and team from Embody. Thank you to all of our volunteers. I'm sure you have met most of them, but there are chances that you have not met some of them. And I'm not sure if you'll get a chance to interact with them because you'll probably are hungry and you go to some restaurants and you'll probably get distributed. I want to take this time to mention specifically what each of them does. That way I'll also remember in the future, but it should give you visibility. So Sangarshnan is an amazing techie guy. He is working with Siddharth in Beta1.ai. He's amazing. So anytime you want to like geek about some technical stuff, just you can always reach out to him. There's Pradeep Matthew, who knows MATLAB. If you need DSP stuff, just reach out to him. There is Ali, who is, I'm embarrassed, he's born after 2000s, and he helped almost every team during Music Hack Day India, which I could not. So I'm very jealous and envious of Ali. But he's an amazing guy. If you can find him here. Ali, are you around? Okay, he's like a backbencher. Yeah, so definitely meet him. Jose, who is doing a lot of interesting stuff in physics. And yeah, so if you want to talk about acoustic stuff, definitely meet him. There's Govinda. So in the Music Hack Day, the first presentation was done by Govinda, and he's a violin player. He had a concert, so he had to leave early. But in the presentation, he played the melody of Vande Mataram. And we were like, yep, you have set the whole vibe of the event. So yeah, like just meet Govinda, especially if you, Govinda's right here. If you want to listen to him play violin, yeah, just ask him. And then we have Karthik and Samriddhi, who are also exploring. So one of them is an architect, and they are kind of trying to build some kind of acoustic spaces where people can actually move around and experience some interesting stuff. So again, definitely reach out to all of these people. They'll be here. You find them with a blue tag. And yeah, if you need their contact details, just reach out. We'll share them with you, and I'm sure they will be okay with that. Yeah, yeah. And again, thanks to the organizers. And you need to know this about Manasvi. How many of you have met Manasvi? Okay, if you haven't, you do it. And I'll bet you, when you have a conversation with him, the number of tabs that you have open in Chrome will just keep on increasing. In every 2 sentences, he gives some information that you feel, oh, I did not know this. And then you Google it, and it was released 1 day ago. So he's so up to date about this. So that's Manasvi for you. There is Ajay. Where is Ajay? Ajay. So Ajay is basically taking all the effort to build an ecosystem for decades. I mean, that doesn't make you feel old, but so he is not only appreciating all the events like this that happen, but he also interacts with universities and makes sure that if there is a program happening, he'll be involved in that. So look for any audio tech event happening in India, and in the organizers list, you'll find Ajay. I can guarantee you that. And then there's Siddharth Bharadwaj. He is one of the first AI company, music tech AI company in India, and he's extremely helpful when it comes to answering you and giving you suggestions. And this is a fun fact, he's the CTO of the company, so I asked some of his friends, some of his colleagues, how is your boss? And they said, who is the boss? And basically, it's like a really good vibe that they are setting up in India. So it's not just a music tech company that's setting up in India, it's also a remote working company, and it's also a company that has a good work culture. So we definitely have to applaud him and his team for that. And finally, we have Albin, who traveled all the way from Europe to here just for this event. And we did not have to convince him. So I just asked, when are you landing? He already had an answer. So, and he has been another person who was involved with Essentia, and during Hack Day, many people reached out, and I think there will be people bugging you even after the event. So thank you so much for all the effort. So yeah, that's the organizers. Please, round of applause for all the organizers.
Also, thank you to Prashant, who audio developer, ecosystem creator, game developer, maybe stand-up comedian as well.
Yeah, some jokes land, some don't. Anyway, thanks to the ADC team. Bobby is here, Tom is here. There's Andrew. Andrew basically runs Space. And again, so basically when I had this conversation about bringing ADCx to India, there were 4 people there. Bobby, Tom, Andrew, and Derek. And it was in a pub. And all I had to say was, we want to do it, and they were just saying yes. So thank you so much, Andrew. I hope you are watching the live stream. So shout out to Andrew for that. Thank you to Ralph. So everything that you see in the design, all the amazing rangolis and all the designs, it's completely done by Ralph. So shout out to Ralph for the amazing work on that. And then there's Derek, who also influenced the setting up of this event, and he's also the person who runs the ADC mentorship program. So if you sign up, you'll definitely get to meet him and get to know more about him. So round of applause for Derek as well. Sophie and Jim are basically the people who run ADC and the main event, and all the logistics, all the live streaming, all that effort they do. It has been one of the reasons why the events keep happening, and the reviews and feedback has been amazing all throughout the years. And this year, in 2024, ADC is going to be in Bristol in November. You can check audio.dev for more details. And yeah, what else is there? A huge thanks to all of you. Because again, the community is the people. We can try efforts, but unless and until you all participate, it's just going to go away. So a big round of applause for yourself. Yep. Thank you so much for taking the time. And with that, we'll wrap.